Check. Check. Testing.
Is it 9 yet? We should at least give them,
I'm giving you.
at least give them a warning, a 1-minute warning or something. They can come in here.
It's now 9 o'clock.
Good morning, everybody. Welcome to Arlington, Texas. Let's see who's driven the furthest today. Anybody drive farther than Oklahoma City? Piedmont? Okay, there you go. So we have somebody from Piedmont. How many people are from the Oklahoma City area? So we have a few. Okay, good. So we appreciate you coming out today, and this is casual day. So, you know, it's going to be a fun casual meeting today. We have some good presenters, as you can see, coming up. So it's a really interesting presentation. So we hope you enjoy it. And then Kim, you want to tell them about the coffee and so forth?
Just a few things as far as like logistics. The coffee bar is out of the sanctuary to your right, and there's coffee, tea, water. I just say please be cognizant of your cups, and they do have lids out there for anyone who has drinks in the sanctuary area. So please use those when you can. And also the men's bathroom is to your left around the corner, women's to your right around the corner. And we're just so excited y'all are here today. The most exciting is welcome to everybody who's watching right now, live streaming, first live stream of TESSA. So very excited about that. And so welcome everybody. We're glad you're here and joining us for this wonderful conference. So you ready for me to introduce Jennifer? Or?
Is Jennifer ready?
Yes, she is. Okay, my name is Kim George, by the way. I'm the conference coordinator, and I work with Martin, and this is my 10th year with him in TESSA. But we're excited for you to be here, but more importantly, I'm excited about our first speaker, Jennifer Dunn, who has been with TESSA for a long time, but this is her first time to do the keynote speech. And I'm so excited. We have a meteorologist who's the WCM of the National Weather Service in Fort Worth. And she's done a great job as far as doing everything. My phone went off, sorry about that. One little glitch. So we're excited for her to be here to present to you this wonderful talk that I've been looking at the slides. It's going to be great. You're going to just be so well informed. And she does an amazing job, not just with this, with TESSA, but if you've ever gone to her spotter classes, she's amazing. And she's just has it down pat, and she does such a good job. She entertains you and tells you all about weather without it making boring at all. So anyway, Jennifer Dunn.
Thank you so much. That's such a nice introduction, Kim, and I'm so excited to be here today. I was talking with Kim and Martin earlier. This being here and being the first speaker, the keynote speaker, is kind of full circle for me right now. I was thinking it was 20 years ago that I first came to TESSA as a student in college at Texas A&M. I won a prize. I won the Al Muller's Vortex tube. Actually, the hose, the piece of hose, it was his vortex tube. It was my first time. At the time, I had just started working for the National Weather Service as a student intern. The gentleman that hired me is here. I met Martin. Martin then brought me on his chasing group at Tempest Tours. I met Bill Bunting, who then hired me after I finished, and now, after being here presenting on a couple of other topics, I'm here being the first speaker of the morning, which is just incredible to me. So I'm so excited to be here. Thank y'all so much. Oh, y'all are so kind. So I didn't really know what to title my presentation today. When I normally do with kids, I usually use Dr. Seuss. Say, can you say what's the weather today? Yesterday, I used Snoopy, You Can Be Anything, because I was talking about you can be a storm spotter to a group of American Meteorological Societies there. So I wanted to draw on some stuff that how we all can work together, but I also have a couple of tools that y'all might be interested in that I want to review or kind of pull out for you there. So if we'll go ahead and go to the next slide, please. I'm going to have to hit next each time. So first I want to talk about the importance that storm spotters and storm chasers play in the larger group of what we call kind of the integrated warning team. Whenever we have severe weather in particular in the area, we have four main groups. Now, there are other ones in there too, but we have four main groups that help kind of disseminate and flow information through what we call the entire public safety enterprise. Of course, we have the National Weather Service doing the radar analysis, sending the information out, taking your reports, making adjustments. The media is doing a lot of the same things, but we know that a lot of people turn to the media whenever there is weather going on, so they really help us as message amplifiers and distributing that information, which of course you'll hear from David Finfrock here in just a little bit. I saw him sneak in, there he is. Emergency management and that public safety sector on kind of that public government side plays a big role also. A lot of times they help us prepare and respond to disasters. They're focusing in on their community, and they're using your storm reports too. And so if you go to the next slide, our storm spotters and chasers play a very integral part, making up a big chunk of that pie also there, to where the reports that they are sending, your real-time reports when you can safely do so, those ground truth reports play an integral part in helping us make warning decisions also. We're going to talk about that here in a little bit, but the reports that you make are visible not only to the National Weather Service, but to our partners in the media and in public safety emergency management also. I'm going to talk about that a little bit here too. And then again, those timely and accurate reports help us make informed warning decisions, and I have a kind of a specific example of that hopefully will help drive that home here in just a little bit. So we can go to the next slide, please. So safety has to be your number one priority, and I really want to emphasize that. A lot of times we can find ourselves close, too close, accidentally close, but we need to remember that safety has to be your number one priority. We do appreciate reports after the fact, as long as you give us the correct time. If you're able to safely do so, those real-time reports, though, are invaluable to us. Our spotters and chasers in that community are serving as our eyes and ears. While the meteorologists are in the office, I make this joke, we're in the office doing the radar analysis. I only have 2 windows out of our operations area facing north. I can't really be anywhere else, neither can our meteorologist. So y'all kind of become those eyes and ears out there giving us that valuable information. Communication, whether it's with your team or directly with the National Weather Service, is crucial, and knowing what those communication methods are and also the various backups, but the various thresholds to report to different teams is important also. So next slide, please. Okay, so why your reports matter. I'm gonna harp on it one more time. The ground truth is a lot of times the missing link, or the link that we are looking for to validate what the tools we're using at the National Weather Service are using. We have powerful tools in satellite, radar, automated weather stations. Our weather models are getting better, but none of those are exactly gonna tell us what's happening on the ground. It could indicate large hail. That hail could be melting, and it could be falling as smaller hail by the time it reaches the ground. The tornado is actually, the radar I should say, is never actually really, at least our 88D, is really gonna sample the tornado itself. The radar starts at 90 to 100 feet up. So we need that ground truth that there's contact with the ground there. So the reports that our spotters and our chasers and all the public can provide assist us with warning decisions. There's times where we're sitting there wondering, the radar's telling me this is happening. Is it really happening? And then what is happening, or like what size hail is falling. And so we're wondering sometimes if we don't get reports, do we need to continue the warning? Should we cancel it? Do we even need to issue a new one? And then we'll get that confirmation in, and that gives us the confidence to know exactly what we need to do with those warnings. We also can tailor our messaging and update information for those who are in the storm's path there. So this could be telling people that your hail has increased to baseball size now. And if you're still outside for any reason, you need to be inside taking shelter. Or you need to make sure that you're away from windows, from any type of wind-blown hail that may be happening there. Or tornadic situation. There is a big difference, social science research tells us. There is a big difference between saying radar observed and confirmed by somebody. People are more prone, I see a lot of heads nodding, perfect. People are more prone to take action faster when they know that it is verified and confirmed, because that's one of the steps people have to go through before they take action. So if we can say it's confirmed, or we know we have reports it's happening, hopefully they're taking action and shelter faster or quicker whenever there is threatening weather in the area. And then, as I said, your reports too, on the public safety and public sector side of it too, is driving safety response actions, whether it's sounding sirens, putting up barricades. They're amplifying their message too to get people in safety, maybe out of their parks, off the ball fields, soccer fields, any of that if they're still out there for any reason. Whatever those actions look like on the local level, they're helping to implement those based on that too. Next slide, please. So reporting musts, this is obviously a lot of what I talk about is from the National Weather Service in Fort Worth, but you're gonna probably find very similar criteria across the country, at least across the southern and central plains too. So when it comes to hail, we like penny-sized or larger, so 3/4 inch is what I was trying to get there, 3/4 inch in diameter or larger. Damaging winds, a lot of times people try to estimate what those wind speeds are, and it usually results in an overestimation. If you have a handheld device that you're using, you can measure it and send us that information. But with spotters and chasers, I really like to emphasize, focus more on describing to us what was damaged. We'll go in this a little bit more here, but describe to us what was damaged, and we'll usually be able to make better wind speed estimates off of that. Remember too that if you are estimating 60-mile-an-hour winds, unless you are over an open field somewhere, which does happen, but otherwise, if you're estimating 60-mile-an-hour winds or you think that's what's happening, there should be some type of damage, a little bit more notable damaging happening with that. We take flash flooding very seriously as it is the #1 killer among thunderstorm-related events. So flash flooding is rapidly rising water into areas that typically don't flood. So your areas, not your common trouble spots, but now we're starting to rise up to levels maybe that you haven't seen before, where people need to take action to protect themselves. So sometimes this results in, or one little threshold we can use is about 1 foot deep, but sometimes you're getting bigger impacts at less than 1 foot also. So I'm gonna come back to that one too in just a little bit. We're gonna talk about each of these a little bit more here in a second. And then of course we need to know about any indication of a possibly developing tornado, whether that's rotating wall cloud, developing funnel cloud, or of course, an ongoing tornadic event, when you are able to safely do so. Next slide, please. All right, so I wanna go a little bit more on the flooding. So being able to call us and tell us that it's flooding is one thing. But as a spotter or chaser, how can you provide more information to the National Weather Service, a better report? And we usually categorize it as answering 3 questions of flood magnitude, flood frequency, and floodwater behavior, in a sense, can really give us at the Weather Service more information to understand what's really happening with flooding in your area. So with flood magnitude, it's as simple as answering the question of how high is high. Now, I'm not telling you to go into the water and find out or measure how high is high or how deep it is. We don't always have these nice flood gauges too, but you can probably, while safely staying outside, you can look at probably objects around and get an idea, whether it's, bushes, shrubs, fences, cars stuck in roadways. You can probably get a pretty good estimate of how deep that water is by staying out of the water and giving an estimate that way. Flood frequency can actually be a pretty good measure for a National Weather Service meteorologist also. So at our office, we cover 46 counties across North and Central Texas. I don't have a map of it. I don't think I have it in this presentation today, but 46 counties. It is impossible for me to know everything about every road in those 46 counties. But y'all are the local experts in where you live, where you drive to work, where you go for recreation. You know where those trouble spots typically are, and you probably know when it's getting worse than that, when it's at a level of something you haven't seen before or you rarely ever see. So use that expertise and tell that to us when you make a report too. Reference it as, this is something I haven't seen before, or I've only ever seen the water this high, a few times in the 10 years that I've lived here. That's gonna speak volumes to us and let us know that something bad or something worse is going on here. And if we need to investigate more, we will, but the information that you provide may be enough that we need to upgrade or change a warning and tailor that messaging there. And then what is the water doing? Flash flooding usually is swift-moving water. People underestimate the power of fast-moving water. And then usually, once it's kind of standing still, is after the flash flooding has kind of ended, everything's kind of settling. Still dangerous to go into the water, but that's where we're kind of waiting for it to drain off. So swift-moving, fast-moving water is going to be usually more indicative with your true flash flooding when it's going on. Next slide, please. All right, so let's talk a little bit about hail. Everybody here probably knows how to measure hail, but just in case, we're gonna review. We have some young folks in the audience. They may not have had the experience yet. So let's go ahead and just kind of review here. So we know that hail does not fall in nice, pretty round shapes. It usually falls in oblong or what we call spiky type shapes. So when you are measuring hailstones, make sure that you are measuring across the basically across the longest length there, from spike to spike. So it may not be exactly through the diameter. It's probably going to be pretty close, but it might not be exactly through the diameter. You just want to make sure that you're measuring that longest length. We're not averaging it. We're not measuring the circumference around, but we're measuring that longest length. And then hail often falls in different sizes, and so you want to make sure that after the hail has stopped falling, then you can go outside and collect hailstones, pick up your larger size hailstones, and make sure that you're measuring those across that longest length. You can still report as it being a mix of sizes, like penny to golf ball, that's pretty big, but a pretty big range, but penny to golf ball, know that we're gonna write it down as golf ball size. And then in the notes, we may say that it was penny to golf ball size hail. So quick story while we're here. Kind of to explain the importance, one, of measuring the longest length, but two, how ground truth provides is actually crucial. So I remember working a day, and as an Aggie, this is a very tough story to tell. You'll find out why in a minute. I was working one day, and we were estimating, I think, penny to maybe 1-inch size hail in a storm. Pretty innocuous storm, not doing much. It was cold aloft. We're going to have maybe a little bit of hail, not expecting it to really kind of be close to severe. So we get a call of longhorn head size hail. Longhorn head shaped hail. Yep. As an Aggie, it was said maybe one of the worst days in my career. We're like, there's no way. Like, what? No. And they said it was 2.5 inches. 2.5 inches, longhorn-shaped hail. What are you talking about? There's no way. This storm has 1-inch hail. It's like, it's all right, I got a picture. Perfect, got a picture. Sends it over, 1 inch in the middle, 2 spikes going out at the top, 2.5 inches across from spike to spike in the shape of a longhorn head, which I'm going to choose to call it Molly from Fort Worth Longhorn, right? But that shows that value. I mean, he was a trained spotter too. He knew exactly what we were looking for and how to measure it and then how to report it to us too. But that ground truth. And so I don't think we upgraded the hail size because the storm was coming down, but we had to write that down as 2.5-inch hail for that storm, and that's what went in the monthly report. So longest length across, largest size hailstones, obviously when it's safe to do so. I know from a fact that even pea to half-inch size hail hurts when it's falling. Think of how high those ice stones are falling from at 100 miles plus falling out of those storms there. So next slide, please. So when we talk about reporting hail, we're getting a lot better of not reporting marble-size hail. We hear it every now and then. Marble-size hail, so you can see and kind of see the animations, unfortunately, aren't going to work today, but marbles come in different sizes. I make the joke that sometimes when we're chasing, we lose our marbles for a little bit too. So we want to stay calm, but we want to make sure that, so marble-size hail used to be half-inch is what it equated to. The new criteria for half-inch is plain M&M. Plain M&Ms are half-inch size, so perfect reason to keep plain M&Ms always with you. Have them as a snack. Keep a few on the side in case you need to measure or reference, but have a little bit of candy there with you. We still tend to get a lot of pictures of just hail in hand with no context with it. No measurement, nothing next to it. So it's very difficult for us when you send us a picture of hail in your hand to actually know what that estimate is. As you can see here, I'm gonna guess it's a male hand. Sometimes it could be a female or a kid's in what we've been looking at. This one kind of has the hand cupped, not laying flat, so we play a game of trying to measure sometimes in the office and figure that out. And that's taking away time. So it's better to do what's on the right there, either send us the actual measurement if you're going to give us a picture of hail in a hand or hail laying on the ground, or lay one of these more common household objects that we're used to having around with it, or just use the ruler, send us the ruler picture there also too. So try to get away from sending us just pictures of hail in your hand, at least without any context to it. It's highly likely that we may try to guesstimate, but in the essence of time, we're probably just gonna push that report away, at least for the time being, and go on and look for something that we can get a better reading on from there. Next slide, please. On the wind damage spectrum, remember once we get to 60-mile-an-hour winds, that's a specific criteria, or 58 technically, but about 60-mile-an-hour winds, that's where more notable damage starts to happen. And so that's why we issue the severe thunderstorm warnings at 58, 60 miles per hour or more. But kind of doing just kind of visual reference of what some of this looks like, at 30 miles an hour, 30 to 50 is about typically what we have with majority of our thunderstorms here. You can still knock over, especially unanchored background play equipment. Yes, trampolines can fly at less than 60 miles an hour. They can end up at roofs, especially the ones that aren't anchored, and it doesn't have to be caused by a tornado either. But we're gonna look at, when that happens, you wanna look to see what else was damaged around the area. And if it wasn't really anything else, the winds were likely less than 50, 40 miles an hour. But we start to break kind of smaller tree branches when we get up to 50 miles an hour. And then as we cross into that close to 60 miles an hour, you'll notice we have larger tree damage. Sometimes trees snapped, longer limbs broken off. On the structural side, we start to cause more significant roof damage, especially in this case. This one was from the Euless area, I think, or somewhere in the HEB area. Taking kind of, in this case, an aluminum roof off, still was anchored on, but that lighter weight material. And then higher up on the scale, we get into, these were both tornadic events that happened in this area, or in North Texas. You can see the more notable roof damage. I know it's hard to see probably the structure damage in the top right there, but whole sections of the roof are gone. The entire roof over that extension actually collapsed down into the pool underneath it. And so as we move higher up, the damage gets more notable. And then there's a reason for, the reasoning for that is why we issue at 60 miles per hour or greater. So again, visually estimating winds is challenging. Actually, if you want to go to the next slide, please. Visually estimating winds, our bar got off just a little bit, is very difficult. It usually results in an overestimation. It's like standing on a curb of a street and trying to guess how fast the cars are going. We usually overestimate it. I live on a neighborhood street that's a main pass-through, 30 miles an hour. I swear everybody drives 45. At least that's what it looks like to me. So as spotters, as spotters and chasers, focus on providing a report that is as descriptive as you can get it. It's gonna take a little more time, yes. But think about, if you know, I don't know what types of trees. Some people are great at types of trees. All I know is Bradford pear, because they fall at anything, and that's what we used to have in our office, and we finally got rid of them. So, type of tree, but the size of the tree. Is it a smaller, newly planted tree, or is it a 12-inch, 18-inch diameter tree, and the size of the tree limbs that were broken? What type of structure is it? Is it a wood shed in a way, or something with siding? Is it a brick home? Is it a manufactured home? That type of information is important because we can use the wind scales that we have, the ones that we have experience with, to using damage assessments when we're out doing damage assessments, the enhanced Fujita scale, the enhanced Fujita scale, to apply these wind speeds to it. So thinking about what you're looking at, what type of structure, what size tree, what material was used for roof. I put that because a lot of times it is roof damage. There's a difference between just shingles being broken off versus, actually starting to pull some of that plank and that base up on the roof there too. So next slide, please. Well, David, here you go. I think we got a little mixed up in our slides right here. There we go. All right. And I'm done, short and sweet. All right, how to report to the National Weather Service. This is how y'all can especially help us. And I tried to make this as generic as I can, but one of the biggest things that you're going to want to do, especially if you're not from the North, if you're from Piedmont or Oklahoma City, you're going to want to check with those local National Weather Service offices to see what their reporting methods and criteria are. But in a sense, you usually can call the Weather Service office. Phone numbers should be kind of at the bottom of the web pages, our public phone numbers. Down at the bottom, too, is where you will also find usually every office's central email address. So you can send reports there as well. We try to monitor that frequently during an event going on. It's a great place to send pictures and videos, too. Emailing the offices is a great way to send reports like a day or two later also, especially if you have pictures or video you want to send over later with reports. Email's a great way to do that. Social media, the National Weather Service, as hopefully you all know, is on Twitter, X, formerly whatever we're calling it, something on that, and Facebook. So you can usually find it at NWS with the office name. We do our best to monitor social media in real time because we know that a lot of people are using that. Well, maybe the numbers are varying now, but the different platforms. A lot of people are using that, but there are times where we may have to put that aside while we're in a transition period, bringing new people in, or we don't have the amount of people in yet, so we got to focus on radar. We got to focus on a couple other things first. But we usually try to go back and catch up on social media. Amateur radio, I have a couple of my amateur radio team operators here that come and help our office, but knowing what those local frequencies are, and that may be county dependent and changing, a lot of times those can be listed on Weather Service pages, but also talking with them to get that information will be helpful too. Next slide, please. So speaking of office pages, some of them have local Skywarn pages. Ours in particular, you can link and find our amateur radio frequencies. You can find our listed criteria of what we want reported to us. You can also find how to report to us. You can find recordings of Skywarn presentations. You can find our upcoming class list. So those can usually be very good references for each office's Skywarn program if they have that local page. We do also take reports through MPing, which is a free mobile app on iOS and on Android devices as well. Please note this is not a Weather Service app. So we don't have control over it. We just kind of see the results from it. It is part of a research project between that other school to the north, I think OU they call it up there. Sorry for all y'all from Oklahoma. Nothing bad, we've hired plenty of people from there. For them, NSSL, and a couple of other groups. So they're the ones running that. MPing reports may not be seen right away or soon enough. For example, we do pull them into our office where they alert on our workstations, but there's about a 10 to 15 minute delay for that happening by the time it goes to their server, and then we pull it in. We can see it other ways a little bit faster, but MPing I feel like is good since it's a series of drop-down menus that you just click and choose. You can't add information in there. So it's good for reporting hail because it's easy to select what type of hail. But if you look at their flooding and their wind, some of their descriptions kind of run together and can be a little generic, and you can't really add information in there, like flood magnitude, flood frequency, that type of important information, a description of what was damaged. So I recommend that you use the other reporting methods when you're reporting flooding or thunderstorm winds there. You can also do winter precip. We actually will look at it while we're at, when we have winter weather events. We only have like 1 or 2 this year. That's fine with me. But we will look at it can help us see maybe where the snow transition line is, where sleet is reporting, freezing rain. It'll help us gather reports that way too. Report tornadic activity directly to the office too. Again, there's that delay. Tornadic activity or developing tornadoes is urgent, it's imminent. We need to know that information faster. And then yes, you can report to the Weather Service, and you can do it on MPing also. So you can report to us and still help the research efforts. We'll see it come in, we'll know that it was something that was already reported, so don't worry about the duplication part of it too. They're being used for different purposes also. We know that a lot of people too, or some people may be a part of Spotter Network and report to us that way. I'm gonna show some of those, how we use those here in just a little bit. However, how the Weather Service used to ingest Spotter Network reports has changed, and we don't really have the capability right now to see them as they're coming in. So we would have to go to the Spotter Network page to monitor. So just know that if you're using that as your primary reporting, the Weather Service, as of where we stand right now, since we changed one of our systems, is not seeing those like we used to. So please follow up, especially on the urgent reports, with a more direct report to the National Weather Service. Can't guarantee that we'll always be monitoring that page. It's kind of one other thing, so we'll have to see where it kind of falls in our priority, but we can look for those later, kind of as a follow-up there. Next slide, please. Making a complete report is very important, so answering these 5 questions as much as you can will mean that you have given us as much of a complete report as you can without us having to take time and ask questions back. So yes, number 1 seems pretty intuitive, but I have taken reports of, it's happening. What is it? Like, I know it's exciting and it doesn't happen a lot, but you want to, especially if you're reporting after the fact, what are you reporting? When did it occur is important too. Those real-time reports are great if it's happening now where you safely can. Usually you'll say hail is falling now. But if it happened a little bit ago, 30 minutes ago, because you've waited for the hail to stop falling and then you went outside, 30 minutes ago, an hour ago, a day ago, Last week, like I said, we'll take them after the fact. Last week, we'll get those because sometimes people will go check on extra properties that they have, and then they find damage. So we take those reports too. But make sure to tell us, date and approximate time, especially if we have multiple storms moving over that area. We want to make sure we've lined it up. Where did it occur, of course, is important too. No maps go. And no, what was the other one? Grid boxes. Somebody wanted to report in grid boxes the other day. GPS is okay. It's easy for us to kind of plug that in and find it. But really the biggest thing is if you can reference the nearest notable intersection and or reference to a town, city, that's gonna help us find it as quickly as we can. Again, thinking about how we cover 46 counties in our jurisdiction or in our area, and other offices cover just as many at times. If you tell me you're in Parker County at FM Road X and FM Road Y, it's probably going to take me a little bit of time to find where FMs are located. But if you've got another one, if you're telling me even that you're at FM X and FM Y, but it's about 2 miles north of Weatherford, perfect. I can find that a lot faster. Get that report processed and go on to taking in the next report and things like that. Under the damage section, this is really going to come in. Not so much for hail, especially for damaging wind, maybe tornadic type, but again, focus on describing that damage and sending us pictures if you're able to also. Next slide, please. All right, so what happens to your report? It doesn't just get written down on a piece of paper and tossed in the trash afterwards, believe it or not. It actually has a longer lifetime, or shelf life even, per se, when you talk about the big database that the Weather Service maintains. So we log your report as it comes in the various systems that we have, or the system that we have. We're not gonna write down your name or your contact, your exact location, your address, things of that. It'll be something as simple as, like this one says, a train spotter reported 2.5-inch hail near X and X in Temple. Something as simple as that in this one. And then what we do is we'll send it out as a preliminary storm report so all of our partners, the media can see it, David and the meteorologist can report it on air. Again, providing that confirmation to people that yes, there is 2.5-inch hail in this storm, you need to be taking shelter. And then at the end of the month, well really 2 months later, we lag about 2 months, we have to assimilate all the storm reports that we got for a month and basically QC it and push it up to our headquarters, or not our headquarters, push it up to our environment group, and they will certify it. Once it gets certified, it goes into the storm event database. So if you search storm events database, you will find all the storm reports that we have certified and QC'd that have been reported to us at least. And then that report becomes part of our nationally archived database that's used for millions of projects, businesses across the country, everything from insurance to construction, to research, to, like I said, construction. If they want to build a new, build a new apartment complex or build a new warehouse building, there's a lot of those going up. They're going to look at the climatology weather and see what they need. Of course, they have their building standards, but what else do they need to account for on the weather side to help sustain that facility? So construction uses it a lot too. Agriculture, all sorts of things. So you're essentially helping the national economy for decades to come, believe it or not. So, but again, we're not gonna write down your name or your contact. The federal government's not gonna track you that way. So we'll just get that basic information in there. Next slide, please. So I think here I'm gonna go into just a couple of examples of where spotter reports have played critical roles in helping us make warning decisions. So I really wanna drive home that your reports do help us and help us do that. So this was from November 4th. We're gonna go into a case study of this in just a little bit here. But this was a tornadic event, mostly east of here. We had the big EF4 tornado go through Lamar County up by Paris and move up into Oklahoma. So that's the event that I'm focusing on right here. So at 3:16, we had a spotter that actually called our Shreveport office, our sister office to our east, and they were able to quickly relay that report back to us. So even if you don't call the right office, we should be able to relay it back pretty quickly and get it to the correct office there. So they report a large stovepipe tornado. The tornado warning was already issued at, I actually have my time wrong on this. This is actually the 4 o'clock hour. I did my conversion wrong. This has been 4:15. The tornado warning was issued at 3:56, I believe. So at 2 minutes later, it actually was less than 2 minutes, it actually was just about a minute and a half, updated the warning, put out that the tornado was observed. So went from radar indicated to observed, giving people that confirmation that it has been reported here. 3:25, we received another report, continuation of the tornado ongoing, so continuing that confirmation that it's still in contact with the ground. I don't know where that report actually came from. I think it came from a spotter. It just wasn't written down exactly through what method. 3:30, 5 minutes later, another spotter who was working with the emergency manager, maybe on the amateur radio lines, reports the ongoing tornado then. So we're continuing to track it, having that confidence and telling people that this possibly large stovepipe tornado is still ongoing. Another report from Shreveport from the same spotter of a large tornado ongoing. So we're using those reports from spotters and chasers too to help message our information, but also update our warnings and know that we need to continue that warning also, having that confirmation that it's ongoing. And then our media came in a little bit later. We hadn't really heard about the damage or the type of damage, but viewers started contacting them and they started relaying damage reports to us too. We could start making our track, knowing where we needed to be the next day to survey that information. So next slide, please. Continuing on just a little bit later, I've got the times, I think a little bit more correct here. This was our second storm down to the south. This was in Hunt County. Now we're using Spotter Network in this case, so we had a Spotter Network report. This was on our old system, so we still got the reports filtering in directly to us. We made the change to the new system in last summer, 2023. So this was when we got it. He quickly reported a funnel cloud that was ongoing down in Rains County, so south of Lamar County, about 2 counties down there, or 3 counties down. And then a few seconds later, he was able to quickly relay to us that the tornado was on the ground. So you can see soon after that, we upgraded to observed. Now, it says 6 minutes. What happened was the other tornado warning was about to expire, and we were getting ready to issue the new tornado warning. So we just waited on the new tornado warning to issue observed. But everybody, all of our partners, had already seen the information from the spotter network about the confirmed tornado and could start messaging that out. So we had an observed tornado at that point, telling the public that it's observed now. And then we got another message from our Shreveport partners. So there wasn't quite too many storms in their area, but it was getting kind of close to the border, so they were keeping a close eye on it. They were able to find a chaser stream, or maybe the chaser had actually told them that they were streaming, and so they hopped on that and then let us know. So again, that kind of office-to-office communication back and forth too. So they relayed that they had seen the tornado develop on the live stream, and then we started getting information. You can start going to the next slide now. We started getting information from local law enforcement, continuing following along, and so we've got that confirmation. We know it's ongoing. We see the track getting possibly approaching Sulphur Springs, so we upgrade the tornado warning at that point to add the considerable tag, and that changes the wording and it changes the messaging. So we upgraded to the considerable tag. We're continuing to get information, and we're providing information too. We're zeroing down to help that law enforcement and the emergency management and amateur radio network controllers. Here's where the tornado, we believe it to be now, getting close to Highway 19. Crossing it, he's relaying report where their spotters are reporting it from, starting to relay damage. So there's a lot of communication that goes on back and forth, but we're all using those reports to try and relay that safety message out to the public too. But understand too that when you're sending us reports, we're sharing it for the greater good also. Because again, message amplifying, having more people saying the same thing, hopefully gets people to take action a lot faster than waiting a few minutes to decide what to do. Next slide, please. All right, so now we're going to jump into the case study here. I wanted to show you a demo of one thing. I'm not going to be able to, but that's okay. I'm still going to talk about it. So quick review. Again, we ended up having 4 tornadoes on this day. This is a path of the EF4 that went through Lamar County. It continued up into Oklahoma. This is not the one that hit Idabel. Yeah, Idabel. Idabel was the one more county over. But all of the tornadoes occurred in our far eastern counties, where the radar beam does not sample below 8,000 feet. So our far eastern counties along the line of East Texas can be challenging because we don't have decent low-level sampling. So spotter, chaser reports become critical to us in that area. But I'm gonna go through a little bit of radar analysis to give you an idea of how we can still use the radar, how we used it to hopefully make the best warning decisions possible. Again, we're still going to be really looking for that ground truth, that missing link from spotters and chasers to tell us what the radar is telling us. Is that what's actually happening down there? And it's more challenging when your radar beam is above 8,000 feet. So next slide, please. So this is what I want to grab your attention on, maybe make you pay attention to this case study here for a little bit. This is the Warn-On forecast system, which was made public somewhat recently. It was internal a while, but it is showing a lot of progress. All I'm going to do is tease it right now. The Warn-On forecast system is a model. It's an ensemble probabilities. This is an image of low-level rotation overlaid with the tornado storm reports. If you can see those triangles there, and I don't have a pointer, sorry. If you can see those triangles, this is a model run 4 hours before the EF tornado happened, where it's showing the potential decent probabilities for low-level rotation nearly in the same area where the EF4 tornado tracked. So pay attention a little bit here. We don't want to get too carried away with it, but we're going to try and come back to that here in just a little bit. So let's look at the event itself first. If you can go to the next slide, please. Find my water here. All right, I'm going to let you just read this for 1 second. I don't feel like I should put water on the altar. All right, so 26 miles in Lamar County. We actually were not able to survey the EF4 damage until the next 2 days later. So we went out, we had a survey team go out, they did majority of it. We couldn't get to a certain area, so we went back out the next day. And I'll tell you the reason that we went back out is because somebody provided us aerial footage of that area. We had no idea there was a house hidden in there. And because of what they showed, that's when we made the decision that we got to go back out and look at that. And looking at that is where we figured out that that was where a little pocket of EF4 wind speeds and damage had occurred. So sometimes surveys take days, but we had estimated winds of 170 miles per hour as this tornado tracked about 30 minutes and then crossed over into Oklahoma. And right now I'm drawing a blank on how much longer it was on the ground in Oklahoma, but not quite the same distance. So next slide, please. The forecast for this was actually pretty good. 15% probabilities started showing up on SPC about 15 days. 15% probabilities started showing up on day 4. You can see day 3, they already went ahead and went enhanced with about a 30% outlook there. Next slide, please. Day 2 showed kind of just expanding the area a little bit higher on the probabilities there. Really starting to hit on the upper right one is wind, bottom is hail, and then we have your outlook on the upper left with tornado outlook here on the bottom. So the thinking was that if you read on the discussion, it was going to be kind of supercells, maybe small clusters, and then kind of becoming into a QLS. Or kind of a squall line. So that was a little bit why the tornado probabilities were a little bit higher and the wind probabilities were higher. It was kind of because of that clustering and then the line of storms also. So kind of a hodgepodge of everything really was possible that day. Let's go to the next slide. The next slide shows day 1. The 13Z outlook didn't show much change from the day 2, but by the 1630Z we had upgraded, or SPC had upgraded to a moderate outlook with higher probabilities, especially on the wind and the tornado potential there. So leading up to this well-forecasted event, I think we started talking about it 4 or 5 days out also. You can go to the next slide, please. So here's the verification. It turned out pretty well. Do look like there are a lot of red dots indicating tornado. Remember, some of those are multiple reports of the same tornado. So this was the preliminary. But right in the area that they were anticipating some of the most intense activity is what actually happened there. We got to remember, too, that you can still get strong or very strong tornadic and also severe thunderstorms even outside those moderate areas, into the slight, into the marginal also. So we don't want to completely discount those days either. Next slide, please. Messaging on this day, because we had a lot of lead up to this event, it was a pretty well forecasted event. Our messaging on this day, in the morning you see the image on the left here where we tried to break down the timing and the threats. But as I went back through kind of our social media posts, we were really hitting safety messaging that day, getting the word out to people. We talked about how do you get warnings in the morning, having multiple ways to get warning. Tornado safety on the road, Sheltering, I think we posted about sheltering in apartment complexes, sheltering in manufactured homes, sheltering in brick homes, things of that nature. We really knew that for November, that kind of a wintertime potential tornadic event is not something that people were going to be, I don't want to say they weren't expecting, but it's usually not the typical time of year. So we wanted people to pay attention. And then we did a little bit of lessons too. So by the time we got into the middle of the day, we already had showers and rain and storms forming. We start to transition a little bit into what we kind of call mesoscale, giving you more of those radar updates. And so I know it's hard to read, but talking about the area in the middle there, we say that this is where we're watching closely. Showers are expected. Let's see, intensify into storms after 1 p.m., severe weather threat increasing along and east of 35 by 2 or 3 p.m. So we're breaking down that timing even more, trying to give people the latest update and information there. But we started out the day really trying to hit the messaging, as this was going to be a different November day than most people are used to. Next slide, please. So our sounding data here, we actually did 4 soundings this day. We have our 12Z sounding on the left here, and then we actually did a 15Z sounding mid-morning on the right here. So a little bit of decent improvement. I'm not going to break down completely, and I know it's a little bit difficult to see there, but I'm not going to break down completely everything in the sounding data. But between 12Z and 15Z, the cap was already weakening. The shear was improving. Our deep layer shear, I think, had gone from, I'm trying to remember, 25 to 40 already, just within 3 hours there. Lapse rates were steepening, and the moisture was increasing. You can see the red and the green, your red being temperature, green being dew point, getting closer, a little bit closer together there by 15Z. The shear, our hodograph profiles, not the big curved hodographs, but it's still early in the day. By 15Z, I say veer back veer. So what happened is your winds kind of veer, kind of go a little bit clockwise, and then they kind of come back counterclockwise and then go back. It kind of folds on itself. That's a little concerning, but again, it's still earlier in the day. Meteorologists, we know not to discount a day because one thing seems a little bit off. I'm sure a lot of us here will tell you we've busted on many days if we believe that. So let's go to the next slide. The next slide is actually the 18Z sounding from Fort Worth and the 21Z sounding from Shreveport. So still before our tornado. Both of these, unfortunately, were contaminated by rain and storm, so we can't gauge really too much out of them or put a lot of confidence in them. But one thing that we did note using our sounding at 18Z as we launched it, and also aircraft data coming in at Love Field, was that the cap had just about completely been erased. The wind profiles were starting to increase. Again, you can kind of get that off the Fort Worth one. That was a little contaminated, so looking at aircraft data for that. And that, let's see. Yeah, the wind fields are displaying low-level disruption, but are improving rapidly. So again, still a little early. Let's kind of see what happens. So next slide, please. So now, about that same time, 1 p.m., we get the watch box for pretty much everything along and east of 35 there. I show you the surface map. I'm going to explain it because I know it's a little bit hard to see. This is the 3 p.m. surface chart because they pretty much hadn't changed since about 1 p.m. the same time. So our surface pattern actually stayed fairly similar for a couple of hours. We have good south wind. The blue line was the cold front coming in, which should be the brown line. The one that kind of goes completely north to south there is the dry line there. I circled up by Lamar County. We did have a little bit of backed winds in that area. Those winds kind of stayed backed, and so that likely played a role in helping that tornadic potential up there too. Dew points for the most part, 73. 73 for November 4th. That's pretty crazy. A little bit lowering in the DFW area. It was raining. It had cooled a little bit, but good south winds up through there. 73. Temperatures were in the 70s for the most part. Even looks like some 80s down in central Texas. So a warm, humid, icky day there for the north and central Texas area. Kind of starting to come together for a severe weather event there. Go ahead and go to the next slide. All right, so this is actually going to be a radar loop. First, what I'm going to do, I'm stepping up through the storm. So this is, as the storm is in Fannin County, getting ready to go into Lamar County. This is early in, and I'm sorry, I can't read the time. I think it was right after 4 o'clock. So this is sampling from the Fort Worth radar, and I'm going to kind of step forward now. So as you look at your velocity patterns, it's very icky. It's very mesh. You don't really have a good look at rotation. There's a lot of things kind of going on there. As I play it, I'm going to play it back one more time. If you look at your reflectivity, remember, we're over 8,000 feet here, so you don't really see like a hook echo. You're sampling mid-levels. You can probably, as it loops through, I'm going to slow down a little bit here too. You'll see the bounded weak echo region indicating that strong updraft. So I kind of slowed down here, and I would have paused it if I had the capability to. So as I put some markers on, I know it's hard to see. I was trying to line up where that bounded weak echo region was. You can see broad rotation where I'm kind of mentioning there before we get into range folded areas there. So this would essentially be sampling the mid-level cyclone, nothing in the lower levels. The tornado already was ongoing by this time, and then this one gets lost. So I'm going to switch now. Let's see. Nope, I'm still sampling. That right there may have been the best rotational velocity that we had. And that I think was close to when the tornado was getting started from the Fort Worth radar. All right, I think that's the end of that loop. The next slide is actually off of Shreveport's radar. So Shreveport actually has lowered their base velocity down to a 0.3 degree. And so, or a little bit, around that area. So they did not have range folding on theirs at the time. Remember, we had a bunch of other storms we were sampling, so we had to be careful of where our range folding was. So we were looking at Shreveport. Again, you're sampling at this point over 10,000 feet, I think, so you're not going to see a well-defined hook echo. There's some bounded weak echo regions in there, but the velocity pattern, I'm going to show some still images too. The velocity pattern looks a little bit better off of them, but again, it's still pretty broad. You're sampling the mid-level cyclone. You can see kind of where I'm putting the marker there as it crosses north of the highway. And then right about there, we start to get probably our best look at some of the velocity. And this is really about the time as it starts to do its EF3, EF4 damage too. Yeah, right in there, or the scan before that. I'll show that to y'all in a still image here soon. So not your traditional couplet, definitely a challenge out there. There's an ongoing tornado. Velocity product from the radars is kind of messy, but sometimes out in these areas we have to deal with messy, and we have to actually use what we can in those messy velocities. And so one of the things that we can use, if you want to go to the next slide, is what we call rotational velocity. Now, this is kind of one of the things, I'm going to explain this as best as I can, but so rotational velocity is calculation to determine the strength of the mesocyclone. Research shows that there are potential links in that rotational velocity to tornado strength, but you have to have other things in place. Like usually you also have to have a TDS for confirmation or for confidence. And you also have to, you're looking at distance from the radar too. So here's the challenge though for us. Rotational velocity works best, usually, or the layer that we're usually looking at to maybe help with especially tornadic potential is between the 4,000 to 10,000 foot range. In East Texas, we're higher than that. So we gotta be a little bit guarded about that. So how you calculate it is you do velocity of your maximum inbounds plus velocity of your maximum outbounds, the absolute velocities of them actually, and then you divide that by 2. That's what you're gonna see in a lot of the research papers if you go look for it. That's what you'll see with the chart here on the bottom left here. One research from Smith et al. Basically went and looked at case studies, calculated rotational velocity, was able to link it to, you have to distinguish between supercells and QLCS tornadoes. QLCS tornadoes are gonna be a smaller mesocyclone. Supercells are going to be larger, so there's slightly different calculations for that. So you can equate it, different rotational velocities to potential for different types of strengths. But what we've started doing a little bit in our office and what you'll see in a few of the research papers is adding a distance factor to that to probably get a better sampling of the rotation when you're farther out from the radar. Close in, we do it all the time. Close in, you know, you're adding 1 or 2, not a big deal. But as you get farther out past like 40 nautical miles, and you're sampling higher up in the storm, adding that extra distance factor, which is just the distance divided by 10, can usually give a better strength of the mesocyclone. So taking kind of somewhat of the research on the left there, or as they've been able to put it kind of in a nicer chart that's easy for us to look at and maybe keep on our desks when we're looking at tornadic potential too. Now you'll notice that the range to radar goes up to 120 on that. Typically, once you get past about 80 nautical miles, you're gonna be up above that 10,000, 80 to 90, you're gonna be above 10,000. So you gotta kind of be careful on the far right side of the scale there because you are sampling much higher up in the storm. And again, we're trying to hit in those lower level or kind of mid levels with the 4 to 10,000 foot range. So next slide, please. So what I wanna do now is, sorry, I forgot, it's not gonna work on this way. What I had captured was a couple of the images at the Fort Worth time and then at the Shreveport time, and I calculated the rotational velocity to show you kind of where it falls and how it could still be helpful. So the first one I captured was 407. The tornado had not developed yet. The VROT that I calculated, including the distance factor, was 45 knots. The range was about 95, and we're already above 10,000 feet at that, where I identified probably the rotation was strongest. So putting it on our chart, it already puts us up in the strong category, strong mesocyclone. Again, you can try, it's not gonna tell us that there's a tornado. We know there's not one happening at this time, but you have a strong mesocyclone that in the right environment at least may be able to support kind of tornadic activity and maybe development if we were closer in. So going to the next slide, this actually, okay, the one thing that I was gonna show next, right, is GR, if you use the Gibson Ridge, GR actually does now a calculation of VROT for you, but it's a little bit different. So what you would do is you would identify where kind of your outbounds and inbounds are. Again, they may not be right next to each other. They probably won't be at this far of a range. So I actually was looking farther out. I know it's hard to see, but there's a red dot in one of those bright greens there. And then by sampling, I'm actually sampling about 1, 2, 3 bins over where those higher outbounds are. And that gave me a VROT, it's on the bottom there, of 37.4. That doesn't calculate the distance though. So distance, it tells me the range is 94.5, so 95 miles. So let's just add 10. So that's 47. Like I said, I calculated 48 on my rounding, 47, so that's pretty close. So we can use, at least in the Gibson Ridge, to maybe get some of that also. Now there's another one in here, you can't see it. Right above VROT, it says CROT. CROT is another rotational velocity that calculation that puts in some of the distance, does a little bit more fuzzy math. It's not quite the same that we do, but it's trying to account for that range and being higher up. Now the CROT on this was 59 knots, I think, 59, and then it has strong next to it, meaning a strong mesocyclone. That's about 10 more than what I had calculated using ours, so just kind of gotta, I don't quite know the math behind that one, but the VROT plus the distance is a lot of times what we are using too. So now going to the next slide, this was at the time of the tornado was actually developing. I calculated a VROT on the image behind of 55 knots at 100 nautical miles. Our height is well above. This was the time I said, yeah. So this puts us actually off the chart there. So we're gonna have to expand the chart, I guess. But no, we're looking at mid-levels or higher up in the mid-levels too. Remember, VROT calculations are usually designed for a little bit lower, but using our calculations, if we couldn't visually see it, this is a strong mesocyclone and we're in an environment that could support a tornado. We know that already. So we're gonna be looking for that help lower down to get that confirmation. Go ahead and go to the next slide, please. This should switch over to Shreveport now. Shreveport, I'm not using the chart here, so now we'll get an image a little bit here. 57 knots, it's gonna be off the chart anyway, again, just like the previous one, but this was a few minutes later. Farther out, higher up, I think you can kind of see where the green and the red are. Just by where the highway is, it's hard to point out there. That's the area I was calculating that VROT in. Go to the next slide. This is where I believe it was its strongest. This was as the tornado was really getting going. I calculated a VROT there in one of our best kind of couplet or mesocyclone looking areas of 67 knots. So that was the strongest calculation I had of all of them when we were doing this. And then our last slide there, or the next slide, please. A couple minutes later, still have a strong circulation as it's passing between Sumner and Paris. This is where the EF4 damage was happening to, or the strongest EF3, EF4, and calculating at least that mid-level VROT of 63 knots there. So trying to use some of those tools even to help at farther ranges. They're going to be better off when you're closer in, even if you're only 20 nautical miles, but within that 20 to 50 nautical mile range too. Using it in the level between 4,000 to 10,000 feet is a lot of times the level we're looking at in the right environment to maybe give us a lead time of that mesocyclone strengthening and how is that going to impact lower levels in the storm also. Make sense? Now you're all gonna go read research papers on it, right? All right, yeah, next slide, please, go ahead. All right, so now I wanna talk a little bit about the Warn-On forecast system, and that was the image that I showed you. And I had hoped to do a demo of it, but not gonna be able to do that. So let me talk a little bit about it, and disclaimer, don't go running off and use this to make all your decisions, please. Like any other weather model, right? This one is still a little infant, or it's more than an infant, it's actually been around a while, but it's just now publicly available. So taken directly from their webpage, if you go to the National Severe Storms Laboratory, or if you search Warn-On Forecast, we also call it WOFS, WOFS, or WOFIS, like any acronym, people say it different ways. It is a research project tasked with increasing lead time for tornado, severe thunderstorm, flash flood warnings. They're doing it by developing a rapidly updating high-resolution ensemble model forecast. So ensemble modeling is different than just your deterministic forecasting. All right, next slide, please. So a little bit more about it, and you can go to their webpage and you can read a lot more about the specs if you would like to. I didn't put all of that up here. It's showing a lot of skill, but it still is under frequent development work. It does not run every day. It is running based off of funding now, so they're targeting your higher days there. And so it only has so many operational runs a year and a season. The domain size is a 900 by 900, so it does not cover the entire country. It doesn't do sections. They basically determine each day that they're gonna run it, what part of the country they're going to run it for. It may not be in our area if the southeast is about to get slammed with a tornado outbreak. So it's not gonna cover everything. It's really gonna highlight, or they're going to pick up where some of the most intense, strongest storms may be. It's the first model system to perform rapid assimilation of radar, satellite, and observations, and it uses right now the HER as a background. It used to use the WRF, I think the ARW WRF I read. But it assimilates data every 5 to 15 minutes, produces a new model output run every 30 minutes, so we're getting a new run every 30 minutes. As low as a 3-kilometer resolution, it also runs 9, 15, and 20, I think, kilometer resolutions too, and the output is every 5 minutes. So every 30 minutes, a new model run, that gives me every 5-minute time step from there. So a lot of data going in there. It uses 36 members, and it also has a deterministic hybrid run, kind of like a base one to go with it too. So next slide, please. How it is helping us. Increased confidence in threat areas and storm evolution throughout an event. And then we're using that to improve our messaging. Not necessarily using it to make warning decisions or warnings ahead of time, right now, but we're using it a lot in our messaging out to our partners, messaging out to the public, and that's what I'm gonna show you here in just a little bit. Next slide, please. So how we're improving it with messaging. This was I didn't specifically pick me, I just happened to be chatting this day, or doing the communications this day. This was actually November 30th, 2023. So I believe it was already, the public version's already running. Like I said, we've been looking at it internally for a couple of years now. So at 11:52, I'm like, hey, WAFIS is running. It's showing the potential for a few robust storms with hail, generally along and east of I-45. I have timing in there, about 1:30 to 2 p.m. for gaining intensity. It's not showing very much in any of our counties with respect to a tornado threat or rotation for the remainder of the day, which is in line with the latest outlook that we just saw from SPC. So I'm kind of increasing that confidence in there too a little bit. However, we don't want to completely discount it. Again, it's an ensemble model run. We have to be careful near the warm front still. So we're still watching near the warm front, but it's starting to line up with our initial thinking too that the tornadic threat might be minimal. And then about an hour later or so, WAFIS indicates the hail threat could increase with these storms over the next hour. Hail size is still expected to be around 1 inch. So we're not talking about a big hailstorm. We're reminding people, not large hail. We're looking at just near severe criteria there. And we're gaining a little bit of confidence with it because the short-term high assimilation model is starting to show the same thing. But as I mentioned there, so 12:44 p.m., this would have been about 17:45 Z, because we're in November, late November, so we did time change. When WAFIS starts running, WAFIS always starts running at 17Z. That's their start time that they run and that they run through. So we have to be careful with the initial WAFIS runs that kind of come out because they're kind of starting from scratch. And if there's no storms, the model improves as storms get going also. So if storms don't start developing until 21Z, yes, you're gonna have output at 17, 1730, 18, 1830, et cetera, but again, it's assimilating radar and satellite too, and there's not a lot on those at that time, potentially. So you're going to maybe see changes in the model until we get storms going and it starts to latch on and adds that extra data and then goes from there. So next slide, please. So a little bit later, we put out that here, so we use that to make a graphic, is kind of what I'm getting at here. So here's where we're highlighting where the increased potential for hail could be. So I had said along and east of 45, now we're able to kind of move using WAFIS a little bit, narrow that down, we kind of get into 35 here, but as storms get going and as the model starts to assimilate radar and satellite, we're further refining that area. So again, the hail is only about 1 inch. And then once the storms got going a little bit later, 2:30 in the afternoon, you started to see the change in WAFIS. And so the last one there is like coverage is increasing, but they're elevated. There's really not much to share. We're still keeping an eye on the warm front, but lightning and heavy rain are really the main hazards. WAFIS has scaled back, or WAFS has scaled back on the overall threat over the last few runs, even for 1 inch hail. So it adapted to the environment as it started getting more sampling in this case. We actually ended up not even issuing any warnings or reports for this day. We did have that smaller hail. Again, remember, we were looking at just around 1 inch hail, which is our threshold for warnings. I think we had some smaller hail, but didn't actually cross that. So kind of pointing out too, you have to be careful with those initial runs sometimes too, and then watch and kind of see how it adapts as storms and the environment starts changing and gets going there. Next slide, please. So another example here, we were able to use this. This is June 15th, 2023. This was the, as one of my coworkers calls it, the Sanger Banger, the big 5.9 inch hail in Sanger. Up in Denton County. WAFIS latched onto, what you're looking at the loop here is updraft, 2.5 kilometer updraft with hail for, not hail, sorry. Yeah, updraft speeds of greater than 60 miles per hour, meters per second, excuse me, miles per hour, meters per second. So a couple hours, it was basically showing a pretty intense storm starting in Oklahoma, crossing the Red River. As that storm got going, you can see, I know it's a little bit small there, but the image in the middle there, as it got, we were using WAFIS to draw an area of where, this is where it's gonna be at 8 p.m. and 9 p.m. This is kind of where we're watching it getting down into our area. These people need to be aware. These people need to take shelter from this hailstorm here. That image that I grabbed was actually, it was a webinar I was on recently where the director of NSSL was talking about what they've been working on over the last year, and they grabbed the image that we created using WAFIS there. And I was like, hey, we just showed up on a national webinar about it. So we're happy to see that. So our Science and Operations Officer, Ted, did a little kind of review of this event and then kind of how WAFs performed. And some of his comments are that it gives us a critical confidence boost when the output matches the conceptual model. Remember, kind of have to have all things working out correctly here. So it's giving us that increased confidence, which I talked about earlier. It's hard to cancel watches early, but using this in particular, but it shifts our messaging to focus on areas of greatest concern. Again, we're using it for messaging out ahead and starting to get that confidence of where we can start to message those threats maybe ahead of time. And then he kind of points to storms took longer to organize, which impacted the timing and lowered the confidence after a certain time. So again, it's not a perfect model. We don't want to be throwing all our eggs in a basket with it also, but it is showing a lot of improvement, a lot of skill, a lot of improvement, and has been helpful to us as we keep an eye on it during the last couple of event runs. Over the last 1 or 2 or 3 years, I think we've kind of been looking at it. So next slide, please. Another example of messaging here. We used it back on April 4th of 2022 also. We were using it to highlight areas where we thought warnings were likely versus possible. It's really trying to get people to pay attention to the weather, but using that to help increase our confidence, help our messaging. And then in the bottom right, you see an example, an older one too from 2021, doing the same thing from our sister office in Norman, Oklahoma up there, using that output, and I know that they did because I talked to them about this, using that output to try and highlight where the increased risk for tornado warnings might be issued over the next 1 or 2 hours there. Next slide, please. Okay, so like I said, I did want to do a demo on WAFs, but I'm unable to. WAFs is publicly available, and it has retro runs too. So I was going to go back and I was going to show you that output from November 4th. But if you're interested, again, on the NSSL webpage is where the public link can be found, and also more information about how it's run, some of the specs on it, the different schematics it uses if you really want to get down into that there. But I don't remember exactly when it came online publicly, but I think it would have been somewhere in the last 6 months to a year, I think so. All right, so how I was going to wrap it all up, which I'm making really good time here, is I wanted to talk about damage assessments from the Weather Service standpoint, and also how you can help us during some of these events too. So we do damage assessments, obviously, after tornadoes, but we also sometimes do it to try and determine if it was a straight line wind event or if it was a tornadic event. As we know, both of those can cause similar damage, especially down closer on the EF0 to EF1 wind speed scale. It helps us visually assess the damage to determine rating, path, width, wind speeds, and then again, was it straight line winds or tornadoes? We document it. It goes into that storm event database once we certify it. Internally, we call that storm data, and then we use it obviously for our post-event write-ups too. Next slide. So we do them when we know we have a tornado. We have to have eyes on that. As y'all know, tornadoes are rated after the fact, so we have to have eyes on that damage. If we have a questionable or significant damage that with a radar signature that may have indicated possible tornado, we'll go out and get eyes on it too. But we'll also go out if we get a request from an official or a partner. And this sometimes falls in the lines of on your government side. You know, they want that official write-up. It helps us with their summaries, so we'll go out and take a look at it. Next slide, please. So how it happens is we develop a survey plan, and the cat driving is literally developing these teams is like herding cats sometimes. No offense to any of my coworkers, but on days with big events, we'll have multiple teams, multiple people. You're trying to get them all out the door. So starting after the event, so most of our tornadic events happen in the evening or late afternoon, evening. Starting with that evening shift and overnight, they're starting to gather any data that they can. We're making a decision first. Do we need a team? How many teams? Do we need to go out? Do we know where to go? So our teams consist of meteorologists. We don't use outside expert helpers usually. I mean, not while we're there on site. It's usually just us with the officials in that area. Usually 1 to 2 people, preferably 2, 1 to drive, the other to help assess, and then we may have 3 or 4 if we're doing any type of training or just have a lot of ground to cover also. So starting that night before, we're gathering any data that we possibly can. We are scouring social media, we're looking through emails we may have missed, looking through reports, starting to make maps and plots, and there are times that we don't even know exactly where we need to go at that point. So that's another missing piece too. Whenever we are going to do a survey, we will announce it usually on social media, but also through that public information statement. And then they go forth and they survey. All the cats drive away, and they've got all their tools and their kits, and they're ready to go. So next slide, please. So I know there's a lot of text on this, so I'm going to try and summarize it. But we have a damage assessment GIS-based app that we use. We have our own app that we use to gather data. It has the EF scale, all the damage indicators right there in it. And so as we're going through and taking pictures and damaging things, we're dropping points to a host server that the Weather Service personnel or the other meteorologists at our office can see, as we are doing also. So we only have so many options for damage indicators, although with the update coming on the EF scale, we will get some more damage indicators. I think a lot more, I've heard, than I'd probably ask for, but it'll be helpful. And there's only so many descriptions too, so sometimes we're not quite in those descriptions, and I've got to pick which one is the better, because the description that you picked impacts the wind speed that's selected also. We don't necessarily capture every damage point on our surveys. We don't always have the time to stop at everything, but we're gonna hit as much as we can. We have to find the start point, we have to find the end point, we have to go to the hardest hit damage, because that's gonna be our maximum rating. Yes, we wanna get a good capture of it, but sometimes we'll do our survey, and then we will get more information from the local emergency management in the next day or two with all the other points we missed, and we'll kind of assimilate it in that way too. So we're trying to kind of move quickly, because we only have so much daylight to work with, and hit all of these points too in one day. If we have to go back out another day, we will do that too. Sometimes we have to go survey more areas the next day also. We aren't usually entirely sure of the rating when we're surveying the damage. It's giving us a preliminary rating, but so majority of the time we probably have a preliminary idea while we're out there. But there's sometimes things that we want to double check on. We have quick response teams in the Weather Service, so if I need help with something, I can reach out to this team and send them pictures and all the information and get their input on it. I can confer with people back in the office. Hey, what do you think of this? You know, we all have different levels of surveying, so what do you think of this? Sometimes we might need to work with structural engineers or building experts, because that's their expertise and not ours. While we do have experience in that, sometimes we want a little bit of extra help to make sure we're making the right call. So again, that experience varies among staff, so it might take a little bit longer to actually get the rating out during the day. While we're in the field, we cannot draw the path length or width. Our app doesn't really allow for that. I can get an idea of it, but I can't actually draw it. Someone at the office might be able to do that when we're all done, so that I already have the length and width when I get back. But if it's somebody at work who doesn't have that, or if they're busy with something else, all that's gonna have to wait until we get back. Next slide, please. So usually somewhere between 5 to 12 hours later, 5 to 14 hours later, we get back to the office, we're tired, we're hungry. We probably haven't been in a good restroom in a while, just like in storm chasing, right? So surveys take time. A lot of people want the information right then and there, but it actually takes a lot of time. We're in North Fort Worth. If a tornado happens in Lake Worth, I can think I'm gonna hop out there, I'm gonna get it done in an hour. There's a reason I put 5 hours up there. Even ones close by the office, always take more time than most people anticipate. So once we get back to the office, we have to finish up editing the data points. We've got to pull up the website, the GIS. We've got to edit some of them. We don't have to do full editing, but enough to get the track, the width, the rating, and usually we have to get the times, the radar times, if that hasn't been looked up, and then we have to do the write-up for it. And we're getting better. I've trained a lot of people at our office so that they can start doing that while we're driving back. And also, we have 2 people in the car. Usually we start typing out the write-up on our phone, and then we just email it to ourselves. Because when I get home at 6 and I just want, I don't know, some Chick-fil-A nuggets, because all I've had is a truck stop burrito at that point or something, I just want to be out the door and probably showering too at that point. So we'll do the write-up, we'll construct the public information statement, and then we will send that out. And as each team comes back, we'll usually resend that out. Some will come back faster, but we know the media is waiting for that information. We know emergency management. The public is waiting for that information too. So we try to have a pretty quick turnaround, but sometimes we just get delayed a little bit more than that. And then over the next couple of days, we'll do really the full cleanup of all the points and start making that information more publicly available once we've taken out any of the personal information that we may have typed in there. Or specific information that just needs to be kept internal. And then maybe it might result in little shifts of the track too, as we find, maybe get other information from reports coming in or emergency management and kind of drawing the new lines there. But usually that first day, we've done a pretty good job on that point and on that track. Next slide, please. And then, so how you can help us with this. So we keep working over the next couple of days. It gets certified about 2 months later. That's when we have to have everything done and complete by then. So how you can help us, if you have storm damage reports, or if you have tornadic reports or wind damage reports, tell us about that as soon as you can. I know it might be a multi-day chase too, where you're one to the next, but if you've got time the next morning or that night that you can even just drop us a note that says, hey, I did see a tornado, here's where it is, here's a picture. Remember, we're starting to assimilate that data and figure out where we need to go starting that night. So if you can provide us anything you have, especially by 7 or 8 a.m. that next morning, that will really help our teams, especially in the more rural areas where we're not quite sure exactly where we need to go, but you may have been along that FM or county road that gives us that name. And so we can at least start there and build from there. We don't always, some people think that right away we have high resolution satellite imagery and flyover that we can see the path. We don't usually have that right away. It takes about a couple of days sometimes to do that. We don't own drones. I can't request helicopters to fly imagery for us. I can't even request drones to be flown on our behalf. But if you have one and you fly one and you share that with us, I will not say no, absolutely at all. Sometimes when I go out there, I get out there with emergency management. They have drones, and they'll fly it for us. But I have had storm chasers that are like, hey, I had a drone, here's what, and they've sent it to me right then. And so I use all of that data, but I officially cannot request it be flown on our behalf. So keep that in mind, too. If you have the data, it's helpful. So lastly, please give us time to complete damage surveys. As I said, they really do take a lot more time than we even expect. And it would be helpful if we can encourage a culture of not bashing assessments or ratings. We know we're not complete experts. We are highly trained. We are reaching out to other people for help when we need to. Sometimes there's a requirement. At a certain rating, I have to reach out to the QR team, usually for help or for a second assessment. But if you have thoughtful comments and questions or want to know a little bit more about it or have maybe a piece of information we missed, those are much better received than, I don't know why you rated it this and not this, because it looks like that house was destroyed. Well, you weren't there to see that that house was not anchored down at all and just completely collapsed once the garage got taken off. So just be mindful of that. Next slide, I think that's actually the end for me. That's like a fire hose of different information, but I hope you got a little bit of something new or something enjoyable out of that. Yes, I will happily take questions. I know I have some time, but Martin, yes. Three questions.
Just a
Only
second.
one per person. I'm kidding.
What is your, okay, thank you. What is the Weather Service, or at least your office's velocity threshold to issue a tornado warning? Is there a magic number?
So on the, there is 40 knots on that VROT, 40 knots, and there actually is a chart out there. I didn't show that one too. I think though, there's a threshold, I'm trying to remember, 30 knots, I think that might be tropical though. So I think 40 knots is about the average for, that was what I was gonna show. About 40 knots is when you started getting in that moderate to strong. So it's not necessarily that we'll issue a tornado warning at that point. On the low levels, we don't really have a threshold. You know, you have to look at the full image through the storm, and you have to look at the environment too. But when you're in that 4,000 to 10,000 foot and you're getting close to 40 knots, that's really when we're taking a really close look and seeing what's happening at all levels and in the environment too.
Okay, so that's 40 inbound and outbound?
It would be the computational of both of them.
Okay, an
so
average.
it might change, yep.
Okay. Next one is, you're talking about the Helicity Ensemble Forecast model earlier in that Eastern County event. How is that more reliable or similar to the NamNest and the HER Helicity Swath forecast? I mean, is it essentially the same thing?
It's, I don't know the exact calculation. It's going to be more similar to the HER, though, since it's using the HER as a base. The NamNest, I think, is going to be a little bit different. Now, the calculations of each, how they actually calculate it, I think might be similar. I can't remember exactly how each of those is calculated, but the concept is going to be the same if that's what you're asking. Like if you're looking at updraft helicity on the NamNest and updraft helicity on the HER, the WAFS, though, is going to be closer to how the HER is calculated because that's what it runs as its base.
Okay, so if you compared it to the HER Swath forecast.
You
It'd
might
be
have similar. Yeah.
Ballpark similar.
Yeah, and I would look and compare both of them too, because remember the WAFS is assimilating data faster than the HER is also, so it may have updates a little bit better.
Okay. And then the other question, are more of an observation, is I noticed the tornado warning to actual tornado ratio is probably, this is me personally, is probably like 6-1. So we'll have like a 6 tornado warnings and maybe 1 tornado, or maybe it's even 10-1. Is the ratio so great because you're just erring on the side of safety? And
That's
this
a
is
good question.
This is
it's
not
probably
just
across the country, right?
yes, yes. It's southern and
I
central
hope we're
plains.
a little bit better than that.
Yeah.
So, yes, in a way. I think, though, having an understanding of the environment and where that skill level lies probably plays an impact on it, too. But there are offices that lean a little bit heavier on that, or on that threshold. Not anything bad against them, but just probably that's some of the needs that might have been requested to by like their partners too. Sometimes there is a societal impact on that too, that sometimes will be considered in, but we are still looking at that base meteorology and that base radar analysis to see. So yeah, I think it's going to vary. It's going to vary on environment and skill level though, I think also.
Right. Part science and part policy.
In a little bit, yes. A little bit of that, yes.
Okay.
Sean? We don't have any official training for like training the public to do damage assessments. And there are different ways that even like the Red Cross does theirs and jurisdictions from us. So, but we don't have anything to train kind of on that. We'll simply take all the information and kind of assimilate that into our plan and our assessment. We don't have anything at this time, no. So, David.
Jennifer, you mentioned that you can't request drones, and I'm wondering the reason for that. Is that just an NWS policy, or would this be something that had to be an act of Congress to change?
Probably both. It's an NWS policy right now. We do have some agreements, like with CAP, Civil Air Patrol, that we can work with, and then ongoing research, but I don't know the full background on that. It's just kind of the guidance that we were given to. So, yes. Did I miss one over here? Okay, yes, I'm gonna go over here first, Kim.
The print is kind of small up there.
I know.
Slides are available for us. And the second thing I'd kind of question is, this past week, we had a little bit of pea-sized hail. Mm-hmm. And can you comment on that and the warning of that in advance? Because, you know, I wasn't expecting it, obviously, but didn't really pay attention. But in any event, thanks for your slide presentations. I think they're excellent. There's a lot of content in there about the little websites and stuff, or little content on the database and things like that. Your case studies are really exciting, to me at least. But maybe, I think, make a comment about the World Economic Forum's view on predicting severe weather increases in Texas. And I was wondering if you've gotten around to looking at their predictions to see how they fit.
I have not looked at those predictions. I know, you know, I'm at the point where I need to start looking at the next couple of months. We've been involved a lot with finishing up winter and then getting ready for eclipse planning and all that stuff. So, but with the transition from El Nino now into neutral, which was a change, and then flipping on, I know I need to go back and look at what our climatological statistics are for the next couple of months on there too. You asked about the slides also. I'm going to double check them. I'm pretty sure I've got nothing in there that they can be made available also. Plus, I think the live stream may have shown some of the content also. And so that will be there for reference. And then The pea-size hail, that's what you're asking about. So yes, the system coming across, I guess temperatures were a little bit colder. We started out with some bursts of sleet in there. The models didn't, I don't think, resolve that colder temperatures very well. So we did end up getting a mix of grapple, sleet, and small hail throughout the day. And so just trying, I think we updated some of our graphics to try and message that out. But every now and then, some of those systems coming across come in with those colder temperatures that can catch us off just a little bit. Thankfully, it wasn't anything more than small size hail in that. Just reminding us that February is going to go out with one more before we transition from winter to spring. So, did I catch all your questions on that?
I can keep going, but...
Well, maybe we can catch up on that later then. I may have seen one in the far back, so.
And there will be a recording of all of the presentations, which will have the slides in them that you'll be able to get within about a week or so.
This is in reference to your case study up in the Northeast. Do y'all have in-house access to that new radar that's in Durant? I don't know if it's the same bandwidth as the NexRads, but I don't know if you'll have access to that. We
do not have in-house access at this time. We don't have in-house access at this time, and no, it's not a S-band radar. It's X or CX, I think. X-band, thank you. It's X-band. So they're still working on getting that up and going. I think they are making some of the data publicly available, but so we can view a little bit that way, but we don't have any internal exclusive access at this time. Yeah, the app. It's pretty, the public, the app. So I wasn't sure if I was supposed to say that publicly or not, or let Durant say that, I don't know. Not that I'm hiding anything from y'all, I just, there's a lot of players involved. Here, I can get this one, Kim.
Okay.
What's up? That's okay, so everyone else can get
Okay. So as a chaser, I'm still struggling a little bit with the best way to make reports now, since that Spotter Network is not really tagged right in. I was on several tornadoes last year. I reported them on Spotter Network, but if I'm in the midst of something, it's hard to break away and post on Twitter or post on Facebook. Is the best way to call you guys and just leave a message on the recorded line versus Spotter Network now?
Calling our office, we do have, our office has that 1-800 number, but we also just have our public number. Calling and leaving a message is great. I think we're gonna have to make a more conscious effort to be monitoring the Spotter Network page also. So that's something I'll have to take back to our office to remind that, because we did get information, it was quick and easy that way. And while you could do it on MPing too, we'd have to have the right system open to monitor that. So we'll try and make a more conscious effort of that. I think they're going to be looking at getting that integrated back into the new system. A lot of people have asked for it. Let me put it that way. A lot of people have asked for that to be integrated back in. So, but yes, if you got a second to call our office, that would be fantastic too. We appreciate that.
It's just so easy in radar skills,
Yes.
Location knows everything.
Yeah, it's integrated into radar scope, and that makes it easy, yes. Now, we can have radar scope open too and see them plotting. That's one of the ways we'll see the MPing also too. But again, we've got our systems. We usually have GR open to have like Shreveports, because we only have so much screen real estate, or whether it might be Dias. So it's just, for us, it's the balance of where all the data is coming in and how we can, how many people we have to monitor all that. So thanks. Yeah.
Even though it's delayed, it still provides a geotagged location, because
Yeah,
most
we'll
of us
still-
have no idea where we're at.
Yes, and so we'll still get that. Even if it's delayed, we'll still get it and be able to, or process it, because I say process it, we have to like turn it around, send it as a LSR. We'll still get that information sent out, is what I'm trying to say. Yeah.
So I work for Esri, and I was just kind of curious about some of the GIS apps that you guys are using for the damage assessment. Is that a combination of Survey 123 and field maps? And
Yeah, we use Survey 123 to input the information, and then it goes onto our servers. When we get back to the office, we have our Esri license for that.
And then when you guys are editing, are you guys editing in a web map? When you edit the tracks when you get back in the office, you guys do that? Just curious.
I don't know. I dabble in GIS, but not enough to know everything. I do know web. I I don't know. It's just the web page I go to. And then we push it out and make it public. So, and I know like they've changed, you know, you're getting rid of story maps or dashboards and story maps in the various web apps. So Greg, do you know if it's, yeah, we take it in on Survey 123, but like the web page itself, I don't know exactly what it's using. But I can look that up if you really want to know. All right.
Okay.
Turn it back over to Kim.
Thank you, Jennifer, for your wonderful talk. Could everybody say thank you? So, first talk done under the time limit, so y'all are going to have a little bit more time to go and enjoy the vendors and look at all the raffle items that are really good, especially that little, car from Channel 5 that we got. That's amazing. I think y'all are going to really want to get that. But take your time doing that. But before we do that, I'd like to introduce my daughter, Lainey. So anyway, she is going to draw the first 2 tickets for the TESSA t-shirt bag that people put in. And so get your tickets out. And we will draw those tickets so you can go back and get those during your break. Okay? So draw the first one.
So I hope you have your tickets ready. 681724. 681724. Look at those tickets for me.
Nope.
Anybody?
Okay. We're
Going
gonna go
once, going twice.
Okay.
Sold. Okay. All right, here's our next one, 682050. We have our winner.
Okay.
So you'll meet me at the TESSA store, and I will get you your prize.
Okay, one more.
Oh, one more.
We're doing 2.
We're doing 2. Okay. And the last one goes to 682268. And there's our 2. Hey!
Okay, great. Please go and see Lainey after this break. It's going to be a little bit longer break, like I said. David's going to be in talking at 11. And if you get the chance, go over and see the cake that's out there for David. And because, it's going to be cut into pretty soon, and there won't be a face on there anymore. So... Anyway, we're real excited about the next speaker, so y'all go enjoy yourselves, have some coffee, have some water, have some tea, have something, go to the bathrooms, whatever you need to do. And if you have any questions, please let me know. I'll be here and to answer anything that you have concerns about, okay? Enjoy the break.
Testing. Testing.
Hello, everyone. We're now ready for our next presentation, and this is the 75th anniversary of NBC5, previously WBAP TV, previously on Broadcast Hill in Fort Worth, now located up near DFW Airport. David? 75 years of the station and the weather department? Is that about right?
75 years for the TV station, and I'm now 48 years.
Okay, so how old is the weather department?
It is 74 years old.
Okay. So the weather department, which I think is the most significant contribution that Channel 5 has given North Texas because it's so unique, and also really the whole country has benefited from the work done by Harold Taft and David Finfrock and his team. And so really before Harold, I believe, the weather was given by reading a message, right, basically?
Yeah, it was, I'll discuss that, but it's the old newsreels, and that would play with all of the different film that we had for the news of the day, and then the anchor would simply read the National Weather Service forecast. But that changed when Harold Taft stepped into the picture.
So please welcome David Finfrock.
Thank you so much for this warm welcome. Now, I know not everybody knows who I am. Not everybody, or even fewer, will know who Harold Taft was, who hired me. So just to quickly, raise your hand if you ever saw Harold Taft do the weather. Well, more than I expected. Wow. So y'all have been around for a while. Harold died in 1991, and he worked up until 6 weeks before his death. There was no quit in that man. We've been showing over the past 20 minutes or so a reel of a lot of old photos from the early days of television. Channel 5 started in 1948 and went on the air actually a little early because President Truman came to town, to Fort Worth, and that was the very first broadcast. And so they put that on the air, the old black and white WBAP TV. If you turn to Channel 5 now, you'll notice it's KXAS because there was a change of ownership in the mid-70s, just the year before I started. So I never worked for WBAP TV, but for its follower, the KXAS, which was then owned by Lynn Broadcasting, now is owned by NBC. We're an NBC-owned and operating station. So we'll go to our first slide here, and that's me now, after 48 years at the station. I'm hoping to keep working another couple of years, just part-time, so that I can get to my 50th anniversary, and we'll see what happens beyond that. If I still enjoy it, and they still want me around, I may keep going beyond that, but that's my short-term goal anyway. But like Jennifer, I'm an Aggie. I beat her by a few years. I graduated in 1975. My first meteorology class was in Godwin Hall, which no longer exists. My dorm was McInnes Hall, which no longer exists. A&M has really changed over the years. It's gotten much bigger. When I started, there were 14,000 students, and maybe 15% perhaps were female. By the time I graduated, it had doubled. It was 28,000, and it was almost 50-50. It had really changed in the 4 years that I was there in the early and mid-70s. So I graduated, got my BS in meteorology, and was fortunate to be awarded the Outstanding Student Award. If you go to the O&M building now, I think there's still a plaque on the wall with all of the past winners, and my name, I think, is recorded there. I was then very fortunate to be awarded a fellowship for graduate work. And in between my graduation in May and my start of my master's program in September, I spent the summer on the Juneau ice field doing field research. And that's kind of what I figured my career would be, doing research. I had dreams of going to Antarctica and doing climate research, and either that or working with the National Weather Service. I never dreamed that I would be on television. For one thing, I was really shy. Getting up and talking in front of people scared me to death. I was in my senior year in college and went to petition my counselor, hey, instead of taking speech, could I take an extra semester of Russian instead? You know, something easy. And he said, no, if you want to graduate, you got to take this public speaking class. And I took it, and I made an A. I was amazed. I found out if I knew what I was talking about, I could do it. It's the uncertainty of not knowing what you're saying that, you know, causes people qualms about getting up and speaking. If you know your topic, it's not that difficult. As Jennifer was demonstrating earlier, she knows her topic really well. We are proud to work with the folks at the National Weather Service, and you are going to be hearing more about Harold and how he worked with the National Weather Service too. But first, back to my story. I got to Alaska, spent 6 weeks there on the Juneau ice field, cross-country skiing from one hut to another, doing research in glaciology, geology, geophysics, meteorology, and came back from that wonderful experience and sat in a classroom again. And somehow it wasn't quite the same. I had a full fellowship. They were paying me to go to school. But about halfway through that semester, I got a call from someone named Harold Taft. I'd never heard of him. I grew up in Houston. What got me interested in the weather was when Hurricane Carla hit near Houston, down around Freeport on the Texas coast back in the early 60s. That really piqued my interest and got me interested in meteorology in the first place. But once I did make it to A&M and then graduate school, and then I got this call from Harold Taft. I grew up in Houston. He was here in the Dallas-Fort Worth area, so I had no idea who he was. But he invited me to come up and interview for a job. And I said, I haven't applied for any job up there. I mean, before my fellowship had come through, I did send in an application to the National Weather Service. And there was a box you could check on the bottom of this civil service application, allowing them to release that to any other agencies looking for an employee. And as a college student, you know, just getting ready to graduate, you're going to consider anything. So I checked that box. And what that did was it allowed Harold to go down to the Fort Worth headquarters, which was in downtown Fort Worth, and go through a bunch of applications of people who had applied to the Weather Service. And he found a list of likely names. I'd never heard how many he interviewed. I think it was maybe 4 or 5 that he invited to come interview. And I was one of the names he chose. And I said, well, I did pass speech, and I'm feeling kind of stultified sitting in the classrooms again. I'm at that point where I'm ready to get on with my life. So I'll go on up and interview. It's good experience interviewing anyway. So I took off, drove up Highway 6 from College Station, and about, it was between Marlin and Waco, I believe. At this point, it was just a 2-lane road with basically no shoulder and a bar ditch on either side. It's been widened since then. But I'm driving up, there's a car in front of me, a car behind me, so I can't really maneuver much. And coming the other direction was this big old dually pickup hauling a trailer with a big smoker on it, barbecue smoker. And as it's coming towards me, one of the wheels on the trailer comes loose. And it starts bounding down the highway towards me. And I couldn't pull over because there's this bar ditch. I couldn't speed up or slow down particularly. So here it comes. And I was very fortunate to catch it on the bounce down at the bottom. It hit my front left fender and passenger, and my driver's side door. If it had come up and hit me in the, through the windshield, that might have been the end of my career right there. But, I eventually limped over to the side of the road, had to shimmy over to the passenger side to get out because my door was jammed. Had to go over and pull the fender away from the door so that I could get in and out of my driver's side door, and said, this is not a good omen for someone going to interview for their first job ever. So I made it on in to the TV station in East Fort Worth, took a deep breath and said, all right, we'll just give it our best shot. I go in expecting this long interview process. I met Harold Taft for the first time, and he really didn't have any questions for me. He said, you did very well in school. Graduated magna cum laude, outstanding student. I see all the courses you took, you did well. I think you know your stuff. What I need to see is you in front of a camera. And so they marched me right into the studio, put me behind an anchor desk, which was up on a raised platform about 18 inches high. And they had saved the maps that Harold had used the previous evening. The paper maps were on the wall. And so I was just supposed to introduce myself, walk over, do a weather presentation, and come back. Well, the cameras turn on. I say, hello, my name is David Finfrock. Let's take a look at the Texas map. I push the chair back, not gauging very carefully how far it was to the 18-inch drop-off on the back of that raised platform, and my chair starts going over backwards. I scrambled to my feet, so I didn't go over with it, thankfully, but you hear this tremendous crash. And I wander on over. This was back in the days when we had a pointer. I had a wooden stick, and we would stand off to the side because we didn't want to distract from the map. The weather was the important part, not our faces. And so I stood there with my pointer and pointed on the Texas map, and then the U.S. map, and the forecast map, and then the actual forecast graphic that we had made up, and did my presentation, came back. Thankfully, one of the floor crew had put my chair back up, so I didn't have to do that. Sat down, said goodbye, and thought, well, this is the shortest television career in history. And went back, figured I better redouble my efforts at my master's program. And I was amazed when about a month later, I was at home in Houston on Thanksgiving break, and Harold called me offering me the job. And it just floored me. I said, my interview was a disaster, and he wants to hire me? And it was maybe a couple of years later when I talked to Harold and asked him why he picked me over those other equally qualified candidates. And he said the fact that that happened, and I kept on going. I didn't stop and say, oh, can we start over? No, I rolled with it, went, did the weather, came back. He said, if you could do that on your interview, you can probably handle anything that'll come up on live television. So the fact that my chair fell over may be the only reason that I am here 48 years later talking about this. The little things in life, you never know what is going to be important, what's going to put your life on a whole new perspective. But Hurricane Carla, taking that speech course, which gave me the gumption to even come up and interview, having that chair fall over. These are all things that led to where I am today. But let's look back more at some of the past. We're going to go to our next slide. This is where I walked in to do that interview. This was when it was brand new, hadn't even got any landscaping. There's shrubs around there now, and it no longer says Fort Worth Star-Telegram, WBAP. Amon Carter was the owner of the Star-Telegram early on. He started WBAP radio in the 1920s, started WBAP TV in 1948. And here you can see the building. Nobody really knew what a television station was supposed to look like in 1948. So does that look like anything to you? They used the plans for a middle school. and it looks just like any 1940s era public school. They took the cafeteria and auditorium spaces, turned those into studios. But if you went upstairs in particular, there had been basically no changes. You walk down a hall and there's classrooms on either side. Those were the offices for the managers and sales staff and so forth. But it was really fun working there. Although by the time I got there in 1975, it had been altered a number of times inside, especially in the studio. And those alterations continued up until about 10 years ago when we left that building for the new studio just south of DFW Airport. Go to the next slide.
When a B-29 bomber crashed and burned near Fort Worth a few weeks ago, it was a routine job of coverage for the WBAP TV staff which produces the Texas News. A 5 days a week television newsreel covering top news events of Fort Worth, Dallas, and Texas. In peace and war, the aim of the Texas News since it was established on September 29, 1948, has been the development of a new medium of news, television.
But that was the kind of newsreel footage that was used not only in promotions like this, but also in all of our newscasts. We can go to the next slide here. And, well, there are slides and videos in here. And this is about a heat wave from the early 50s. 50s, of course, was a really significant hot and dry period here in North Texas. And you can see, television has changed a bit over the years. I don't think, there they are trying to fry an egg on the sidewalk, though. That still happens, but usually not with people in their swimsuits. So yeah, we wouldn't try to do this today. Can't argue with dogs cooling off, though. Animals are still real big on the news, even today. But that was a historic drought in the early 1950s. And we have had a number of really bad hot and dry years since then. There will be more on that coming up. But let's go to our next slide. And this is when the weather started. Now, I mentioned earlier, September of 1948 is when the TV station went on the air for the first time. This was a year later. It was October of 1949 when we had the first weather broadcasts. What happened was Harold Taft had been in the Army Air Corps and then the Air Force during World War II, and eventually returned to service during the Korean War and wound up a full colonel in the Air National Guard before he retired in the early 70s. But Harold Taft, who is the man on the right in the picture of the three people, was watching the television and saw how, they just, read a forecast, the National Weather Service forecast, just read just like you would read his own forecast today. And he says, we can do better than that. When I was in the military, we did briefings for the pilots. We would put a map up, show them, tell them where you're taking off, what the weather is like, what it's going to be at altitude, they didn't have satellite back then in the 40s, or radar was very rudimentary, but they had weather observations and they could give an idea of what the weather was like at the destination, and because of weather balloons going up, the RAOBs would allow them to get some sense of what was happening aloft. And so they would give this full detailed briefing to the pilots before they took off. And he wanted to do something similar for the public. So one day he just dropped by the studio and asked to see the manager and broached the subject with him. And sure enough, they thought that sounded like a good idea. And so Harold, after being in the military, was working for American Airlines as a forecaster. And so were these other two gentlemen, among others. But together, the three of them, Harold Taft, Walter Porter, and Bob Denny, decided they would come start doing the weather. From what I read, they got paid $7 a day for doing the weathercast. I think it was just on the 10 p.m. news. And the reason there were three of them is because they still worked full-time for American Airlines. And they had shift work, so whoever was off on a given night would come in and do the weather. So they would rotate. In the early 60s, American Airlines transferred their meteorology department to Los Angeles, and Walter Porter and Bob Denny went. Harold decided to retire from American Airlines and become full-time television. But here you can see them standing in front of a big blackboard with a map on it, and they would write with just chalk, draw where they thought the fronts were, isobars, temperatures. They would do explanations. I know it's kind of hard to see, but if you look at the right, Mr. Porter here is showing not only the forecast up at the top, says tomorrow, fair, mild, minimum 47, max 62, pressure 29.97, but below that, you'll notice he's giving a little demonstration. He's pointing to a map of the Gulf, and then just to the left of that is a schematic showing rising air coming up over a front, producing clouds and rain. Even back then, they were doing scientific explanations. Yeah, you can see right here the schematic where the wind is riding up over this front. There's the Gulf, there's Texas, and it's just rising up over that. So not only were they doing forecasting and explaining the weather, they went into the science behind it, which was a first. Now, I don't know for sure that this was the first weather broadcast in the country. Certainly it was one of the first, and the first ever to use maps and scientific explanations on the air. Let's go to our next graphic. They called it weather telefax. Sometimes you would see it spelled Telefacts, telefacts. But what's interesting here is the logo is superimposed over the radar image. This was a radar that we had installed at the station. It's a WSR 57, which goes back a ways, 1957, Weather Service Radar 1957. And this was with the old cathode ray tubes. And the radar would sweep around, and you'd see a blip where you got an echo, and then as the radar went around, it would fade away. So by the time you got back around to where it was before, the screen was completely blank. If you wanted to see how things were moving, you would have to take a grease pencil on the screen, outline the area of precipitation, and then come back maybe 10 minutes later, outline it again, and see how it's moving. That's how we could determine motion of the storms. Obviously, you didn't see anything about reflectivity other than, yep, it's there. And certainly, Doppler didn't come in until 1988. And so it was rudimentary, but again, it was state of the art in the 1950s and 60s, and even in the early 70s when I started there. So things have changed a lot over the years. We eventually, of course, got color radar that would animate. And I think truly of all of the changes that have occurred over the years, probably the one that would surprise Harold Taft the most if he were to come back is that you can carry around a radar in your pocket. That would just be mind-blowing to him, when this was what we had up until the mid-70s, really. It was beyond that before things started to really improve. Let's go to the next slide. There is the radar up on the roof. And that's Harold there pointing at his proud installation, WBAP TV weather radar. And so far as I know, it was the first one at a television station anywhere in the country. Next slide. This is Harold inside with one of the early forecasts. Again, this is before my time. This is probably early 60s here, but you can see, well, yeah, it says October 14th, 1963. And you can see the weather information that he put on, the almanac data there for that particular day. And then you would have forecast graphics, and most importantly, you would have all of the maps, the paper maps that we put up. Let's go to the next slide.
Weather televised. Here is your staff meteorologist, Harold Taft.
Good evening, folks. Under clear skies, the present temperature is 82 degrees, and we look for a hot day tomorrow. It was 91 in Fort Worth, 93 in Dallas. Temperatures tomorrow should be up into the middle 90s, downtown areas, some places even warmer than that. Cooler air, however, is pushing down across northwestern Oklahoma, and radar picked up a line of thunderstorms about 30 minutes ago.
So that was an indication of those paper maps that we use, that we drew on with chalk and marks a lot. And this is my first promotional shoot in January of '76. You'll notice, fresh out of college, when I came down to do my job interview in October, I shaved the beard that I had grown in Alaska, but I kept the mustache. And you can tell I cut my own hair back then. I couldn't afford much more than that. This is only one of my 3 or 4 $29 leisure suits that I bought. That was the extent of my wardrobe. When Harold hired me, I came in, I worked Monday through Friday, the morning show and the noon show, plus I worked the Saturday evening show, so 6 days a week. We had Ken McCool, who was a physics professor at one of the Dallas community colleges, who would come in and do Sunday evening. So I got that day off. But I worked 6 days a week, including through Saturday night, and then also coming in early Monday morning. So I really only had, part of one day off. I had no paid vacation, no health insurance, no retirement. But I got in the door, and I did that for about 3 years, and I was paid each month with a check from Harold E. Taft and Associates. Harold had a contract with the station to provide all of the weather for the television station. They paid him a lump sum, and then he would pay whatever it cost to bring somebody else in, which is why he hired somebody straight out of college with no experience who would work cheap. And this was the beginning. I did that early morning and Saturday shift for 2.5 years, working for Harold Taft. And then we had a new news director come in. And he found out there were people on the newscasts who didn't work for him. I worked for Harold Taft. He couldn't have fired me if he wanted to. So it was then, only after I'd been at the station for 2.5 years, that I actually was hired as an NBC5 employee. And at that point then, oh, wow, I only have to work 5 days a week. So that was a real benefit to me. Let's go on to the next picture.
Yesterday, we hit 104 degrees, the hottest day of the year so far. But Texans are used to this kind of heat. In Dallas, Parkland Hospital has reported only a handful of heat stroke cases in the last 3 weeks. And at John Peter Smith Hospital in Fort Worth, the news is even more encouraging. No heat stroke cases and only a few patients with the less serious heat exhaustion. Nothing at all unusual for a Texas summer. But of course, the hazard does still exist, especially for the elderly or those with breathing or circulation difficulties. Many of the area's young people are cooling off in swimming pools, and Fort Worth's water gardens are popular in spite of the official no swimming rules.
It's back up above 100 degrees again today, and the bad news is it's only June. And as any long-time Texan can tell you, the worst is yet to come in July and August. I'm David Finfrock, Channel 5 Action News at the Fort Worth Water Gardens.
But, that was one of my early live shots. The first live shot that I recall ever doing was also in June, I think, of the previous year, and that was 1980. And those of you who were there at the time may recall that we hit 113 degrees on 2 consecutive days. What was it, June 26th and 27th of 1980. And my first live shot was standing out in that heat at the old Handley Power Plant in East Fort Worth, talking about the demand on the electrical system. Not everybody had air conditioning back then, but there were enough that, it did put a real dent in the electric power grid, and so that was my report. I tell you what, standing out in 113 doing live broadcast makes me really appreciate the reporters and the storm chasers who are out there in the field every day, while now, for most of my career, I got to sit in an air-conditioned studio, so it was a lot easier. There were times, though, when it was difficult. I mentioned that, I only had to work 5 days a week once I came on staff, but the problem is we still only had me and Harold Taft. And one night, after I had done my early morning show and the noon show, and then I usually took a nap in the afternoon for an hour or two, and then would try to stay up until the 10 o'clock news so I could watch Harold's broadcast before I went to bed. And I was waiting up for that, lounging around at about 9:45 when I got this panicked call from the TV station. David, can you come in and do the weather? They've taken Harold to the hospital. He had a heart attack, and they took him in, and he had, I think it was quadruple bypass surgery, emergency. So here I am at 9:45, lounging around on the couch, and I've got 15 minutes to throw on a suit, race fortunately back then I lived very close to the station, so it was only about a 6 or 7 minute drive. I made it in, threw up a quick Texas map. The other forecast information was still there from Harold's 5 and 6 o'clock newscast, and actually got on the air at 10:15. But Harold was in the hospital or recouping at home for the next 6 weeks. So that night, I had to come back in and do the 10. That was on a Tuesday night. Wednesday, Thursday, and Friday, I did the morning, noon, 5, 6, and 10, all 3 days. And then had to come back in for the next 6 weeks. We had somebody who came in and took over the early mornings, a part-timer, but I did noon, 5, 6, and 10 for 6 weeks, and also a lot of weekend work as well. So that was when they decided, we can't do this with 2 people. And that's when we brought in Scott Chesner, who is on the right there. And so it was then Harold Taft, me, and Scott Chesner. And behind us, you'll notice a lot of other people. Those are some of our weather watchers. Harold started the Weather Watcher program. It's not quite storm spotters, but similar in that we need ground truth, in particular rainfall, because we would go on the air and report how much rain fell at DFW Airport, but what happened elsewhere? And they would write down on daily logs and call into the station when they got rain. And so we would either prepare a map, or Harold would sometimes, when they came in late, just read them. Here, so-and-so from Mineral Wells had this much rain. In West Fort Worth, it was this. In Mesquite, this much rain. Frisco, this amount. And so we had all of that ground truth coming in, because it was so important to realize that weather is not just in one location. It varies across the area. And that's why we have storm spotters today, why we had weather watchers back then. Let's go to the, and all the young people there, they'd come in for the seminar that we had. Every year we would bring them in and have a little training session, and sort of like what Jennifer does, give them some information on the weather. All right, let's get on to that next video.
From KXAS TV, this is Channel 5 Action News.
Good evening, I'm Dennis Hulley. Hurricane Allen has gone ashore near Brownsville. We have word from meteorologists that tornadoes, high winds, and heavy seas have pushed water inland and caused a great deal of destruction in the Brownsville area. Action News reporter Charles Ely is standing by, we understand, live from Corpus Christi. Charles?
Can we get rid of the feedback? Thank you.
Too much. You're on.
Okay. And I'm Charles Ely.
And I'm Harold Taft, and we're live in Corpus Christi. Hurricane winds extend 75 miles to the north and about 50 miles to the south. So that's pretty much the situation that we're in right here. Now, the temperature is holding pretty steady at 77, and that may sound comfortable, especially with the wind blowing 64 miles an hour. But the humidity is 90% right now. And that, of course, makes it a very, very miserable night. Exactly what does the rain look like, and what does it feel like when we're up to 65 miles an hour? Well, it's stinging right up against your face, believe me. David, that's the latest we have from Corpus Christi.
All right, Harold, we got a good look at the storm from our eye in the sky, of course. The satellite photo shows the big sprawling mass stationary there just off of Brownsville. If we look at that right now, you can see the big cloud zone and very clearly see the eye of the storm there just off of Brownsville. It will be moving, of course, right on up the Rio Grande. Flash flood watches out throughout all of South Texas. A tornado watch also from McAllen on up
towards Victoria. We've already had one report of a tornado in the Freer area, tornado warning there in Duval County, and there will likely be more as the storm sits there, spawning the very severe weather all along the Texas coast. In our area, already some high clouds beginning to move in. Now, we'll take a look at the forecast map for tomorrow, and on it, you can see, again, fair and hot out west. But in our area, the rain increasing quite a bit. It will be moving onshore very slowly during the next 24 to 36 hours, drifting up the Rio Grande, and by tomorrow evening, we should begin to see some of the rain beginning to move up into our area. We won't have the torrential rains they've had down south, but we will see scattered showers and thunderstorms Sunday evening on through Monday and Tuesday. So a couple of days of a chance for some pretty good showers in our area.
So that shows you a little bit of what, the typical forecast would look like. Those paper maps we had to draw for each newscast, and then the Texas map in particular, where you had the temperatures plotted on it. At the end of the newscast, we'd rip that off at 5 o'clock and put a new one up for 6 o'clock because we had to have current data on there. And by current, we go back into the little weather office around the corner from the studio where we had a teletype and the DIFAX machines printing out maps. And at the top of the hour, that Texas map, I may have already drawn in areas of precipitation and where I thought the front was, but so far as the temperatures, we waited for the teletype to start spitting out those numbers at the top of the hour. And we'd rip those off and go back in and then draw with my Mark-Salat the temperatures on the map. So, it was current. And if you noticed in that one, when I said, let's look at the forecast map, and that the current U.S. map glided out of the way, that wasn't mechanical. There was actually a person back there who would pull it off to the side. These were the olden days. Things have changed so much over the years. This was our team back in the 1980s, and I'm just about in the center there in the striped tie, and just to the left, you can see Bobby Wygant, who just died this last month. I talk about being here for 48 years for Channel 5. She worked there she used to joke she was poured in with the foundation when they built it. She was there on day one and was still working in the late teens, coming in, sort of like I am now, part-time, doing occasional work. So she had over 70 years at the station. I don't think I am likely to beat her record. Like I said, my short-term goal is 50. I don't think I'm planning to hang around for another 2 decades or more. So I think that one is safe with Bobby. At the bottom, you can see some of the anchors there. Next to Harold is Brad Wright and then Jane Giroux. Just a lot of memories, a lot of people, good people who I've worked with over the years. Of all of the people I've worked with, there's only 2 of them I can think of that I really disliked. And I'm not going to mention any names. But that's pretty good odds. If you think about spending 50 years in a career and there's only 2 people that you really didn't like, not very many people can say that. I've been very fortunate. Okay, let's go on to the next one. We've been on the air now, as I mentioned, for 75 years. Harold Taft was the first chief meteorologist. I took over for him when he died. He had stomach cancer, and he was working, like I said, up until 6 weeks before his death. That last summer, he died in early October, and I think his last day on the air was something like the last week of August. And that last summer, he would come up, I would prepare the maps for him, and he would come out at 5 o'clock, do the weather, not let on to anyone at home that he was in any, dire straits, but after the 5 o'clock news, he would go back into the weather office and lie down on the floor. We didn't have a sofa or anything, just to gather his strength, and then he'd come back again at the 6. And the people at home had no idea. But like I said, there was no quit in that man. He worked all his life. I was the second chief meteorologist. I took over when Harold died in 1991. And then when I retired from full-time service in 2018, we were fortunate to have Rick Mitchell step in. And some of you from Oklahoma City would recognize him. He is our current chief meteorologist. I'm now termed the senior meteorologist, which I think is pretty apt. But you think about it, 75 years on the air, we've had 3 chief meteorologists. It says something about the station, about the longevity of the people who work there. Not just in weather, but so many of our news anchors as well have been there for decades. And it says something about, our workplace and the type of people that we bring in. So just very pleased to have had this as my career. Let's go on to the next one.
It's now being confirmed that we've got rotation within that cloud. Official storm spotters out there are observing rotation. We've had no tornado touchdown, but a tornado
We're
warning
up to 2,000
has now been issued here in northern Tarrant County. Oh, well, all right, look at this. This is a live picture, and we do seem to have a tornado right in downtown Fort Worth right now. Our camera is being shaken. You can see the debris flying through the air. This is a live picture from the top of a building in downtown Fort Worth, and you can see the swirling debris in the storm. This is incredible. We have a tornado live in downtown Fort Worth. Everyone in Tarrant County, take cover immediately. This is a very dangerous storm. It's moving to the east. Now you can see here, it appears to be letting up at the moment. You don't see as much of the debris flying, at least. But there you can still see lightning flashing in the buildings. A very dangerous storm. There could be more than one tornado out of this cell. We're going to continue to watch it here. This is just incredible video.
David, have you ever seen anything like this?
I have never seen a tornado live.
So that was a really historic event, obviously. March 28th, 2000, the tornado in downtown Fort Worth. I had to excuse myself a moment later, tossed to the anchors. I said, I need to run out on the front porch, because if you know where the old station was on Broadcast Hill, it's just about 3.5 miles east of downtown Fort Worth, and that tornado was moving east. So I needed to run out and see if I needed to send everybody down to the basement. We did have a basement in that building. It was built in 1948, and the basement was a civil defense shelter built during the Cold War. Don't have too many basements around in North Texas these days. But yeah, I ran out to the front porch and looked, and at that point, there was no longer any funnel. I could see rotation in the cloud approaching. And we had debris, papers and small pieces of, limbs and so forth drifting down onto our property. And I picked up one of the pieces of paper, and it was somebody's tax return. Remember, this was March 28th, 2000, and one of the buildings that was hit was CPA, and people's taxes, you just don't think about things like that, just everything distributed across the area. This, you can see, this was a little earlier because we were still using the DIFAX charts. I was watching the movie Airplane a week or two ago, and there's a scene in that where they rip the radar summary off. This is what we used for our forecasts and to prepare our graphics. How did we know where to draw in the rain? It was from these DIFAX radar charts that would come in once an hour. But you'll notice it's not just the radar charts. We've got the surface weather analysis. We got the 850, the 500, or 700, 500, 300, 200 millibar charts, and very rudimentary models, the LFM, it was called, Limited Fine Mesh. And that was the only model we had, and that started coming in like in the late 70s. When I started, there were no models available. And that is why when we started, our forecast was 2 days. We did tomorrow and the next day. Because that's really all you could do with hand forecasting. Weather is too chaotic. You just can't see much farther than that unless, it's like that summer of 1980 where it was just day after day after day. And I remember Harold saying, just brutally hot until further notice, But those were the types of maps that we used and were very important. There was another source of information, though. I was reading an article. Dick Lyle was a former meteorologist with the National Weather Service here in Fort Worth. And he was telling a story in this interview about how Harold Taft would call the Weather Service on an almost daily basis and sit down with, one of the lead forecasters there and just, on the phone, discuss the forecast. And sometimes there would be disagreements, and they would explain each other's point of view, and frequently they would come to a consensus. Sometimes there would be differing forecasts. But Dick Lyle said that Harold called almost every day, and almost no other meteorologist did. And I'll have to admit, I don't think I've ever called to discuss the forecast, but then we didn't have Slack back then. And now we can communicate so much more easily. But Harold recognized how important it was back then to be part of a team, forecasting, working with the National Weather Service, working with RACES. We had a RACES radio operator who would come into the station on severe storm days. Couldn't have him in the studio because it made too much noise, but he would have to be in another room, and then when he would get a storm report, we had a runner who would come back and forth and pass on that latest information. Slack is a whole lot easier. One more slide, I think. This is me holding in my house, holding one of those old paper maps. And the thing is, at the end of each show, these were just rolled up in a ball and tossed into the trash. Some of us on the morning show, between the Today Show cut-ins and the noon show, there was a little bit of a break, and sometimes we played what we called map ball. We rolled up some of the old maps in masking tape, and it was like dodgeball. We'd throw it at each other. But most of them just wound up in the trash. And we found out years later that one of the people who worked there salvaged several dozen of them and kept them at her home for decades. And just in the last 5 years or so, they have been donated, most of them, to the special collections, the cartography section of UTA. And those maps have been digitized, and through the Portal of Texas History, run by the University of North Texas in Denton, you can actually access some of these old maps. And the thing is, I can look at them and tell, all right, was this one of Harold's maps, or was this one of mine? Because of the font, just the way that we drew the numbers. And this is one of my maps. It shows some fog over in Arkansas and Louisiana, south wind curving up off of the Gulf Coast. There are some scattered showers out in the Gulf. But around here at that hour, temperatures in the mid-70s. It was a pretty pleasant afternoon. So that pretty much concludes what I have to say here. It's just, I feel so grateful to be a part of history, to be able to help our viewers all through North Texas for almost 50 years now, to be part of a team to keep people safe. I have just been blessed to have this wonderful career, and like I say, at least 2 more years I'm planning to stick it out, and we'll see what happens beyond that. Thank you so much. I'm willing to take any questions you might have.
Okay, who has a question?
Well, thank you so much. You talk about the high standards. You will notice, though, that Harold Taft and I never had an AMS seal of approval. Harold was active. I mean, I've been a lifetime professional member of the AMS and value its contributions, but Harold was on the committee that was designing the guidelines for the AMS seal. And he wanted to insist on, as a minimum, you have to have a BS in meteorology. And it got watered down to where he said, I don't even want one. And he never encouraged me to get one. So that's why you'll never see us with an AMS seal on on the screen when we're doing the weather. He thought it should have been more rigorous. And I think it has become somewhat more so over the years. I don't want to denigrate it, but that's the reason that I don't have one. Harold didn't, and he didn't encourage me to. And if it was good enough for Harold, it was good enough for me. Yes.
The WSR 57, was that that radar at WBAP or at Channel 5, or was it only down in Stephenville?
No, this was our personal radar. Oh, wait a minute. Yeah, we had one here, and then eventually, when things improved, we did have access to the Stephenville radar, and that was better than what we had. So, I skipped a step in there. We had, various upgrades to radar availability over the years, but when we started out, it was with that little one right there on the roof of our building. But it was replaced by Stephenville, and then, of course, with the 88D into Fort Worth.
Oh, okay.
We have a question about what got me interested in weather. Well, my father was a geologist, and when we'd travel around the country, we would stop at road cuts and look for fossils and minerals and so forth. I think early on I knew I wanted to be involved in the earth sciences, whether geology, geography, geophysics, meteorology, oceanography. I loved watching the Jacques Cousteau specials back in the 60s. All of that appealed to me. But as I mentioned earlier, when Hurricane Carla hit, I was living in Houston, southwest Houston. It hit down near Freeport, so we didn't have major damage, but part of our fence was blown down. We had some shingles off. A banana tree in the backyard got blown down, limbs off other trees. It made an impression on me. And at that point, this is way before the internet. The only access you had, as a civilian to weather information was to, when a hurricane was coming in across the Gulf, was to listen on the local radio broadcast. Every 6 hours, they would say, here's the latitude and longitude, and the wind speed and pressure, and I would plot all that on a map and follow it along. And that just really piqued my interest. Then I got a little personal weather station at home and before school, and when I got home from school and before bedtime, I'd go out and measure the temperature and pressure and take a look at the sky and write a description of the weather, what types of clouds I was seeing. And, by the time I was in high school, I had pretty well decided on meteorology. And growing up in Houston, with a decision to go to school for meteorology, A&M was just the only choice. Where else would I want to go? There are many other good universities. I mean, Oklahoma, Florida State, Penn State, a lot of others, but I still think A&M's maybe in the top half dozen for sure. I won't try to rank them all, but that's where I went, and I've just enjoyed my career immensely. Any other questions? Here's one.
How did you react when technology improved and you went over from hand maps, hand-drawn maps, to the digital board and green screens?
Well, I had had a little computer work in college. This was back when we were programming in Fortran, and I would write up a program and have a stack of cards that I'd have to take in to the mainframe and put in, and make sure you don't drop those cards and get them out of order. But that was my computer experience, but it was a lot more than Harold had. And so, I mean, Harold was always willing to adapt to the newest technology, but he was limited in his computer skills. And occasionally, he would have a problem when we went to the early digital maps on screen. He would, be flummoxed by something, and a lot of times, a little before the 10 o'clock news, this was before we had call waiting, the phone would ring and Sherry would turn to me and say, "It's Harold." And, and I picked it up, sure, okay, tell me what you did and what button you pushed and so forth. And I'd have to try to figure out in my head what he had done that caused it to stall and have to talk him through that. So, he was not what you would call computer literate, but he was willing to learn and to try anything. It just took him a little longer. You can teach old dogs new tricks. It just takes a while sometimes.
David, I know you've talked about on Twitter, just beyond the work you've done for weather and which we all appreciate, you do a lot of volunteering for Meals on Wheels and stuff like that. Do you still do a lot of that? And if had any interesting experiences, somebody's watching the news and then you show up Meals on Wheels and do that kind of stuff?
Yeah, I'm speaking in April at a Meals on Wheels gathering. I haven't been there quite as long as I have here, but I'm going to be getting my certificate for 25 years of service of delivering Meals on Wheels. In the past, thank you. In the past, I have also worked some on Habitat for Humanity. Remember Scott Murray, who is our sports guy, would show up sometimes on our 10 o'clock news in a tux because he was out doing all of these public events, emceeing things. And that didn't appeal to me as much. I much preferred the kind of things where you get out one-on-one and work with people, where you can physically make a difference. And that's the kind of volunteer work that I've always enjoyed.
Can you tell us a little bit about what it was like when you guys first started using mobile spotters with the organization directly, where you had people actually out calling in and representing you out in the field?
Yeah, I mean, the spotters have been a tremendous help over the years. It's, it was very difficult early on just because of, the limitations of internet and trying to coordinate somebody who's got video and try to get it back, before cell towers and all of that. And frequently, we would get great video the next day, but trying to get it live on the air was the real challenge. It's so much easier nowadays to get live streams, but for most of my career, that was exceedingly difficult. And things like the March 28th tornado, the next day we had some great videos of that tornado coming through Fort Worth, and then the subsequent one that developed on Barden Road down in Arlington. But we didn't have any access to that at the time other than our camera there, where you could see the debris swirling, but you couldn't see the cone. It was behind the camera. So, that was the real difficulty. With the advent of cell technology, the ability to get information back so much more quickly, And with the tremendous increase in cell phone technology and the cameras and the kind of quality you can get, things have just changed so dramatically. You look back to those early images we had of radar and compare that with what we've got today. It is just incredible, not only looking at what's happening now, but as Jennifer was pointing out, how we can, through these models, anticipate what is going to happen down to a storm level in the next couple of hours. So, you know, it's a great time to be in the field.
Okay, we're going to let you draw out of the bucket the raffle thing for NBC5 for the wonderful Storm Watch car. Okay, you can read that.
See, if I'd known you were going to do this, I would have brought my reading glasses. 682-337.
Anyone?
682-337.
This means you do have to be here to win. So, nobody? Okay, we'll draw one more.
Let's dig down to the bottom.
Okay.
682-223.
There we go.
All right.
Congratulations. Okay, and just a second, we have one other thing for you. I'm going to hand this over to Martin.
So we've got some for David here. And in recognition of the contribution he's made to public safety and severe weather education, he's being presented now with the TESSA Award, which has not been presented since we gave one to Alan Moeller quite a few years ago. So congratulations, sir.
That is a high honor. If I share it with Al Moeller, can't get much better than that. Thank you all so very much.
Okay, so now we are going to let David go and cut his cake. And so if y'all want to go out there, as he goes out there, you can watch him officially cut that cake so that we can get it cut for y'all so you can have it after your lunch. So if you want to go to lunch, go down East Chase. There's a lot of places down that way, or you could go up 303. There's places up that way, but just be back by 1:15. But first, we're going to go cut his cake. So if y'all want to follow us out there.
Or they can look at Google Maps and figure out where the where the restaurants are.
That is so true. So
technology has changed.
David will meet y'all out at the cake, and you'll get to see him cut his cake. Thank you, guys, and happy lunch. Thank you, and thank you.
Check. Check. Check.
Welcome back, everyone. We have some that still aren't back, but I'm sure they're going to kind of feed in as we come along. So as we begin our second second half of the TESSA conference, I am pleased that the next speaker is going to enlighten you with all kinds of culinary taste and some places that we have actually been together and eaten at. So it's going to be a fun ride. It's probably the best presentation I've ever seen Martin do, as far as, I think it's great. And I've been with Martin since 2013, and we've had a lot of fun times chasing together, doing things, and especially stopping at interesting places to eat. And Martin Lisius is my boss. He is the president, CEO, everything of TESSA. And we are pleased to have him come forward and enlighten you with amazing culinary taste. Martin Lisius.
Thank you, Kim. So if we could go ahead and bring the lights down and just make it as dark as you can make it so we can see the images. So storm chasing is, TESSA is really about public safety and, severe weather education, and storm spotters is a big part of what TESSA is about, because we want to share information from these great presenters, so like Jennifer and Roger and Greg that are coming up, scientific information and how to spot better and so forth to help make your community safer. So that's really what this event's all about. But today I decided to do something that's just fun and is more related to chasing and being out there on the Great Plains. So, as you can see, it's exploring the culinary wonders of Tornado Alley. And let's go ahead and go to the next slide there. So why do we chase storms? It's all about the barbecue. And next slide, please.
I chase for barbecue. That's what I really do, is I go out and sample restaurants. If a storm happens to pop up that afternoon, I'll go after it. But really, it's all about the barbecue.
Okay, Tim Marshall. So he says what he thinks and thinks what he says. He's right about that. I kind of like his attitude. I think we've busted a few times, and why not just coincidentally pick a restaurant in the target area, the highest risk for tornadoes and supercells, and go there and eat. And then afterwards, maybe see something interesting. Okay, so there are many types of restaurants in Tornado Alley, and you'll see what we're going to be doing today is talking about just some of the small towns, mainly in the southern plains, of restaurants that I've been to. And when I go through and I look at all these reviews I've read on Google, which you can have access to anytime you want, these are the types of cuisine that they serve, and it doesn't vary much off of that list right there. So next slide. And so in Tornado Alley, comfort food rules. So you saw in that list, burgers, barbecue, donuts, coffee, pie, chicken fried steak, which we just call CFS. When I do our review, I just call it CFS because it's so common. And then next slide. So this is the area in Tornado Alley, what I call Tornado Alley, where I've done reviews. And I think there are a few north of there, like in Bismarck, North Dakota, and so forth. But most of them are within this red line. And then go to the next slide. So, but today we're just going to do this area here, which is North Texas, Panhandle, Western Oklahoma, Southern Kansas area, basically. Southern Plains mostly. Concentrate on that area. Next slide. And then if you go to Google reviews and you plot my restaurant reviews on a map, this is what it looks like. However, there are way more on there than that shows because Google Maps is very zoom level biased. So you have to keep zooming down, down, down for more thumb tack things to show themselves on the map. So there's actually a lot of red, what do you call those red things? Yeah, there's a lot more of those on the map than that map shows. So you just have to zoom in on the app. Okay, next page. And then, so what we're going to do is we're going to do Texas. And we're not doing everything that I've reviewed in Texas, just a few. And let's see. So we are going to go with Abilene. Abilene. You've got your Bell's Chicken Dinner House and Jay's Barbecue Shack. You've got in Amarillo, the Big Texan, which is, of course, a place that all tourists must stop at one point or another. Elmo's Drive-In, which is on Route 66, a classic hamburger joint. In Arlington, now Arlington, I don't really think of that as a tornado alley town, but meteorologically, climatologically is. But it's not a little town. But since we're there, I'd like to mention Moni's Italian, which is in North Arlington. Really good, hole-in-the-wall Italian food place. And then I want to mention Spring Creek Barbecue. It's a chain. It's a small chain in North Texas. And they're just very consistently good and fun. And they play country music. And they have these great, fresh... How many people have been to Spring Creek Barbecue? Say the hot rolls that they bring to your table. So even though they're not listed in Texas Monthly, they are as good as many other barbecue places out there. So I do want to mention them. Down in Bluffdale, which is between Granbury and Stephenville, southwest of DFW, there's Will Fong's, and we ate there once during a severe storm. Who is the guy? He's in here somewhere where I was with me at the time. Steve, I don't know. Steve George? Okay. Anyway, he's probably out there in the lobby, but we ate together there during a severe storm, and they probably had maybe almost golf ball size hail, and we were inside there, and it looked like it was barely holding together, but it's literally a shack, I kid you not. I don't think they have to have an engineer inspect their construction down there before they build a structure. But it is still there, and they have very good seafood. Breckenridge in the big country, Sissy's Cafe. Next slide. And then this is Spring Creek Barbecue. It only has a 4.4, which I think it deserves higher. But again, one of the problems with Spring Creek Barbecue is that it's clean. They have clean restrooms. They have a professional staff, and they have good hours, and they open when they say they're going to open and close when they say they're going to close. So that goes against them for their barbecue ratings because, to be a really good, honest barbecue place, you need to open whenever you want to, close whenever you want to, and run out of meat, and you have to stand in a line that goes around the block for moderately good barbecue. At Spring Creek, you don't have to do that. Just walk in, get some barbecue, and it's delicious. Okay, next slide. Okay, still in Texas, we have Bowie Longhorn Cafe. It's a really good, has anybody been to Longhorn Cafe in Bowie? It's just this really good buffet that they have there. Buffalo Gap out by Abilene. You've got Perini Ranch Steakhouse, which is cooked for, I think, George Bush a couple times for the White House. Burke Burnett, Whataburger, and I just picked that Whataburger because it's right there off of I-44, and it's really convenient for chasing, either go there before or after your chase. You've got your Canadian, which is in the Eastern Texas Panhandle. You've got the Bucket Cafe, Sugar Shack. Childress. Now, Childress is a really interesting town for storm chasing because it's a crossroads for storm chasing. And there are two major highways that intersect there, and it's just like perfectly positioned, at least if you're coming out of DFW and maybe even central Oklahoma for storm chasing. And they've got several options there for eating. You've got JT's Drive-In, and it's loud with lots of flies, but delicious. I have seen a Supercell every time after eating lunch here. Food for thought. Okay, so JT's is right on 287. I mean, if you sit out in front of the restaurant eating, these cattle trucks are within feet of you. And so they're really loud and there's lots of flies. So, but the burgers are very good and the French fries are especially good. And then you've got the barbecue place downtown, which is, you would never notice from 287 because it's downtown. Childress actually has an old historic district that you can't see from 287. You actually have to turn south to get in that Main Street area down there. So it's a neat little place. Ballyhoo Coffee Cafe, and I just discovered that last year, and it's kind of interesting because you go in there and it's very chic and very Austin-like. So if you've ever been to Austin, they have these very chic, artsy places. It's very much like that, and the coffee is delicious. And next slide. Okay, there's JT's Drive-In. You see it's got a really nice rating there of 4.6, which is good on Google reviews, and you can see it's just a really good, you can probably tell, a good burger and exceptional French fries. It looks like they shock the French fries, which is where you put it in, well, you can do it different ways, but generally you put the French fries in the fryer, then you roll them in flour, put them back in the fryer. So it makes them really crispy. Next slide. Okay, Dalhart. In the Panhandle, you got your Hodie's Barbecue, Electra, believe it or not. It's a little tiny town on 287 west of Wichita Falls. They have a little place downtown called the Pump City Diner. It's very funky, but it's kind of cool. Good burgers, Follette and Prime Tornado Country. That's in the eastern or northeastern Texas Panhandle. It's got a really, the menu's just like got 6 items on it, and that's it. So it's real simple, but good food. You've got, and then I'm going to mention Fort Worth. Again, not really one of those little Tornado Alley towns, but it is clearly in Tornado Alley. Curly's Frozen Custard on Camp Bowie, delicious custard. Jesus Barbecue, Tex-Mex meets barbecue, featuring heavenly brisket tacos and brisket nachos. So heavenly at Jesus. And then you have Dutch's Hamburgers over by TCU, really good gourmet burgers. And by the way, go ahead and next slide. So there's Pump City Diner and Electra. Next slide. And then this is Jesus. Jesus is really interesting because it's a Mexican food place, but they have a smoker in the back, and so they smoke a lot of brisket, and so they put the brisket in your nachos or your quesadillas or your enchiladas. It's really, really good. You think it's good? Kim likes it. Next slide. Okay, so still in Texas, Gainesville, up by the Red River, north of DFW, there's a little shack in this little residential neighborhood west of the county square, and it's called Jazz's Barbecue, and it's one guy that works there. I'm pretty sure he's the owner. And you walk up and you order your food and you leave. I think you might have one picnic table outside, but it's really good. Is Steve George in here yet? No, he's probably out in the lobby. He's eating there, and it is very delicious. In Granbury, Grump's Burgers. Grandview Subway, a great place to hang out and watch for storms. So the Grandview Subway, Grandview is almost to Hillsboro, and it's just this little subway that's out by itself, and it's surrounded by a big wheat field. So you can just literally sit there in the parking lot and watch for storms. It's really a good spot. Hamilton, Texas, which is down kind of on the northern edge of the hill country. You've got Nita and Glenn's Barbecue. And Henrietta, you have Pecan Shed. And Pecan Shed, if you go north on 287 towards Wichita Falls, you go through Henrietta, and Pecan Shed is like a gas station. But inside, they have everything pecan. So chocolate-covered pecans, pecan pie, pecan fudge. They have banana pecan fudge. So it's like this yellow fudge that's got pecans in it. And really clean restrooms. And I think, as I recall, fairly affordable gas. So you can just stop there and get your pecans and get your gas and head to your target. Next location, Hillsboro. So we've got a 1950 styles hamburger joint. It's called Williams on the south side of town. Next slide. And so this is Jazz's Barbecue in Gainesville. And you'll see it's a little shed there on the left side. And then he just writes up his menu there on a chalkboard. And you can see there's a smoker. It's on a trailer right next to the shack. So I do recommend that. Next slide. And then that's Williams Drive-In in Hillsboro. That's Steve George right there. It's also kind of a little shack on the south side of town. Really good hamburgers, 50 styles hamburgers. Next slide. We go back down towards the hill country. There's a little place called Eve's Cafe in Lampasas. It's excellent German food. And you've got your cheesecake and your strudel. And it's like really pretty close to amazing. So if you ever get down that area, stop by there. In Lubbock, you've got the cast iron skillet grill. You've got Texas-style cafe serving chicken fried steak, but they have a big selection of pie. That's in central Lubbock. And then Wup's Boomerang Barbecue, similar to Jazz's in Gainesville. You'll need GPS to find it. Their customers always come back. They always come back. Get it? Get it? Okay. But anyway, that's in Marlin, which is off of Highway 6. So if you're going from Waco to College Station, say if you're in Aggie, for instance, and just try to find it if you can. It is in Google reviews, so you should be able to map it. McLean. McLean is in the eastern Texas panhandle, and there's a place called Red River Steakhouse. And it's, again, this restaurant's out by itself, out of the town. And has anyone ever been there? In McLean, Red River Steakhouse? You've been there? Okay. It's on the west side. West side of town, it's just all by itself. And it's, anyway, it's, wide open. So you can, eat and then just hang out in the parking lot and wait for storms to develop. It's a great place for storms, you get the dry line that sets up kind of through Amarillo, north-south. The next place we have is Mingus in Mingus, Texas. So Mingus is west of DFW, and there's a restaurant called New York Hill Restaurant. Has anyone been there? Certainly there's got to be some people have been there. Have you been there, anybody? Okay, because when you go out there, you can't really spot very well if you're a spotter or a chaser. It's hard to see the sky because it's heavily wooded, but if you get up on that hill where the restaurant is, you can see fairly well. So it's delicious. Check it out. Next slide. And so that's Eve's Cafe in Lampasas. So you can see you've got on the right there, you've got your bratwurst and your spätzle and your Rotkraut there on the left. Very, very good if you like German food, or even if you don't, you'll end up liking it. Next slide. And then this is New York Hill Restaurant in Mingus, west of DFW off of I-20. One of the cool things about New York Hill Restaurant is it overlooks the defunct town of Thurber. So when you're up there, there's nothing down there anymore. But they have these pictures of what it looked like as you look down from the hill. And there was this town down below. It was like an oil boom town. It's gone now, but you can see it in the pictures in the restaurant, which is kind of neat. Next slide. Okay, going back up to the Panhandle with Mobeedy. How many people in here have been to Mobeedy? Mobeedy, because that's something special. They have a restaurant there called Cowboys Oasis Restaurant, and it's just a little tiny restaurant with a tiny menu. In Plainview, which is between Lubbock and Amarillo, you've got Big Flip of Barbecue and More. In Kittiquay, you have 2 restaurants that are highly rated, Bison Cafe and Coffee Mill. They're like just a couple stores down from each other in the downtown area of Kittiquay, which is like 1 block long on one side of the road. The interesting thing, there's some meteorological significance to Kittiquay. It's right near the Caprock Escarpment. So if you go west on the Farm to Market Road, just a few miles west of town, you go up in elevation up onto the Caprock. And I know all of you, or some of you I know knew Alan Moeller. He'd always tell me on a cap day, just go to Silverton. Well, Silverton's just west of Kittiquay. And I remember I went on a chase not long ago, just a few years ago, with Steve George, and here comes, no, Steve George still out in the lobby. He's busy working. Anyway, we were out there, and we were just kind of hanging out, and these little cumulus would go up. And it was in June, and it was very hot, and they'd go up, and then they'd die, and then a storm, and then it would die, and then a bigger storm, and it would die, and it was just kind of progressing a little bit, and then right at sunset, this big supercell just blew up, and it tracked northeast and produced a tornado near Clarendon, west of Clarendon. There's a tiny little town. Ashtola? That's right. Were you there? Yeah. So it was at night. So I was east of Ashtola looking west, and I could see the tornado and the lightning. So that was really cool. So you were out there that day? So you were there early when it was just blue sky? And you were waiting like me? Yes. Yeah, that ended up being a really cool chase. So Kittiquay. And the next town is Shamrock, Eastern Texas Panhandle. You've got your Farmhouse Cafe and Mesquite Canyon Steakhouse. And you've also got the U Drop-In Cafe, which is in the historic Conoco gas station. We'll see a picture of that in a minute. Stratford in the Texas Panhandle, The Best Donuts is the name of it, and it is clearly the best donuts in Stratford. Next slide. This is the U Drop-In Cafe, and you can see it's Art Deco on Route 66 in Shamrock. It's like one of the coolest buildings I've ever seen. If you go up and look it up close. Anyway, that's where that restaurant is. Next slide. And then Waco. So you've got Jake's Texas Tea House near the 1953 tornado path, just a couple blocks away. You've got Vitex, which is out on I-35 near Baylor. And you've got Health Camp Burgers and Shakes, and of course they're anything but healthy. They are definitely a carb and calorie load, but it is delicious, and it's on the traffic circle, south, kind of the southeast part of town, southeast central Waco. Now west is coming up here. Now what's really interesting about these 3 towns, they're all within like a 25-mile radius of each other. They all have some really good restaurants, and they all start with W's. So that's Waco, West, and Whitney. Waco and West are in McLennan County, and Whitney, I think, is in Hill County. Can anybody tell me where Whitney is county? Hill County? Okay. I know how to drive there. I can drive straight there right now, but I didn't know exactly the county. But anyway, you've got the Czech Stop and Garrick's Old Czech Bakery in West. So how many people here have been to the Czech Stop? Like almost everybody in the state of Texas? Okay. Well, if you just go like 2 blocks inland into the town, there's a place called Garrick's, and there is a difference between the two. So they have kolaches there. I would say the Czech Stop's kolaches are better, but Garrick's forte are the cinnamon rolls. So the cinnamon rolls are huge, and they're just completely covered in cream cheese icing. And they put them in your hand, and they weigh a good couple pounds. Okay, they're like $5, and they'll feed 4 people easily. And then in Whitney's, there's a brand new Allsop's gas station, which I just stopped there for gas, and they were making hamburgers, and I ordered one, and it was like, wow, this is a really good hamburger. So check that out next time you're in Whitney. Next slide. That's Jake's Tea, Texas Tea House, downtown Waco. They have a lot of pie. Next slide. And this is Vitex in Waco. There's my wife, Lori, on the right. Next slide. And this is Chuck Stop. Now, the Chuck Stop, by the way, their food is really good. And it's like the quintessential road food stop, you know? Like, I know people like Buc-ee's, but I mean, the Chuck Stop, they're really good at road food. They've got your fresh baked kolaches, but they also have these like sandwiches they make, like these ham salad, chicken salad, egg salad, sandwiches that are wrapped up like that in cellophane, and they're freshly made, and they're really good. So these Czech people, Czech descendants, are really good at this type of food. But the complaint that I have about the Chuck Stop is you can see in the upper left, there's a big line of people inside the store. They're very, very, very popular. They're like Chick-fil-A, you know, with this big, long line. And they do really good job at getting people through, like Chick-fil-A. They have an excellent staff. However, they need to expand it just a little bit larger, and also better restrooms, because their restrooms are really bad. So if they'll do those 2 things, I'll give them 5 stars. Next slide. Okay, this is Garrick's, and you can see the cinnamon rolls on the left. And they just basically, if you go in there, they have this display case with the pastries in it. And it's like maybe 20 feet long. You can see all the different kinds of pastries they have. And it looks like what they have done is they've lifted up the front of the display cases, got a big hose, and sprayed everything with cream cheese icing. I mean, it's just like, it's got to be gallons of that stuff daily. And that's what makes it good, right? What makes French fries good? Ketchup, right? So that's what makes these pastries go from good to just like unbelievable until you've had 4 or 5 bites, and then you know, it's a little heavy. Next slide. Okay, we go to Oklahoma. Altus, Roberts Drive-In, a little cafe serving chicken fried steak, burgers, and pie. In Alva, northern Oklahoma, you've got the 818 Diner. In Ardmore, you've got the Hamburger Inn in downtown. Has anybody been to the Hamburger Inn Ardmore? You probably haven't been there because it's downtown. It's maybe 4 miles east of the interstate. But downtown, in a little tiny historic building, is Hamburger Inn. Check it out. Clinton, you have the White Dog Hill Restaurant. It's up on a hill. Another good place to hang out if you want to watch for storms. And then you have tornado snow. 2 things that rarely occur at the same time occur here. Snow cones, so they call it tornado snow. It's a snow cone shack. I would not recommend it to be in it during a severe storm. It's just a little shack that you drive up to. Chickasha, Mama Carol's Kitchen. Next slide. Duncan, you've got Tim's Place. El Reno, you've got Sid's Diner. In Frederick, you have Very Good Coffee, which is very good. In Gate, you have Lori's Cafe, diner and historic building, easy to find. How many people have been to Gate, Oklahoma? Gate, large town, small town? Pretty small, so easy to find this place. And then you have Grenfield General Store, good convenience store, conveniently located for chasing. Cashier gets nervous when storm chasers visit. So here's a story. So how many people have heard of Bill Reed, storm chaser, William Reed? Okay. He is a great storm chaser if you know him. Do you think he's a Roger? Pretty good storm chaser? Just really good and fun and funny. So we were chasing a storm in southwest Oklahoma, and it was approaching Granfield, and which is north of Wichita Falls. And we were up ahead of the storm, and we were just getting hungry, so we stopped at the general store, and we got some chips and some pop, and we're coming up to the cash register, and we're not in a big hurry because it's another 15 or 20 minutes before it gets to the town, and then we're going to just continue east with it. And it wasn't really doing anything. It was tornado warned, but it's one of those tornado warned storms that aren't ever going to do anything. So we knew that. We had kind of a feel that that was going to be the case. So we were kind of taking our time. And we get to the counter, and the lady, she's probably, I don't know, 19 or 20, and she goes, "Are you guys storm chasers?" And we say, "Yeah, we are." And she goes, "I hate it when you guys come here because something always happens and it's bad." And right when she said that, the tornado sirens went off. And then right when the tornado sirens went off, right like 3 seconds after they went off, Bill was behind me and he chomps down on a potato chip. So you get the siren, you get Bill's chip crunching, and we're just casually walking out of the store, and this girl's down behind the counter when we leave. And we get in our car and we just drive east and wait for it to catch up with us, and we chase it some more. So, you know, kind of what I learned that day was we're kind of like the four horsemen, you know? We're storm chasers that, you know, you come into town, they're coming into town, you see a lot of them. This is a clue to be weather aware. Okay, so next slide. So that's the Very Good Coffee in Frederick, and it is good coffee downtown. Next slide. In Mangum, we have Mangum Donuts and Thai food, fresh-made donuts, Thai food, smoothies, Thai tea, and Vietnamese coffee in Mangum. So Mangum is pretty international. Medicine Park, you've got several good restaurants. I was going to do a review on one, and then I noticed when I was looking at the restaurants there were like 4 there that were highly rated. So they're kind of bunched together there. So just go to Medicine Park. It's north of Lawton, and get yourself some food. Shattuck, Gusto's Italian Grill and Pizza. This is kind of it's north of the Windmill Museum. Have anybody been to the museum in Shattuck? The windmill, it's pretty cool. It's just like this little city block with a grassy area. It looks kind of like a park, and they have a bunch of old windmills that are spitting, so it's kind of cool. But down the street from that is Gusto's, and Gusto's is kind of fancy, so it's kind of funny to see it in this little western Oklahoma town. And then in Thomas, does anybody know where Thomas, Oklahoma is? You do. Well, where is it? Would you say it's maybe just north of Weatherford? Okay, so they have a place there called Heart and Home Bakery, and it's just this kind of this. Has anybody been there? So it's this bakery that serves, you know, you can see breakfast, pastries, sandwiches, pies, cakes. It's a lot of fresh baked items. And then in Woodward, one of my favorite restaurants is Pollyanna Cafe. Anybody been to Pollyanna Cafe? Roger? Downtown? You got to go there. It is so cool. You'll see a picture of it in a minute. Okay, next slide. There it is. Look at how many photo views that one picture has, nearly 1 million. And, you know, I kept getting these emails from Google. This photo is getting lots of attention. And I'm like, why? And it's nothing special about the photo. I mean, it's a cool place, but why would it be getting so many views? And it's in Woodward. It's retro, yeah. No, it's Route 66 is down by I-40. Yeah, Woodward's in the northwest part of the northwest central part of the state. But it's in historic downtown Woodward, It's just this cool, long restaurant. So you go in the door, it's kind of shotgun-like. And it's just, you can see, it's just long, and on one side are booths, and the other side is the bar, the soda fountain bar there on the right. It's good. It's good food, and it's a neat place. Next slide. Okay, we go up into Kansas, Copeland. You've got your chicken fried steak, burritos. I mean, it's almost the same thing repeated, right? Burritos, burgers, pancakes. Dodge City, Provencho Mexican barbecue. The name says what they serve. You've got your Wildcat Cafe in Elkhart. Good home cooking in the southwest corner of the state. Great place for tornadoes. Tradition Soda and Sandwich in Garden City, and it's kind of like a 50s soda fountain place that has a hot roast beef sandwiches and Reuben sandwiches and pie. Greensburg, Reggie's Pizza. Next slide. You've got the Pancake House. Okay, another place I like to go. Is anybody into the Pancake House on Liberal? Okay, what street is it on? Don't look. Pancake Boulevard. So Pancake House is on Pancake Boulevard across the street from Dorothy's house. So I don't see why any storm chaser wouldn't stop there. I highly recommend it. You've got Jetmore, you've got Judy's in Jetmore, you've got Two Moms, etc. in Meade, Trinity Smokehouse in Pratt, and in Ulysses, which is in western Kansas, you have Wagon Wheel Cafe and Bakery and Watch and Clock Shop, serving brisket, barbecue, meatballs, meatloaf, lasagna, chicken fried steak, and a long list of homemade pies, all served in a timely manner. Timely manner. Next slide. And then there's Dorothy's house right across the street from the Pancake House. And it's really cool. How many people have been to Dorothy's house? Probably a lot, right? So you got to go there. It's sort of like the Mecca for storm chasers, right? Kinda. Okay. And they have the Tin Man there and, you know, the lion, and it's kind of cool. It's a little cheesy, I know, but it's still kind of cool. Next slide. And okay, so I have some more things here that are not related to restaurants, just some fun things I just thought up at the end. I have 8 minutes, okay. All right, and let's continue. Okay, this is a pet peeve I have, and our WCM has left, but that's okay. Jennifer has left. But storm spotters, how many people in here are storm spotters? Okay, so a fair amount, good. And please don't use hen egg when referencing hail size in your reports to the National Weather Service. Size references should be clear and accurate. Consider quarter size, golf ball, baseball, or softball, all of which span the various sizes of hen eggs, and all bird eggs are laid by hens. Well, I kind of figured that all bird eggs were laid by hens, but I looked it up just to be certain. I was correct, however, it's also used to refer to the female bird of a poultry bird, so a bird that that you eat, that you consume. So you can see in that picture, those are poultry eggs. Those are bird eggs that people typically would eat, so they call it poultry. So it can be for a poultry hen or just any bird at all that is a female. So you can see it's kind of redundant to call them hen eggs. And then also the most important thing is they're not consistent in size. And that's what I want to show here. So in Weather Service reports, warnings, they'll issue storm is producing hail to the size of hen eggs. So, hen egg is like from this big up to about this big. Okay, that's an ostrich egg. So it's not a standard. So that's just my pet peeve. I wanted to get out of the way officially. Next slide. And then some of my recent video work. Next slide. And then so right now, last year, I made a couple little commercials just for fun. I wanted to make a storm chaser commercial, car commercial. So here they are. We're going to look at a 30-second version and then the 1 minute, 11-second version. Here they are. And next slide. And this is a video.
Meet Martin Lisius, storm chaser. Some head for shelter. He heads for an Acura MDX. It has advantages over its competitors like a bigger cargo area, torque vectoring all-wheel drive, and the legendary Honda J35 transverse mounted engine. Because if you want to keep up with Mother Nature, you need every advantage you can get. Acura MDX. Be one with the wind.
So we shot all that footage, and then here's the longer version. Okay, so the rain shot where you see my car in the rain, that was actually shot at the back of Kim's Jeep. So we just put up the lift gate, and I had the tripod set up, had it anchored down with straps. We were using a red Komodo to shoot this commercial with. And we basically went out on a summer, it was in July, I think late July last year, and we were doing a chase in around DFW, and we were trying to drive underneath some rain. That's all we wanted to do. And each storm we got to kept evaporating, but finally this cell, we kept moving north, and each cell got a little bit better as we moved north. There's a little bit of outflow boundary, and we finally found a big storm up by Decatur, south of Decatur, and it was just like a torrential rainfall, and that's where we shot that shot from the back of her car. And then the tornadoes that you saw in there were all shot last year. So actually most of the storm footage, maybe half of the storm footage was shot last year. Okay, next slide. And then this is a documentary that I'm working on right now. I'm already on the 3rd chapter. I wrote it in chapters, and I'm actually editing it in chronological order. So I just finished the Chaser chapter. Carson Eads is in the Chaser chapter. He's standing out behind his, do you still have your Toyota? Okay, so he's standing behind his Toyota pickup truck, talking about chasing, talking about spotting. And then the next chapter will be, it's called Guardians of the Universe. So it's about storm spotters and people like Jennifer Dunn. She's interviewed also in the doc, where it talks about public safety and what storm chasers and storm spotters are doing for public safety. That's the next chapter. You'll see Carson in that chapter as well. But anyway, what we're going to do is just show you the intro. It's just like a minute and a half or so to the doc. And here it is.
Is there anybody else down here? Everybody accounted for?
It's true that Mother Nature is powerful, but she isn't destructive. Destruction is a human concept. Nature just is. The more you learn about nature, the more you appreciate it. You might even be amazed by it. So that's the beginning of the doc, and then we tell the story. Okay, next slide. I think so the next presentation, we're about 1 minute left or two for me, is going to be by Greg Stumpf. And he is going to be talking about threats in motion, improving lead times for severe storm warnings. And I have like 1 minute for like 2 questions.
So who's the lucky person? Who would like
Any questions?
Who would like to ask a question? Okay. Okay.
What?
You need to go to Yukon and go to the Green Chili Kitchen sometime.
Yeah.
The best green chili even in New Mexico. It's better than what you can get.
Yukon, green chili. Okay, got it. Okay. Oh, man.
How many of the restaurants did you just stumble upon?
That's a good question. Well, outside of DFW, I would say 90%. Diartes?
I first discovered them on Discover Oklahoma, which is a TV show we have up there, and you can access that on YouTube as well. But Diartes is just off the main drag, actually last one
Okay. Is that kind of near the McDonald's? West of there? Okay. Okay, cool. Thank you.
Okay, one last one. That's going to be it.
Another addition to the list up in Norman. It's not as quaint as some of these places, but in Norman, Oklahoma, Neighborhood Jam in Norman. Best pancakes, apple butter, and jam you'll ever have in your life. So if you ever find yourself in Norman, definitely check that out.
Okay, well, we have some Normanites in the room.
Okay, you can ask Martin some more things later if you
Thank
want
you.
to out in the lobby. We're going to go ahead and do our drawings real quick. The first one is going to be for the single-day chase with Tempest Tours. So please get out your tickets. I'm going to let my daughter draw that. And
There's a lot in here. Okay.
she's mixing them up really good. But you have to be here, so we'll see.
All right, here we go. There you go, Mom.
Okay, it is 681691.
Say it again.
681691. There you go.
Congratulations.
Okay, you'll need to see my daughter in just a second. She's going to take some information from you and give you this stuff. But anyway, and the other thing we're going to draw real quick is the Tempest T-shirts that are out there with some other stuff in them. But these are the T-shirts that we gave to the movie Twisters that's coming out, and it's actually in one of the promos. And so there, you'll see those in the movie. Also, you'll see our Tempest logo on the white vans. We were the only tour company they approached, actual tour company they approached to be in the movie. So you'll get to see that when that comes up. So cool. So the first one for that one is 681746. Anybody?
Say it again.
681746. Okay.
Yeah. Awesome.
Go see my daughter and one more, and then. And 681762. Right over there.
Awesome.
Okay.
Congratulations.
Go see my daughter after, and she'll give you all of the stuff for that. Okay. Thanks so much. Okay. Now for our next speaker, I got my cheat sheet over here. Yep. You know, I love this man, Greg. He's wonderful, but he has the longest thing about who he is. but I'm going to say, because it's long, he's done so much, and but he is a research scientist for the Cooperative Institute for Research in the Atmosphere at Colorado State University, and has a BS in meteorology from Oswego, and his MS in atmospheric science from Colorado State University. But he works from home in Norman, and I'm not going to go into all this other stuff because he's going to be telling you all about himself. We are so glad to have him here again at TESSA, and here's Greg.
Thank you. It's great to be back at TESSA. It's been a while since I've been down here for this, so glad to be a part of it. Okay, well, let's go ahead and get started with the presentation. So I'm going to be talking about something called threats in motion. Has anyone in the audience heard about what this is yet? Okay, just a few hands have gone up. You're going to hear more about it in the next few years, I believe. But basically, we're considering this almost an evolution, maybe revolution in severe storm warnings, and how we're going to be delivering tornado and severe thunderstorm warnings to users, public, emergency managers, everyone else. Next slide. So I do want to say right off the bat, big disclaimer. I think I said this the last time I talked to TESSA. The concepts that we're presenting here are under development and evaluation. They're not yet the accepted and adopted plans of the National Weather Service, although they are partnering in helping us develop and research these efforts. So there's still some work that needs to be done, but we've done a lot of it already, so you're going to see some of that here. So I'm going to start this off with a little 3-minute video that was produced by the media folks at the National Severe Storms Lab, and it's going to give you a nice introduction of what Threats in Motion is and how it's going to help everyone. So go ahead to the next one and play the video. Oh, I had this in here too. So let me just mention that this is part of a broader program that's called FACETS, which is called Forecasting Continuum of Environmental Threats. And basically what this concept is, go to the next slide, I think that'll start the animation there. Basically continuously updating stream of high-resolution probabilistic information extending from days to within minutes of an event for all environmental threats. And what Threats in Motion is kind of honing in on that severe thunderstorm tornado warning time and space scale. And it's one of the proposed first evolutionary steps of FACETS. Now we'll get into the video. It's about 3 minutes long.
In nature, hazardous weather is almost always in motion. New research and technology are making it possible to provide continuous information about a storm and its movement. Threats in Motion is the next step in the evolution of how weather information is provided to the public. Let's take a look at how tornado warnings are currently issued. A warning polygon is added to alert those in harm's way. As the storm gets closer to the edge of the polygon, a new warning is issued. Once the storm has passed, the old warning goes away. This process is repeated for the life of the storm. Now, let's take a look at how Threats in Motion works. A warning polygon is issued at the location of the threat. The warning extends out in time with a 30-minute projection of the storm's path. The warning moves in the same direction and at the same rate as the storm. People are alerted as soon as the warning polygon includes their location.
Threats in Motion basically takes the computer power we have to allow us to update it more frequently, give more frequent updates and advance warning for people who are downstream from where the current warnings are right now, and give them advanced lead time to take action.
Here's an example of how Threats in Motion gives people more time to react. Let's say Jane lives here and Hector lives here. With the traditional warning polygon, Jane gets an alert with plenty of time to take action. Hector, on the other hand, is just outside the warning polygon and doesn't get the alert until the next warning is issued. Hector has less time to take precautions. Now compare the same situation with threats in motion. With a moving warning, both Jane and Hector receive an equal heads up. Threats in motion also will improve how long you and your family need to stay in your shelter. Notice Jane's location. Once the threat moves past her, she receives an all-clear notification.
It's a better, more seamless way of letting people know not only when they're in the threat area, but almost as importantly when they're out of it and when they can come out of their shelter.
The way a warning is issued with threats in motion will affect everyone. That's why NOAA researchers are partnering with the National Weather Service, TV broadcasters, and emergency management.
We have to make sure we understand how end users, such as the public or businesses, can receive this information and know what to do with it. We also have to make sure that we understand if forecasters are ready for this, because it's a pretty big paradigm shift. So we have quite a bit of research ahead of us to set us up to do this successfully.
For more info on this project, check us out online and follow us on Facebook and Twitter.
Okay, now that I've whetted your appetite, we can go to the next slide. Let's get down into some of the details of this, threats in motion. So as we saw in the video there, the way the warnings are issued now for hazards that are typically hazards that last longer than your typical warning duration. So today, severe thunderstorm warnings and tornado warnings are usually issued on the order of 30, 45, maybe sometimes 60 minutes. And if the storm is going to last, and we see quite a few of these in this part of the country, especially those 10-hour hailers that like to traverse through North Texas in the spring, we're going to have a series of warnings that are going to be issued for that storm. So the issue with that, as you saw in the video, is that you could have two users, two people, locations A and B, they could literally be just living right across the street from each other. And user B has to wait for the second warning in order to get warned. So they're obviously going to get less lead time because that storm is going to be a lot closer to them when their warning goes out. But user A gets tons of lead time. That's what we like to call inequitable lead time. Two users not getting the same lead time for the same hazard. On the next slide, we're going to put that polygon in motion. So you'll see just 5 minutes after that warning was issued, user B gets warned as well. So now they're both getting the same amount of lead time. So that's what we call equitable lead time. And because of this, overall, we are going to increase the average lead time for warnings just by changing the way we issue and broadcast the warnings. Next slide. How else does it help? Well, take a look at this. On the left side, you're going to see a right-turning hazard, maybe a right-turning supercell, just before it decides to put down a tornado or two. And if you issue a warning based on the current storm motion, that storm turns to the right, it exits the polygon, you got to put another warning out, and so on and so on. And I've seen this happen on the left at times. But threats in motion allows the forecaster to rapidly adjust the motion vector of the warning and stay along with the storm. So as you can see, one warning and it's turning with the storm. So that'll be very helpful too. Next slide. So the current warning practice right now, if you've paid attention to how warnings get issued and updated for an event, if you're watching them on your favorite radar app or on television, you'll see that a warning gets issued, and as a storm moves through the warning, the best the Weather Service can do right now, as per directive and software, is that they can kind of shrink the warning. So clear out areas behind the warning, which can be very helpful. If you're paying attention and seeing these graphics, you'll know when the storm has cleared your area. But you'll notice that you can't add any area to the warning until that last frame there. That's actually a brand new warning that gets issued downstream from the other. So we can't expand the area and we can't extend the end time of warnings right now. The only way to keep warning on a storm is to issue a brand new warning downstream. So we're going to actually roll out threats in motion in two phases. So the first phase on the next slide is where we're going to give the forecaster the ability to extend warnings now anytime during the updates. They can extend the area, they can extend the time of that warning. And one of the nice things about this is they can just keep doing this forever until the storm eventually dies, the hazard goes below severe limits, and they stop. And we can track the hazard using the exact same tracking number all the way through. That's very useful for anybody that's like trying to put together a history, for example, of the information that's coming from that storm through things like NWS chat and other places. So this is what we're calling affectionately Tiny Tim, Tiny Threats in Motion. And this is what we plan to do first. And the next slide will show the next stage, which we affectionately call Taller Tim. And this is basically now filling in the times between when the forecaster updates that warning, which is usually every 10 or 15 minutes, with these 1-minute continuous moving warnings. So the forecasters have an option to turn this on in our software. So on the next slide, we've actually put all these three together here, and they're synced up at the same time. So you can see the current on the top, the warning shrinks until a brand new warning gets issued. In the middle, Tiny Tim, as we update the warning each time, so it's kind of stepwise moving along every 10 or 15 minutes. And with Taller Tim on the bottom, which is the eventual end implementation of this, it's going to be 1-minute updates going through there. And I've put kind of what our hopeful time for implementation of these two different threats in motion implementation. So Tiny Tim, we're hoping 2 to 3 years. Taller Tim, 5 to 7 years. Next slide. So in summary, it increases the average lead times, but more importantly, as we've shown already, it makes the lead times more uniform, more equitable for folks that are downstream of these hazards. If any of you have access to scientific journals, we've actually published this work showing the statistics behind threats in motion and how it will favor warnings in the future. Next slide. So this is, we're going to look at just one example here of a hypothetical storm. And what this hypothetical storm is doing is actually moving straight west to east at a constant motion, constant speed, doesn't change direction. And it puts down a tornado for 100 miles. That's what that white line is. And all the red boxes, if you can see that, are the individual tornado warnings that are going to be issued along that. So this is current practice today. So if we do that, you'll see that there'll be discontinuities in the lead time. So each time a new warning gets issued, the areas that are just outside that warning are going to get less lead time than the ones that are just inside that warning. Now with Tiny Tim, we're going to issue these more frequently, and with threats in motion, it'll move continuously 1 minute at a time. And on the next slide, we can actually plot. So these are every minute along the path of that 100-minute long tornado, what the lead time is with the different kinds of warning styles. So that blue, the big sawtooth there, is the current practice with Weather Service warnings. So if you're at the end of the warning that's closest to the storm, you're going to get the least amount of lead time. And if you're at the end of the warning that's furthest from the storm, you're going to get the most amount of lead time. And it just over the edge of that, the next warning gets issued, it repeats. So you get this big sawtooth like that. With Tiny Tim, Tiny Threats in Motion, because the forecasters are updating and extending the warning at more frequent intervals, the sawtooth gets smaller. Smaller sawtooth means more equitability for lead times along the path of the tornado. And not only that, the sawtooth is now up higher on the graph, which means an overall higher average lead time. And finally, the red along the top are the 1-minute updates that you get with Taller Tim. And you can see now it's pretty much equitable, almost a flat line at the top, and everything's raised. So we got higher average lead time and more equitable lead times with the 1-minute storm updates, warning updates. Next slide. So this is the path of that 100-minute long tornado, and I've color-coded, it's the same data you just saw in the graph before, color-coded what the actual lead times are, the blue being the lower lead times and the white being the highest lead times. So this is current practice. So you can see we start low, get really high, next warning gets issued, low, then really high, and so on and so forth. With Tiny Tim, next slide, you'll see there are, the colors have gradually all come up, so there's less dark blue on there, and there's less, more discontinuities. But it's more equitable, and the averages come up. And then for Taller Tim, next slide, all white. So you got the maximum amount of lead time along the entire path of that tornado. Next slide. So the bottom line is this: Threats in Motion offers benefits for storms expected to live longer than your average warning duration, which is about 30 to 45 minutes, sometimes 60 minutes, such as the long-track supercells that occurred during violent tornado outbreaks when it matters most. So we've got our rule now. If Threats in Motion is operationalized within the Weather Service, for long-lived storms, the forecasters will extend the warnings and improve on the lead time. But for storms not expected to live that long, they're not going to extend the warning. So they'll just issue warnings the same way we do today for those short-lived storms. Next slide. So additional features that we've added to this whole system. If anyone is used or familiar with the way the Weather Service forecasters issue warnings today, they have a software tool called WarnGen. And in WarnGen, they can track storms using either a point or a line. But storms don't cover just a point or a line. They cover two-dimensional areas. So we've now added this way to track storms using a footprint. You can either do it as you draw out a polygon to fit the shape of the storm, or with something like a tornado warning, we'll use a circle or an ellipse with a certain range away from the tornado, maybe 5 to 8 kilometers. And we use those to track the storms, which is, it's an improvement over point tracking, because with point tracking, you may have to make your polygon wider in order to capture the entire hazard area of the storm, and that takes additional time for a warning forecaster to issue that warning. But if we just click out that storm area and project it, and we make it a little larger with time because we're accounting for some uncertainty in the storm motion, it makes for a more accurate representation of where that threat is and where it's going to go to. So we've added that to the software. Next slide. Not only this, you're going to likely start seeing warnings that aren't straight out from the storm, but may have some curves and bends to it. So that top picture there shows a warning that is taking into account a right turn in that storm, and that's built into the software right now. So you might see something like that. And then the bottom one, we have another option, for the case of a back-building storm, or where the back end of the storm is not moving, but the front end is moving forward, we can also put that into effect. So we can move that front end of the storm, but keep the back end of the warning anchored. Next slide. So we've developed all the software. We've done the research, the statistical analysis of how good Threats in Motion is, but we need to put this into practice in front of forecasters to make sure that this really can fit within the conceptual model of warning operations within a forecast office. And in order to do that, we utilize the hazardous weather test bed in Norman, Oklahoma, and we bring in forecasters to participate in experiments, and they come from all over the country. So we're not just looking at Oklahoma storms or Texas storms, and we're not just using forecasters from there, but we invite them from everywhere within the country. Even Alaska and Pacific area offices have sent representatives to our experiments. And we've used the hazardous weather test bed to test both the concepts you've seen here, both Tiny Tim and Taller Tim, We started doing this testing in 2021. In the first 2 years, we did it virtually because of the pandemic, but we started doing things in person last year, and things went really, really well. And we added a real-time component, too, to the test last year. So before last year, we were using canned cases. We could kind of control the specific events that we're looking at to try different hypotheses and stuff like that. But when you look at real-time data, you don't know what you're up against and what you're going to get that day. And luckily for us, we had one of the biggest challenges last spring. We were operating on April 19th, 2023. If anyone's familiar, that is the event where there were multiple tornadoes and supercells in central Oklahoma that were erratically moving. Very interesting. Lots of deviant motion on these tornadoes, left hooks, and even 2 supercells that started Fujiwariing or rotating around each other east of Norman. And we were operating on that day. So we've been doing these experiments. We even did another experiment with our TinyToon, which is the more mature software, up at what's called the Operations Proving Ground in Kansas City, Missouri. And that's a proving ground that actually brings these kind of software developments a little closer to operations than the hazardous weather test bed, and that went really well as well. So we've done this. We're about to do another experiment with the Tollerton software starting in April, and we'll see what kind of real-time weather gets thrown at us for that experiment. Next slide. So we're not just working with National Weather Service forecasters. That's important, but we've got to work with the forecasters, the Weather Service's partners, and eventually with the end users of this information, the public and other stakeholders. So before we really set out to really start determining how to go about developing the concepts and the software, we had to get some buy-in from stakeholders, as we call them. And we're talking about people from other government agencies, FEMA, places like that, academics from universities, and private sector companies. And we had 2 workshops, stakeholder workshops, we call them, one in 2019 and one in 2021. The second one was virtual. And we had folks from all of these different sectors, and we were giving them the information of our concepts and hearing back from them on what they would need in order to make this happen. And it's not just, here's a new way of doing warnings, but we now have to think about how are we going to disseminate these kinds of warnings. And right now, a lot of our dissemination systems are not built or set up for moving warnings. That includes no weather radio, WIA alerts on your phone, private industries apps on your phone, television broadcasters, folks like that. And we've been in contact with all these folks, and we've even brought in broadcasters and emergency managers into our test bed and had forecasters in one room issuing the threats and motion warnings, and broadcasters in another room with a green screen and actually doing mock broadcasts with the data, and emergency managers even yet another room. And we're all communicating through an NWS chat-like app at the time. And every time we ran through one of these scenarios, we'd all get together at the end of the day, and all the groups would be talking about this stuff. And we've learned a lot from them with these folks. We've done also some virtual focus groups and surveying of these folks. So getting a good idea of how this is going to work once we have it implemented on the software side, how are we going to disseminate things, and a whole host of stuff before this can eventually go into operations, into the public. So that's why this kind of takes some time. Next slide. So it's not just about improving lead times. And actually, when we set about developing this, these are things we hadn't really thought of until we got it in front of forecasters and broadcasters and EMs. It turns out that when you're issuing just one warning for one hazard and following that along with the storm, you end up getting better messaging and actually a cleaner polygon display. So you have fewer polygons per storm, so you don't have these overlapping polygons where you're transitioning from one warning to the next. We've also found out that there's fewer time gaps, because if you keep the polygon in motion, you don't have to worry about your warning expiring. So the other thing is that one storm or one hazard will have one unique tracking number. This is kind of a software thing, but that's important for anybody who's like tracking any kind of data that goes along with that storm. And when I say any kind of data, that could be something like NWS chat communications about that specific storm. If it can be tagged to that number, someone could take software and just boom, just show the entire history of the discussions on that particular hazard, which is nice. You can't really do that very easily right now. And as I showed before, better response to storm motion changes. The other thing we learned from our forecasters is that threats in motion really reduces the workload that they have. They don't have to manage multiple warnings on the same storm anymore, just that one, and to keep it moving, which helps them increase their situational awareness so they can spend more time understanding what they're looking at to make better warnings. And also with a moving warning, the back end's automatically clearing out now as well, which makes it easier on them not have to worry so much about always manually clearing out the backs of those warnings. Next slide. So, clearer messaging. Let me show you an example here of an actual case. I won't tell you where, but if you recognize it, you might know where this is. And a series of warnings were issued, tornado warnings for this storm moving forward to the northeast. And as you can see, I highlighted one county there in yellow. Well, what happened was that there was that first warning cleared out of that county, and it automatically canceled the warning for that entire county, because everything right now in the warning system is county-based. But you can see a problem with that. A cancellation message went out for that county, yet that hazard, that tornado, was still in that county in a different tornado warning. So that's not good. So on the next slide, there it is, just step by step here. The first warning is canceled for the entire highlighted county, even though the threat remained in that county. Next slide. So that warning got canceled. You see the red polygon went away, and then a cancellation message went out for the entire county. Next slide. So with threats in motion, I'm going to show you Tiny Tim here. We're updating that one warning every 5, 10, 15 minutes and moving it along. And that county does not get cleared out until the warning is completely cleared away from that county. Now that's the way it will work today, because beyond this, we want to start going to partial county alerting. And that includes partial county clearing, and I'm going to show you some of that here in a second. But we'll go to the next slide, and let's skip the next slide. Okay, hopefully you can see that okay. Clear warning display. This is what I was talking about a few slides back. On the left are the actual tornado warnings for an event that occurred just south of here a few years ago. There are 4 tornado hazards, not necessarily all tornadic at the same time, but they've raised the level of awareness to the forecasters to issue tornado warnings on these 4 storms, but there are 7 tornado warnings in effect at that time. On the right is how it would look with threats in motion. 4 hazards, 4 warnings. That's all there should be. And it makes it a lot easier, a lot cleaner looking there. Next slide. Who was chasing the Lockett, Texas tornado on May 4th, 2 years ago? Anyone looking at their radar data at this specific time was wondering, what the heck is this? 4 separate tornado warnings in effect for one tornado, because this thing had deviant motion and started hooking to the left. How does threats in motion deal with this? Let's go to the next slide. On the left is the actual warnings. On the right, threats in motion. As you can see, one warning being adjusted to account for that change in motion. And I can tell you right now, the forecaster who issued the warnings on the left was the same forecaster who came into our test bed to issue the threats and motion warnings on the right. So that came from the same person. So, next slide. All right, I mentioned the April 19th, 2023 event, Central Oklahoma. This is how it looks with the full implementation, taller TIM, the 1-minute updates, and we've thrown everything at this event. So if you look carefully, you can even see that some of those warnings are curved. The forecasters recognize these tornadoes were moving deviant and hooking to the left, so they put that into their warning. This is a future that we hope for. So, next slide. All right, okay. So I'm going to answer a few questions that we've gotten before when we've given this talk, and I'll get them out of the way now, but I'm sure there'll be more questions. So let's start with that first question. Next slide. So if we're updating warnings a lot, isn't there a chance that the forecaster may not get the motion vector of that warning correct the first, second, or third time? Let me do it this way since I got to do mirror image. And that warning starts kind of wavering. It's what we call the windshield wiper effect. It's known in the tropical forecasting realm as well, with strike probability maps. What if you go in a warning on the side, come out, and go right back in? How are we going to deal with stuff like that? Well, we've got a potential solution for that we're going to be trying out this year. On the next slide, let me just show you an example, and I hope you can see that okay. If you can't, you can see it really well on that little screen there. This is a tornado warning that moves along, and it slightly flip-flops and goes back and forth. On the next slide, we're applying something called a cool down. And this particular example is a 5-minute cool down, but we can set that to whatever amount of time a forecaster thinks they want to do that. And that is basically if the storm vector changes, we keep the areas that were warned an extra 5 minutes, just in case it changes back into that area. We can make that 10 minutes if we want to. That's to take into account these little fluctuations in the storm vector. But there's another issue that we've recognized working with forecasters. On the next slide, it's called the accordion effect. And you should be able to see that one a little easier because the polygon's a little thicker. This would be an example of not the motion vector direction changing, but the speed changing. That storm slows down and all of a sudden now the warning gets shorter. But if you'll notice, it gets shorter and then areas in front of that warning just get re-warned a few minutes later. So on the next slide, we have what's called our accordion mitigation, and that's basically we can determine if areas in front of a warning, a moving warning, get taken out but are projected to be right back in that warning in a few minutes, just leave them in the warning. So that takes care of that. So you can see at the very end of that loop, at the bottom, the front end stops for a little bit and then starts moving again because finally the actual underlying moving polygon catches up to those areas that were warned in the previous iteration of that warning. Next slide. Okay, all clears, all clears. So right now the forecasters have to manually clear out the backside of the warning. And a cancellation message only gets sent out for those areas if the area they cleared out also completely clears out a county in the system. Well, I talked earlier about partial county alerting, and this is something we want to do with all clear because with threats in motion, we're going to be constantly shaving off little slivers of warning each minute in the back, and they're not going to clear out a whole county each time we do that. So we want to do something about that. And on the next slide, and I just mentioned this, so let's go to the next slide. So we looked at that example from before where even with threats in motion, we can't clear that whole county out until the whole polygon is moved out of there. But what if, on the next slide, we're able to just clear out that part of the county, partial county clearing? and just do that each time the polygon moves. So that's something we're aiming for with this as well. On the next slide, will we get alerted every minute? Okay, is your WIA gonna go off every minute each time this warning moves? No, that's not our plan. On the next slide, let's see, what we're planning to do is, in our solution, is the high resolution geometry, so it's not county-based. That will include new areas added to the warning. So with a moving warning, there'll be areas just out in front. Con, which is the continuation, so the areas that remain in the warning, and then can or cancel the areas removed from the warning. And on the next picture, we'll show image of that. So on the left is the current practice. So issue a new warning, everybody in that red polygon gets alerted. When the warning gets updated and that warning is shrunk today, nothing happens. Unless you're listening to NOAA Weather Radar here to update, or you've got a text feed, but your phone isn't going to do anything when this happens. That little area in the dashed ellipse behind the blue polygon, not even the removed area. You don't hear about that. Only if the entire county is removed. But I've actually put that whole thing is happening inside one big county I call County A. On the right side, this is what we're proposing with threats in motion. So as that warning's moving along, the new areas, the red areas out ahead, will get their alert. The areas in the blue won't get anything. They're still being warned, so you're not going to get an alert every minute. With one exception, if the warning gets upgraded to a destructive or catastrophic severity tag, you will get re-alerted in that blue area. And then the green area, that removed area, gets an all clear, and you'll notice it's not tied to the county boundary. So this is what we're aiming for to make this all work. Otherwise, threats in motion looks great, but we've got to make sure we're disseminating the alerts the correct way. And the next slide, I believe, is my last slide. So I could leave it up here. This is just another example. This was an event that happened in Southeast Alabama in 2019, Lee County. If you look at the top, that star is where there were 19 fatalities from a tornado. They did not receive the tornado warning until 6 to 7 minutes before the tornado hit them. But with threats in motion, you can see that star gets covered almost immediately. Right there, they get the warning on the bottom. At the top, they only get it then. So anyway, that's all I have. Questions? And we need another microphone, don't we? Where's my mic runner? Martin. Oh, here she comes.
I have a question. On the Lee County event here, what's the difference in the lead time to the star?
For this particular example that we're doing here, we did 30-minute threats and motions. And 30 minutes actually gives you more than 30 minutes because there's a little buffer in front of the warning to account for storm speed uncertainties. So they're getting about 35 to 38 minutes of lead time at that star with threats in motion. And without threats in motion, it was about 6 to 7 minutes, yeah, for that particular case. Warning fatigue. So the question is, what does this do for warning fatigue for the forecasters in the forecast office? What we've learned when we run these experiments is that the beginning of the week, it's kind of high because they're just getting used to the software. But by the end of the week, and we usually have them only run through things for about 4 days, they're more used to the software and they finally come around and say, hey, less warning fatigue, because we're not issuing as many warnings anymore. We're just taking the warning that we already issued and we're just updating its position and motion vector and some of the IBW tags. So,
yeah, first of all, amazing presentation. It's very fascinating. Really, really interested to see how this is employed in the next few years. My question for the scenario where you have the A and B town and the warning moves through, for the all clear, about how far away does the rotation or the storm have to get away from point A before they get the all clear? How is that determined?
So that's actually adjustable within the software. And it also, like for example, for tornado warnings, if we're using a circle or an ellipse to describe, you're usually putting the center of rotation in the center of that. So if you draw like an 8-kilometer circle around that, the back end of that will have to clear. So that's going to lag where the actual tornado location is. And then we're going to also add, a feature within the software probably after this year that's going to regulate the amount of speed of the back end of clearing of that tornado. So you can actually slow it down if you want to or add a little more lag. So that's going to be a forecaster choice based the way it will have the software designed.
And Greg, when you did the stakeholder meetings and discussions, did anybody have concern, or maybe I don't understand the full concept, but of overloading the dissemination and communication systems? Because it would look like an order of magnitude more information is going to be going out.
Well, if we keep the same dissemination systems we've had for the last 20 years, yes. That's not where we want to go with this. So, first of all, we're going to move completely away from text-based warnings, and it's going to all be in something called CAP, Common Learning Protocol, where if anyone's ever seen HTML code or something like that, you can add tags and put whatever information you want in there, and it's up to the software that receives it to decide to do what they want with it. So, for example, today, warnings are limited to 20 polygon vertices or less, the polygon. With CAP, you can make that however, but if your software can only handle 20 or less, you read the line that has 20 or less. But there might be another entry within the CAP that might have 100 polygons. It'll make it a lot more precise type of polygon. The other thing we can do in CAP is, like I showed in the second to last slide, is those, can we go back a slide? The red, the blue, and the green areas there can be described as 3 separate polygons within the CAP message. And then also within CAP, if we wanted to, we could, since we know where that warning is going to be every minute from the time the forecaster updates the warning to the next time, we could actually put in those projected forecasted polygons with time codes on them and say, oh, we already know it's going to be here at this time, here at this time. And then when the warning gets updated, that all gets wiped out and a new set gets produced in the message. Our hopeful time frame for the first implementation, Tiny Tim, 2 to 3 years. For Taller Tim, more like 5 to 7. And I hate to say this is government, so it's always a moving target. So we'll see how that goes. We have there and then back there.
There, first.
Hey, Greg, this is fantastic stuff that you and your team have been working on for a long time. And of course, we've been watching it from the sidelines and with a lot of amazement, considering that you and I got into this when it was still a lot more primitive and clunky than it is today. My question was, how are we going to handle, at least in your current vision of it, how are we going to handle CWA boundary crossers and stationary storms? In other words, threats not in motion.
So threats not in motion will just not be put in motion. So they'll just be issued like a regular warning now. Boundary crossers. So we've actually developed software that we tested 4 years ago in the test bed that allows a warning to be handed off from one forecast office to the next. And the way it works is that within our software, the storm hazards are tracked by what we call hazard objects. So you're actually handing off ownership of that hazard object from your office to the next downstream office. And this can happen while parts of that warning swath are actually on both sides of the border. So we've got that, and then What to do? That's just 2 offices. There are triple points and quadruple points all over the country as well, or a big long squall line. How are we going to handle that? The last one, the big long squall line, we're not exactly sure. And that might even, when we think about it, that might be something that's a little more upscale from storm scale, and maybe that needs to be handled by something else. We don't know exactly yet. But even for like a triple point of an object, 3 offices will have to be in communication, decide which of these 3 is going to take it until we hand it off to the next one. We built into the software, and we actually, when we ran this test, we simulated 2 forecast offices in separate rooms. Roger knows this, the hazardous weather test bed operations area, and then on the other side, on the same floor, we have a development lab, and we had the 2 offices in 2 different rooms, and they were only allowed to communicate either through NWS chat or picking up the phone to talk to them. And then we had the software ability where they could send a request to the other office and say, hey, we want to hand off this storm to you. Do you accept or decline? And on their end, they get a pop-up that says accept or decline. And if they accept it, you see the ownership changes, and now only that office can update that warning from that point on, unless they hand it off to another. So,
Are you going to run these, like when you start turning this on, are you going to have to run it in parallel with the legacy stuff for the counties?
yeah, we have to do that. In fact, right now, we're getting ready to roll out the replacement for WarnGen to the field. It's actually being alpha tested in several offices starting last week. And it's what we call in the software world interoperability. So we have to work, if someone's issuing a warning using WarnGen, but then a backup office comes in and they're using what the replacement is Hazard Services Convective, they have to be able to interoperate between each other. Once all the offices get the new software, then that's not an issue anymore, but yeah.
How are y'all going to coordinate with NOAA Weather Radio and getting these warnings out?
NOAA Weather Radio. So Bruce Jones, the CEO of Midland, was one of our stakeholders at both of those workshops. And of course, some of you may know this, but they've held the patent for a GPS-enabled weather radio for almost a decade now, but it's not there. So one of the things we hope to do is be able to broadcast specifically to each radio the location, whether or not they're in that moving polygon or not. And then that radio will alert based on those rules you see up there. With the only issue with that is the over-the-air broadcast of the warning. So basically, it'll just be treated the way it is now. That warning gets updated, so the original warning message now gets replaced with the updated warning message on the over-the-air broadcast.
So in terms of the public and educating the public on understanding how to read and use these new warnings in the future, could you see any potential for some studies where, for example, maybe you show these some scenarios of these warnings being used to the public to test and gauge how they react and perceive them in order to test its effectiveness?
So some of that's already been done in some research studies. In fact, there's a precursor to all this work here where we added probabilities to the warnings as well, like a probability plume. And there's actually some published research on that, results on that. My feeling is this. So if you see a moving polygon on TV and your TV weatherman is showing these moving polygons, I'm going to guess the public's going to love that. But when it comes down to the actual warning, warning is not based on how it looks, it's based on your location, your spot, your latitude and longitude. Are you in the warning or are you not? That kind of thing. So they will likely get the same kind of alerts that you get today, except we're going to add the all clears on the end of it as well. So I don't think that's going to change. It's just how they look. If they've got access to the way these polygons look, that's going to be different for them. So, did that answer the question? Okay.
Any other questions? Okay.
Lots of hands.
Will AI catch up before you get to the 5 to 7 year mark?
Well, you're talking about AI replacing the human in all this? Well, how many of you have been following StormNet on Twitter the last couple of months? Andrew Brady, I think his name is. He's not the first one to do something like that. That kind of stuff's been being done at the National Severe Storm Lab for about the last 8 to 10 years. Basically using AI or machine learning to try to come up with a probabilistic swath of where specific hazards would be: tornado, hail, lightning, flooding, that kind of stuff. More than likely for the Weather Service, that's going to be guidance that they're going to use in order to create their warnings. They're going to have these background fields to do that. If anyone wants to trust the machine, let them trust the machine. But I can say right now, even this guy who, in all honesty, he's cherry picking. I'm going to be honest with you. He is showing all his successes. He's not showing his complete statistics. And I'd like to know how much his technique fails as much as it succeeds. And we don't know that yet. So we'll see. We'll see how it goes.
Okay. Well, let's give a hand of applause for Greg Stumpf. Yes. Yes. Okay, I just need to turn this on. Okay, we're going to do two. Do you want to draw? Yeah. Okay. Greg's going to draw for me. Okay, we're doing two. One is for...
I brought my reading glasses.
Oh, very good. We're doing the photo that Martin has donated to TESSA, his own photo. That's amazing out there.
You ready? Pick us out.
Microphone. 681-817.
Nobody?
681-817.
817 is the last three. Okay.
Must be present to win.
That is
Yes,
correct.
must be present to win.
That's me.
Yes.
682-327.
Yay! Yay! Okay, I'm going to give this to my daughter. You will go get that in just a second. And we're going to do one of the TESSA gift bag, which is, get a TESSA shirt, a TESSA tumbler, TESSA decals, blah, blah, blah.
681-693.
Okay, one more. Thank you.
682-051. And we got a winner.
Awesome. Thank you. Give it to her. Okay. Y'all can take just a couple minutes if you need to go to the bathroom real quick as we get Roger up here. But just don't be gone, but just a couple minutes and we'll get started with his.
go somewhere after I announce you, right? Okay, guys, we're about to start Roger's presentation in exactly 60 seconds. Make it whatever you want. Grand senior.
That'll make me sound like I was always there. See, Rich is older than me. I always give him crap. So, lead forecasters. Okay, that's cool. He's the senior.
Yeah. Okay, it's time for our next presentation. This is going to be by our guest today, Roger Edwards. He is a lead forecaster at Storm Prediction Center, and he is going to be talking about, he's going to tell you right now. Please welcome Roger Edwards.
Let me make sure this is working. Is this working? So what I'll be talking about is the perspective from the last 30 years or so, roughly, of career and severe local storms from the perspective of somebody from North Texas who always loves to get back here, who always loves to see the folks here and interact and talk and learn about weather. And I mean learn just as much as I mean talk, if not more. Because I see presentations like Greg's, or I see presentations like Jennifer and David earlier today, and there's just good stuff in there. And so I've been blessed, really been hugely blessed in life, and I've had a lot of opportunities to learn about severe weather and to try to convey that information on, and that's a core mission of TESSA. So I've always been a huge supporter and huge fan of TESSA. So I'm glad to be here, and I thank every one of you for coming out. Next, please. So a little bit on my background, because it informs the lens, it basically paints the lens through which I've been able to see severe storms. When I was a baby, and I don't even remember this, I would crawl to the door to watch lightning, fascinated by it. And when there was a close CG, and screen doors, open screen doors, when there's a close CG and a flash and a bang, a lot of kids would get scared or they would run. And I'd be like, ah, yeah! And this is just as a baby. I do not remember at all not being almost obsessively fascinated by severe weather. It just goes back. I can only say it's, like I said, sort of a God-given blessing in a lot of ways. So I grew up in Dallas, grew up in East Dallas, Gilman Live Oak area, if you guys are familiar with it, back in the 70s and the early 80s. And it was kind of a rough part of town at times back then. And then I followed a circuit that went from Dallas to OU to the Severe Storms Lab. And I was at OU and Severe Storms Lab at the same time. Well, one day my freshman year, I walked into NSSL, which was the reason I went to OU, because they had NSSL in the same town. And asking for a job, and they gave me a job. Now, it doesn't work that way most of the time, probably doesn't anymore, but at the time, a kid with an audacity to say, hey, I'd like to work with you guys, got to do that. And so that was really, really neat. And that's where I met folks like Greg and a lot of other people who I'll show here later. And so that's the circuit from the blue and the silver there in Dallas, you know what that means, to Norman, the crimson and the cream. And then when I was in grad school, with $16 to my name and 5 figures in student loans, broke, I got a call from the Hurricane Center after applying for a small temporary job at the lab. Would you like to work at the National Hurricane Center? Yeah. So, left grad school, went to Miami. Amazing, amazing time and amazing people. After 3 years at the Hurricane Center, went to National Severe Storms Forecast Center in Kansas City. So Dallas to Norman to Miami to Kansas City, and then when we split into AWC, Aviation Weather Center, SPC, Storm Prediction Center, moved back to Norman. So just pretty much came full circle in a route like that. Next. But I'm from Dallas. The home of your World Series champion, Texas Rangers. Never thought I would live to say that. Next slide. So this is sort of a melange of images here that sort of informed my upbringing. And I grew up in a series of little shotgun shack type rickety duplexes, including that one right there, which is on 6017 Prospect Avenue in East Dallas. And it was in worse shape then, if you can imagine. But, you know, when you're in, we couldn't afford air conditioning. So that meant I was in Dallas in the summer of 1980 with no air conditioning, 42 straight days of 100-degree or higher temperatures. But I was enjoying it. It was, yeah, I sweated a lot, and there were roach-infested places, and you know, it could be a hard life at times, but the weather is so interesting around here. How could you not grow up in the Metroplex and at least have some interest in the weather? And I did. The Wichita Falls tornado, not here thankfully, occurred on April 10th of 1979. And I remember seeing the anvil from it off to the north. I remember seeing Harold mentioning on the 6 p.m. news the tornado warning for Wichita Falls. And I was imagining, what's going on up there? What's going on? Well, that picture at the right, Leon Houghton's photo from Wichita Falls, was on the front page of the Dallas Times-Herald the next day, across it. I was absolutely captivated. And I'd already seen briefly with power flashes and some of the funnel, the tornado on May 26 of 76 through trees and houses from my neighborhood in East Dallas, off to the northwest. But I had that photo on the wall, kind of like I'm looking at it now, on that screen, but huge, the whole rest of the time that I was in Dallas until I went to college, so that every morning when I woke up, it would be the first thing I saw. Because I decided right then and there, I was not only going to research these and forecast them, I was going to see them. I wanted to see that in person, firsthand. In the meantime, had a bunch of teenage jobs, including at the Trailways bus station downtown. My dad worked there most of the time I was growing up, loading and unloading freight, baggage, things like that. So I spent a lot of time downtown, a lot of time. The library, what was in the new public library, just a couple of blocks south of the bus station, there's a highfalutin condo complex now where that bus station used to be on Jackson Street. And why is there a reel-to-reel tape recorder there? Well, when I was 3, my mom and dad interviewed me using a reel-to-reel tape set that he had found somewhere and refurbished, or maybe his friend who was an electronics guy did. And they asked me, what do you want to do when you grow up? And in my kid, of course, little 3-year-old kid voice, I want to be in a hurricane. Hurricane Andrew fulfilled that wish in Miami. So why is that up there? Well, our landlords didn't think very highly of us. In fact, one of them that called us filthy inbreds. And that was not real nice. But, you know, when you live in a poor area and you're poor, you get insulted and you learn to roll with the flow. And we did, and it was just part of growing up that we were kind of just the wrong kind of people on the wrong side of town. And I kind of wanted to do something about that. And so that was another piece of motivation. Next slide, please. So I went on to OU, and I got influenced by a host of really amazing scientists and instructors, and some really awful ones, too. I just put the amazing ones up here. Kelvin, you see Kelvin Drogemeyer, Howie Bluestein, Yoshi Sasaki, and the esteemed Chuck Doswell, who has spoken here before. You guys, a lot of you are familiar with Chuck. And you see Rich Thompson, who's my best friend, fellow lead forecaster at SPC. Met him as a freshman at OU the first day I was there. Hey, there's somebody else on the floor who's as much of a weather nut as you are. What? Is that even possible? Yeah, it's possible. So we tore through the Met department for 4.5, 5 years, raised all kinds of hell, and had a great time, and chased, in Rich's case, I think 61 times, and in my case, 59 times without seeing a tornado our first 4.5 years there. It was the late 80s. Tornadoes, as Greg can remember, it really just didn't happen in Oklahoma for chasers. But I learned a lot. I learned about study habits. I was a good student in high school. Didn't really have to study much. I had to study in college, and it hit me like a brick wall. But I learned good study habits, formed study groups, learned not just the science of meteorology, but the art of meteorology, which was very, very important. And as a federal employee student there. Next slide, please. One of the projects I got to participate in early on, first chase season there in 1986, was Total Bull Tornado Observatory. Our mission, if we chose to accept it, was to take that can full of instruments and weights at the bottom. It was not 400 pounds. I could push that up the truck by myself, but it was heavy. And put it in front of a tornado. We didn't succeed because tornadoes didn't happen. We put it in front of a lot of gust fronts. We recorded wind and temperature and humidity data in front of other things, but not tornadoes, unfortunately. And of course, you can see, if you can see, the Dave Hoadley cartoon from Storm Track about the folks who see Toto being deployed and think that it's the new appliance for their house being delivered. But when I was at the lab, I met tons of amazing people and tons of amazing mentors. And some of them are right up there. You can see, you see Don Burgess, preeminent radar scientist. I pretty much learned everything I knew about radar the first decade of my career from Don. If he doesn't know about it, it's not worth knowing about, and he does. And then I met Al Moeller and Chuck, before Chuck started working there, actually. He was still in Boulder at the time, but they were working on spotter guide slides to give slideshows at Spotter Talks. And my job as the person who had been put in charge of the slides and video collection at NSSL, imagine that, getting paid to watch storm videos and movies and go through slides. That was fun. But I had to organize them as part of the process of that. But I helped Chuck and Al assemble that slide collection and put together slides from an SSL, go through it, decide what was good, what was trash, and 99% of it for their purposes was trash, even if it was interesting stuff. So I got to know those guys. I had briefly met Al a long, long time before that, but that's when I really got to know him and really got to respect him a lot and have ever since. He's one of my major mentors, as is Chuck. John Lewis is another one there at the lab. Still keep in touch with John today. He's out in California, still doing modeling work, amazingly enough. And Bob Maddox, who's retired out in Tucson, Arizona, who's been involved with EJSSM as a founder and editor. So lifelong connections, and a lot of other people I can't even name. It was such a huge influence. They were at the forefront of the development of NEXRAD, WSR-88D. A lot of the radar concepts and a lot of the radar algorithms that Greg worked on as a researcher not long after that, that have gone into threats in motion and other technologies started right then and there. And then people like me got paid to drive out at 1 a.m. and punch mesocyclones at night and scare the crap out of ourselves and verify that these storms are actually behaving in ways that the radar could imply that they were behaving. That was a ton of fun, to get paid to do stuff like this. Well, it wasn't very much fun for my partner, Brian Curran, who's the Sioux at Midland right now, when we punched the backside of a mesocyclone near Ardmore after midnight and had trees bending southward on this side and trees bending northward on this side, about 200 yards apart. And I look over and I see Brian, and he's just white as a sheet with his mouth hanging open. We lived through it. Tornadoes didn't happen much in Oklahoma then. Next slide, please. So those are the projects I've been involved with over my career. I just listed a bunch of them there. Doplight 87, there were chase programs in 88 as well. Next Right IoT and E2 in 1989. Oh, we got in so much trouble that the people back at the lab didn't even know about. Vortex, TwistX, I participated in that. Some. Vortex is a forecaster, TwistX directly for a couple of weeks with Tim Samaras and Tony Lawback and some others driving around. We saw a couple of tornadoes, one from a distance and then one in the jungles of southeast Oklahoma that formed on top of us and went off into the jungles. That was no fun. And I've had the privilege of being an author and contributor and participate in a ton of scientific papers. A lot of them informed by storm observing, spotting, chasing, photos, accounts, videos, important stuff. And as a forecaster. Next slide, please. So the next stage was at the National Hurricane Center. And I was going to animate this, but unfortunately they don't animate well. But there's a slide back there of Hurricane Andrew moving ashore. That was a seminal experience in my career. It was absolutely foundational because that taught me in so many ways what disaster really is. I loved hurricanes and I love weather. But if you want to get the human side of it down and you want to understand what people are going through, be in it. I don't recommend it, but be in it, be embedded in it. A lot of you will be at some point in your lives if you haven't been already. Those of us who've done damage surveys, who've seen F5 damage, who talked to the people out there, we get it. Hurricane Andrew was essentially an EF3 tornado that was 16 miles wide, moving through the south side of Dade County at about 25 miles an hour westward. It's pretty much what it amounted to, even though it was not a tornado. It was an eye wall that was shaped like a truck tire, and it was Category 5, the highest end a hurricane can be. It's quite the experience. I was in the north side of the eye wall, and our property survived, but there was a lot of damage in the area. And of course, cars flipped, and that, I was already interested in hurricanes, and in hurricane-spawned tornadoes, but to be there when that happened was something that really, really shaped me for the rest of my life. No question about that. And informed how things went. And I was introduced to the concept of rotating shift work. In the National Weather Service, forecasters at the local offices and the national centers like the Hurricane Center during season, SPC all year round, Weather Prediction Center and the others, we work rotating shifts. Some weeks day shifts, some weeks overnight, midnight to 8 or 8 p.m. to 4 a.m. Other weeks might be 4 a.m. to noon or 8 a.m. to 4 p.m., 9 a.m. to 5 p.m., and it changes. Shift work is a known carcinogen. It takes a physical and emotional and mental toll on people. It's not something that's recommended. When we tell our doctors, we as the shift workers, we tell our doctors what we do, they go, well, you got to get out of that. But who else is going to do it except those who have the passion for it? And I know Al got up here several times and he talked about the passion for severe storms, and I'm 100% behind that, always will be, because that's what it takes. And at some point, the shift work just wears you out and you got to do something else. That point is rapidly approaching for me. But that's where I first learned how to manage it and how to deal with it. Next slide, please. And I caught a fish or two when I was down in Florida too, because I love to fish. NSSFC in Kansas City, well, that was a whole different ball game. I found people who were really passionate about severe weather. In fact, I was one of the first of the so-called young pups, a whole string of young meteorologists in their early to mid-20s in the mid-1990s who were hired there to transition toward the move of SPC, the split off from the Aviation Center and the move of SPC to Norman to reunite with the Severe Storms Lab and the other entities there. And we were, at the time, we were on the forefront of trying to advance the science of severe weather forecasting. We had a lot of resistance. At the time, the employees union there didn't want to move to Norman, heavily resisted it. But fortunately, we were able to overcome that, and we were able to this taught me how to deal with internal office politics and strife and divisions and behind the back talk and stuff like that plague a lot of offices. I really didn't deal with a lot of that at the Hurricane Center. But that was a time of flux, a time of change, a time of turnover, and that's never easy for anybody to deal with. We managed it. A bunch of us, including some really experienced and highly knowledgeable forecasters, like Jack Hales, who's on the left, Steve Corfidi in the middle, Steve Weiss, who's to his right, the late Bob Johns to his upper right, and of course, Rich joined the lab or joined the NSSFC about a year and a half after I got there. And those folks really set the stage for advancing severe storms forecast science throughout the 90s and in the 2000s. I call it the golden era because there was so much new knowledge, so many new concepts that were coming out of NSSL, NSSFC, SPC, and the folks up in Colorado as well, up at NCAR, and the COMAP folks. And it was really a strong era of knowledge gained in severe weather forecasting. We advanced so much, and I'll show you examples of that. Next slide, please. So we moved to Norman, and back to where I had been, Severe Storms Laboratory Building, 1313 Halley Circle, and occupied an area that I had been sitting in a Macitas room when I was working at the lab as a student. So I got to quite literally work in the same room again for about 10 years. It's really neat. We remade it into a National Operations Forecast Center. And I got to work with a ton of people, see a lot of great folks at the lab, both those who I knew from before, like Greg and others, and folks who had just showed up again and who were there new, folks like David Schultz and others who hadn't been there before. So that was a lot of knowledge to absorb and to diffuse. And again, shift work, having to deal with stresses in life, having to deal with, things going on at home. One marriage ended, another marriage began. I was a single dad of 2 kids for a while. I had custody of a couple of kids while rotating shifts. That period of life was kind of a blur. But one thing was a constant, and that was the forecasts and the storms. And every one of these forecasts was unique and challenging. Every storm that I would go out and see was amazing and impressive and unique. And that was the one constant through it all. And then we moved to the National Weather Center in 2006 on the South Campus of OU, where we are today. Really amazing facility. Still looks brand new when you walk in, except for the concrete out front that's starting to crack apart. But the facility itself is just, it's top notch. It really is, and I'm blessed to work there. Dealing with all those things at the same time was not easy, but it was also a period of amazing growth, not only in the science, but professionally for me, in terms of writing formal papers, writing conference papers, working with people at different universities, not just OU, but St. Louis University, College of DuPage, and other places, and Arizona State, and really getting into the science of severe storms. Next slide, please. Another just absolutely crucial moment in severe weather, science as a whole and for us professionally, was May 3rd, 1999. An outbreak that we couldn't have even conceived when we were in Oklahoma in the late 1980s, thirsting for tornadoes. And after this, we wish we hadn't in a lot of respects. The photo at the upper left, or the image at the upper left, shows one of the outlooks that was issued early for that event and during the day. Unfortunately, I think that was mine. It was only a slight risk at 13Z. The forcing for the event was so subtle and so unimpressive despite the large area of favorable moisture and the large area of favorable shear that we didn't know if or how many or when the storms might blow up. But we knew if they did, it could be really bad. But where and how many? Tremendous amount of uncertainty. High-resolution model simulations that have been done of that event since still cannot successfully simulate it. They either overproduce or underproduce. That day was something else. Rich and I saw 11 tornadoes that afternoon. I got off at 8 a.m. Rich woke me up at 3 p.m., said, "Get your butt in here. It's happening. It really is happening. We need to get out there." So we did. He got off day shift, went and saw those 11 tornadoes from 2 supercells, including 2 violent tornadoes. The second of which, the Mulhall tornado, you can see in the video capture in the upper part. At that point, the damaged path was about a half-mile wide, a little bit bigger than a condensation funnel. The updraft was almost 10 miles wide. That storm was intense. And it might have been every bit as strong as Bridge Creek Moore, but we just didn't have the damage indicators to sample it. At the upper right, you can see one of the homes that was EF5 slabbed at Bridge Creek by that tornado. It's got anchor bolts around it. It was well anchored. I think Chuck took that picture. And it was leveled and swept away. And it was a very deadly tornado. It wasn't as deadly as it could have been without the excellent warnings that were issued by the Norman office, who did the first ever tornado emergency for that storm, for that reason. Unfortunately, at the lower right, the human side wielded itself again. Those imprints you see in the mud on the underside of that bridge are people who were blown out from under the bridge. One of them didn't make it. Why do we do what we do? Why is Greg doing what he's doing with Tim? Threats in Motion. Why am I doing what I do in SPC with outlooks and watches and papers? To try to minimize that kind of thing. Next slide, please. So May 3rd, 1999 allowed us to do a lot of research because it showed us that even for all the great advances we had made, there was still a lot that we didn't know. And so we studied it and studied it and studied it. We figured out how Storm A, the first one, developed that produced the Bridge Creek tornado. We still don't know exactly how and why the second one formed and why it intensified where it did, but we wrote formal papers on it. And there was a special issue of Weather and Forecasting devoted just to that outbreak. Thanks to the work that a lot of us at NSSL and SPC and in that cadre of Norman meteorological community did. Next slide, please. The tools of the trade. A little switch here. Even to this day, one of the things I learned from Al Mohler is this, and it's still true. You have to learn to read the data and to understand the data and to swim in it and to let it speak its language and to learn its language. Because if you're just superficially staring at a screen that has automated plots on it, how good are those plots? What goes into them? What's the information that they're trying to tell you? Well, you should be able to understand that. But the way to best understand the atmosphere is to really slow down and swim in the data. Hand analysis of paper charts forces you to do that, and that's something I'll always be an advocate for on the forecast desk. It's not happening as much as it used to be in a lot of places. But we still do that because that very reason, understanding. It compels deeper understanding of the atmosphere. And in an age of AI, which there's a lot of good tools we can use, and in an age of automated algorithms and high-resolution convection-allowing models, understanding still matters. If it doesn't, why do we do what we do? We can just automate our jobs and walk off into the sunset. I think we still matter enough to where understanding still matters, and that is a great way to gain understanding. Next slide, please. Forecasting tools at SPC have evolved a lot since I got there. We used to issue watches that were just polygons, that were just boxes. Now we're issuing them for counties, and I hope At some point in the next 10 or 15 years, we have, as we've talked about for at least that long, rolling watches that roll along with the threat on a larger scale. Counties peel off, counties come on, just like threats in motion for warnings. Hopefully, what Greg's group is doing will kind of serve as an impetus or push to help get it going on the larger scales as well. We'll see. But we look at all kinds of data. I mean, I could stand here for an hour and just name all the things that we could look at from soundings. And this is just diagnostics. This is not even models. Radar, soundings, plots of all types, different fields that we either came up with at SPC on our Surface OA page, on our mesoanalysis page. Things being developed internally. We're working with some people who are good with machine learning algorithms to develop extended severe weather probabilistic forecast tools that we actually have started to use in extended outlooks now that are based on machine learning pattern recognition algorithms in the past. We don't use them as a crutch. We use them as tools. And I think that's the key to new things like AI and machine learning algorithms, is to treat them like what they are, tools. Use them appropriately. You're not going to fit a pipe wrench to something you need a wire cutter for, and vice versa. And there are good places for pipe wrenches, there's good places for wire cutters, and there's good places for different tools that we use. And yeah, we even look at webcams sometimes. That's the webcam of the Evansville tornado about 15, 16 years ago. Next slide, please. Human understanding matters. Absolutely. It does, it will. The forecaster at the warning desk is going to need to understand the behavior of supercells in order to draw the most effective threats in motion bending polygon ahead of it. So will we for watches and mesoscale discussions and outlooks on days, timescales of days. Next slide, please. So the outlooks have changed a lot since I've been there too. We used to issue slight, moderate, high, and general thunderstorm, and some of you might even remember a category called approaching severe, which became C-text, which kind of morphed into what is the marginal severe threat that we use now. So those are twin high risk. Those are that was a rare event, and we have probabilistic outlooks for hail, wind, tornado, as well as different sorts of displays for showing the outlook to media folks who can call up on an internal page, call up graphics with cities, towns. Weather service folks can call up graphics that show the threat in time and how it goes up, how it goes down. Next slide, please. I don't know if you've noticed the last couple of years, we've improved our mesoscale discussion displays thanks to folks, some of our newer folks like Nathan Wendt and Chris Karstens and a few others who have worked on improving mesoscale discussion displays to where we can show visually some of the features that we're talking about in the discussion itself. So that's been a major advancement for us and a very positive one. The discussions themselves have gotten a little more detailed. We don't use those cryptic abbreviations like XPCD for expected anymore. There's actually plain English words, although they're technical plain English words. Next slide, please. Watches, those, again, we've advanced from just the boxes like we had in 1999 on the left, excuse me, to, here's an example from Hurricane Harvey on the Texas Gulf Coast. And by the way, Harris County was in continuous tornado watches for over 60 hours. I'm presented on that here a couple of years back. Slow-moving landfalling tropical cyclones are some of the worst. And in that event, we had dual threats that the local office had to deal with because not only were they having to deal with being in continual tornado watches for days on end, but they were having to issue tornado warnings. In fact, one of our former leads, Jeff Evans, is the meteorologist in charge there. And they were having to issue tornado warnings. And in the warnings, there were tags that they could select telling folks to go downstairs or go to a basement, but that wasn't the best thing to do when the downstairs was underwater. Multiple threats at once. That event, among others, has showed us we've got to prepare for things like that. Next slide, please. Some of the research I've been involved in has just been fun. I love doing research, almost as much as I love to forecast. It's all a challenge. Since I've been at SPC, I've published 10 lead-authored formal scientific publications as a forecaster. I just love research. And I've researched some of these areas, whether it was my specialty, hurricane-spawned tornadoes, published quite a bit on that, on threat preparedness of different kinds, and especially on some fascinating case studies from chases, including one left-moving supercell case that I published with Steve Hodanish of the Pueblo office, and I chased with Elka over here, my beautiful bride, who's sitting on the 4th row. And that was a really neat formal publication with Steve. And even recently, published on a case where a left-moving supercell produced an outflow boundary. Rich and I were out on a storm near Kingfisher, high base, non-tornadic, May 29, 2012. Rocky remembers that one. That was part of the DC3 Deep Convection and some other stuff project. Maybe Greg remembers what the rest of that acronym stood for. But we talked to some of their people in the field before we got on that storm and kind of exchanged information and insights in the storm form we got on it. High base storm, nothing going on. Oh yeah, it's pretty. It's starting to throw down 4.5-inch hail near Kingfisher. That's not good. It produces a neat little gustnado that almost gets drawn into the mesocyclone and becomes a tornado, but not quite. But what was really neat about that storm was that a left mover to the south sent an outflow boundary out from its rear flank. And those of us in meteorology, we've got conceptual models of how storms behave and how they're structured. And while Rich and I are out in the field, we're talking about that outflow boundary coming up, and we're thinking, well, you know what? What is the sign of vorticity along the far part of a left mover's rear flank gust front? Cyclonic. What happens when cyclonic vorticity hits a mesocyclone? It strengthens. Maybe we should be there. We went there, produced. And once some modelers recently modeled that case, we published a paper on it and included their results to sort of observationally verify what they were modeling, which was pretty neat. Other research I've been involved with has involved data quality and quality control. I'm just going to use one word to describe the national convective wind data. It stinks. It's terrible. 93% of the wind reports nationally are estimated, not measured, convective wind reports. Wind tunnel tests have shown that humans tend to overestimate wind by a factor of about 1.25. So, for example, if it's around 60 miles an hour, then they'll say it's around a little bit less than hurricane force. So incorporated that into that research, and so far unsuccessfully advocated that estimated winds be kind of set aside and not used as much, or at least weighted and downscaled to account for that effect. And also that those estimated winds that are not associated with a value, such as trees down, wires down, fence blown over, things like that, are artificially, and in my opinion, unscientifically assigned a number if they're deemed to meet severe criteria. But we don't really know how strong the wind was, just like we don't know how strong the winds are in any given tornado, and most of these wind reports are not surveyed directly like the tornadoes are. So it's just some arbitrary thing just pulled out of nowhere and attached to them. Well, that was fun research to do. And you can see that graph at the lower right. What are those little red things that are sticking up? Those are values that end in 0 or 5, miles per hour or knots. So you can see that there's a little bit of an unnatural bias toward reporting winds that end in those values. Not only that, but there's a little bit of that bias on the measured end, and I don't know how that happens because it's not natural. So anyway, these are some things I've been interested in, oddities and weird things going on in tornado data. If you're interested in that, there's publications on the SPC publications page. Email me. I'll be glad to send you that paper. It's eye-opening, some of the weird things that can happen, like a 200-mile tornado across the middle of New Mexico in the database. Nope. Did not happen. And there's some other weird oddities in the database as well. So history, thunderstorm modes, radar signatures, worked with Rich Thompson, Brian Smith on a lot of that data set, helped develop the significant tornado parameters, supercell composite parameters, along with Rich and Corey and a few others who were there at the time. It was a time of just tremendous advancement in the knowledge of severe storms at SPC, and I'm so blessed and thankful to have been a part of it. Next slide, please. So some of the other stuff that I've been involved with has involved storm chase activities, of course, photos, the anticyclonic supercell you can see up at the top mirrored, contributed photos of a satellite tornado that merged with the EF5 wedge near Piedmont to a formal paper that Mike French and some of his partners wrote on that event. And if you've never seen a loud, boiling EF5 wedge in person from 1.5 miles away, it's life-changing. It really is. But it contributed to research as well. And I've always been happy to contribute storm chase slides and photos to other people's research and also to use others in mine when I can get permission to do so. And in fact, you can see that at the right, the conceptual model for the left mover and the right mover that were about to merge and produce that tornado near Piedmont in 2012 that we developed in that paper. Next slide, please. So, what's other scientific involvement? EJSSM, we formed a whole new journal back in 2006. It's still going. It's a low-volume severe storms journal that publishes work on any aspect of severe weather, fire weather, sometimes winter weather, even tropical cyclones. And my beautiful bride over here is the copy and layout editor for that journal, has done a ton of work on the website and is great with that. And Chuck and Bob Maddox and Dave Schultz and Scott Blair and a lot of other people have been involved with it. Amos Magliocco has been involved as a copy editor as well, and several others. That's still going. Next. Off-duty storm observing. Again, I'm going to be chasing until they put dirt on top of me. That's not going to stop. You can see some of the folks I chase that you never know who you're going to run into. And in that picture at the upper left, you can see Tim and Carl and Chuck and David Fogel and John Davies and Keith Brown and Elka and me, and we're all just kind of gathered up randomly at a restaurant near Hays, Kansas after a tornado that day. That's one of the neat aspects of storm observing. In the bottom middle, you can see Jim Leonard at a gathering at Tim Marshall's place at a storm chase gathering. He's holding my daughter Donna. My son David is sitting there munching on something. We all get together and just talk about storms. And at the lower, I guess that would be the lower right, that is the Piedmont EF5 from 2011, May 24th. With the radar imagery of it up on top, reflectivity, velocity, it was intense. At that point, it was about a 3/4 mile wide wedge with a satellite tornado to its left. And I was getting a fire hose of rain, hoping I could get one good picture of that. But storm observing, spotting, chasing has absolutely informed the science of meteorology tremendously over the years and will continue to do so. Next slide, please. I'm going to go through these kind of fast. We're about to the end. Some of the advancements we're moving toward are time threats, where the threat ramps up and the threat ramps down in specific points in an outlook area. And this illustrates that with a bar chart on the right showing a threat at a point for an outlook not far from here. I think the threats point we used was Irving for that particular outlook. Next slide. We're also working towards something that we call, I like to call it heat maps, but continuous probabilities. I mean, the probability of severe weather doesn't abruptly change on a line. You know, it doesn't change from Greenville Avenue to Skillman Street 4 blocks apart in East Dallas. It's a continuum of probabilities. It changes over time, and we want to reflect that in our outlooks, and we're working toward doing that. Next slide. There's, again, artificial intelligence algorithms that inform our outlooks. They don't dictate, they inform. And you can see how different they are for the very same scenario. Very, very different. So we still have to use our physical understanding of the atmosphere to decide what of that is more valid than the rest, and what of that makes more sense based on the weather situation. Because it's still essentially a form of pattern recognition, which we've been doing all our lives. Next. So, what's next for me? Well, I'm retiring at the end of this year. And I'm not retiring because I don't like my job or the people. I love them, actually. But 35 years of shift work is just about enough, rotating shift work, and it's starting to take a toll. I don't have any major health problems right now, but I can feel it and I can sense it. It's something I don't want to have to deal with or have to let develop. And so the time where I'll be doing rotating shifts is coming to a close here at the end of the year, and so I'll still be involved in the science. I'd like to get regular sleep for the first time in 35 years. It hasn't happened. A lot more chasing, a lot of travel, photography, fishing, stay involved with the science, keep in touch with everybody. I'll be able to go to more TESSAs than I used to be able to go to. A lot of writing. I really love to write and spend a lot more time with my honey. Next. So there's my contact info, and there's still a little bit of time for questions. So don't hesitate to email me if you have any questions, want me to expound any more on anything I just wrote, want some publications from the publications page. I'll be glad to do that for you. Thanks. Yeah. Appreciate that very much.
Thank you. Okay, I get to tell a little bit because when I first started in chasing with Martin, almost 11, 12 years ago, he always told me that you wrote the best mesoscale discussions, and I could always tell yours because they're very elaborate if you've ever read any of his stuff. And so I can always tell, and they've been wonderful, so those will be missed.
Thank you.
Yeah, lots of adjectives. So who has a question?
Questions about SPC, about science of forecasting, pretty much anything, if I can answer it.
Well, as someone who is trying to basically do a midlife career shift, I'm looking to get into meteorology. I have a goal. I want to get to the SPC or the NSSL. What are your recommendations for someone like me who is at the starting point?
What sort of fields have you been working in? Sorry, Kim.
I've been in the warehouse industry for 10 years, and right now I'm a customer service rep for the IRS.
Okay, so you get to do a lot of dealing with external people and customer type of work, and that actually is becoming more and more of an emphasis in the National Weather Service in dealing with external, what they call core partners in the bureaucracy and stakeholders, as Greg noted. And forecasting, of course, and understanding the atmosphere is still important. But a forecast is only as good as how well it can be communicated to the people who are using it. And so what we call IDSS, or Integrated Decision Support Services, or something like that, is more and more of an emphasis at the local level all the time, and being able to construct graphics and construct briefings in ways that people can understand it. So skills like you have, if you are willing to get the scientific education, which the NWS is, and as far as I know for the foreseeable future will require for meteorological work, at least a bachelor's degree in meteorology, and preferably a master's degree, but bachelor's is minimum, in atmospheric sciences with a pile of listed minimum coursework. You can go to the American Meteorological Society website and get all the required coursework that's listed, but every meteorology program at any university nationwide, be it OU, Texas A&M, Florida State, Penn State, the SUNY schools that do it, all these meteorology programs meet those requirements. Those requirements will change, and they will lean more toward communication and computer science here in the next few years. But if you're willing to do that, those opportunities exist at any stage of the career. In fact, I know someone who is applying for weather service jobs now who got a meteorology degree, but who's been working in the insurance industry for several years. And I'm a reference for their applications. So yeah, you can do it. You absolutely can, but it's, you know, I'm not going to pretend it's easy. It was hard. It was hard for me to learn meteorology as an undergrad. So, but you know, if the will is there and the will to overcome adversity is there, then yeah, absolutely.
Thank you so much. I appreciate it.
We're making Kim run
Still a
around
question?
far.
Somebody back here.
That's right.
With the Jennifer was up here earlier, and she's a WCM, and WCM is a kind of a misnomer of a job title. They're kind of a more of an outreach, where they work with their local partners, the emergency managers, the media, that stuff of that sort. Now, there's also a WCM, as you know, at the SPC. Mm-hmm. You know, what kind of role does that person, does that kind of work with more people in DC? What kind of partners do they kind of work with on at a center like that?
That's an excellent question. Our WCM currently Matt Elliott, previously Greg Carbon, who went on to work at WPC in Washington. He's actually retiring about now. Matt Elliott's our current WCM. That job has been pretty busy, actually, because they, as you correctly surmise, get to deal with a lot of partners, a lot of interests on a different level than at the local office, who are dealing with media, emergency managers on the scale of that jurisdiction. Our WCM deals with a lot of folks from FEMA. In fact, we've got an embedded FEMA liaison, Summer Erickson, who works for us as well. And we brief FEMA people. Sometimes even the White House gets national briefings on severe weather threats. And so our WCM and our former operations branch chief, now deputy director Bill Bunting, who a lot of you guys are familiar with from his time here in Fort Worth, does a lot of that kind of work together. They're also in charge of managing the severe weather database and improving it, and I've been helping out with that. I may badmouth the severe database, but it is getting better thanks to their efforts. And so that's a lot of what they do, but it's more behind the scenes because it's not as public facing as what a local WCM like Jennifer does.
Okay. Any more questions?
Yeah, Martin.
How much in percentage will your storm chasing go up?
So Martin asked me how much my storm chasing percentage will go up after I retire. It will go up to the extent that I'm able to get into the vehicle and drive to an area that I expect to experience photogenic severe weather. And that probably will be on the order of 300 or 400% or more. Season to season. And who knows, you know, we'll see how it all works out, but I certainly wouldn't mind getting involved in things like a tour, you know, if that kind of opportunity comes about as well. We'll see how it goes. I don't have any plans. Nobody's contacted me. I'm not working for anybody else. I'm prohibited to right now because I'm a government employee. That would be a conflict of interest. So right now, it's up in the air, but I can tell you this. I'm going to be doing a lot more storm observing and photography. A lot. Yeah, Steve.
Could you repeat that question a little bit? We couldn't hear it.
Steve wants me to quit messing with the rocks and moving them around. Being an amateur geologist, I have a fascination with and a collection of rocks from a lot of different places that I've been. And I tend to collect the rocks, but because I believe in giving and not just taking, I also tend to leave Oklahoma red, Permian, mudstone and siltstone from my property in a lot of the places where I take rocks from, whether it's here, Alaska, Hawaii, Europe, you name it. They're going to get some okie rocks. In fact, when I was out in Hawaii with a friend of mine who's a meteorology guy out there in Hawaii, and we were on a lava hike and the lava was flowing over it, I put an Oklahoma rock down there to sacrifice to Pele, and the lava rolled right over it. DFW is always home for me in a lot of ways, but I'll probably be staying in Oklahoma for the foreseeable future, for a few years at least. And then after that, who knows? We'll see how life changes and how things evolve. But my home will always be here.
Okay, I got a question for you.
Yeah.
So I remember, I think it was about 2 years ago at the last TESSA event, it was you or maybe another one of the forecasters mentioned about the SPC extending to an 8 to 14 day forecast from the 7-day. Is that still in consideration?
It's still under consideration, and it is not advanced beyond that, partly in thanks to a lot of post-pandemic stuff, still getting over that, and partly because a lot of other things that we're working on and with higher resolution models in conjunction with a hazardous weather test bed, things like that. But it's still on the table. It hasn't gone up, it hasn't gone down, it's still sitting there on the table.
Very good. Okay, a hand of applause for Mr. Roger. So we're going to draw for his photo, and I would like Roger to just take a second to tell you the story. He told me a little bit about how that photo, he got that back. So.
Well, the photo that's being given away is a picture from September 1987. It's actually kind of historic now because I'm getting historic. But this photo was taken on the OU campus near an apartment building that I lived in at the time, and Rich Thompson was standing there beside me, and he was yelling at me, you better be getting these on film. You better be. Well, I hope I'm getting them on film. So one storm is colliding with another, and there's this beautiful gust front, and it's aiming down, and I'm just holding down the camera because I don't have a tripod. I've got it anchored to a pile of stone, and then boom, flash, and then really got a nice spectacular image out of it. So that photo was used for an SPC sponsored tornado summit seminar back in the early 2000s. And a bunch of copies of it were printed. Our director at the time, Joe Schaefer, got one of those copies and had it framed and took it home and put it on his wall. I didn't even know about that. Well, I went to Joe's estate sale recently, and there's my picture on his wall in this big, weird frame. And I thought, I'm buying my own photo back. And now, one of you gets a chance to have it, because I've still got a bunch of copies that are printed out and on my own walls. Okay, so, first number, hopefully this will belong to someone. 682, last three is 246, 246. It's yours.
And yeah, and Sharon apparently won that, and she's one of our volunteers today, and decided she just had to have that photo. So that was great. Congratulations, and you're free. Okay, so that is the last raffle for this, but the big ones are coming up after this next presentation. Jamie and I are going to be talking to you guys for a little bit about the movie Supercell. And so we're going to get ourselves into place, so just hold tight. We're running a little bit long in this one, so we're going to go ahead and just get in place and get ready and go forward so we can get done before 5 o'clock, which is our goal. So anyway, just hold on just a minute.
I just first want to say and take a moment to give a little bit of an applause to Kim George, because I've been to 3 of these things and she does a wonderful job. So thank you for putting on a great TESSA conference yet again.
You're welcome. I really appreciate that. But anyway, I'm one of those ones that, I'm humble. I'm sorry. Anyway, so to get started a little bit with this talk, for those of you who here in the audience has seen Supercell? Good, awesome. There is a thing called, what is it? That place, Rotten Tomatoes?
Oh, she's trying to garner me some positive reviews. If you want, you can go to Rotten Tomatoes and leave a review. I suggest if you do it, please leave a 5-star review. And if you don't like the film, please don't go to Rotten Tomatoes.
He would just like to get some more reviews on there if possible, but I thought I'd just plug that for him because he has been so gracious in helping us with, being a part of this wonderful journey. But some of y'all don't know the behind-the-scenes journey that Jamie and I have had, and we actually started this journey back in 2019, and I pulled this up, and these are not notes. I just wanted to share with you the first email that I ever got from Jamie. It was May 13, 2019, and it just came to me. It says, "Hello. Todd Thorne referred me. I was curious if you guys did any onboarding meetings on non-chase days and charged a daily or hourly rate for that." That was the first email I got from Jamie, and so
I don't even know if that makes sense.
I know, I didn't, and I responded to him, and I said, "What the heck, no." I basically responded to him and said to him that I just left you a voice message, call me back when you can, and I gave him the link to our Tornado Alley Forecast Center for him to review and to look at, and just saying that it gives you valuable information, look it over. I know that we are looking to chase this Friday, Saturday, and Monday and Tuesday. This was with Martin, and I will be glad to give you some insights. No cost to help you along your way. Just call me when you have a minute. Well, he did. And so then the journey began, because he always would call me, and usually almost always I was out chasing with Martin. And so I turned him over to my husband, Steve, who y'all have heard so much about. And so I said, I can't deal with you because I'm going to be out chasing. And so he got a hold of Steve, and then the journey began. And it was a long journey from start to finish, and I'll let you go into a little more detail on that.
Yeah, it's been 5 years now. I'm curious if the first video actually is the start of everything. I don't know if they have the presentation up yet, but we can wait for it. No, there it is. Beautiful. So the next, if you go next and play the video, this was the beginning of everything. I think it was the one before that one, yeah. Oh, there's no video, okay. Well, you can reenact it, but what's happening is I'm with my fiance, and Kim was nice enough to give me her husband's contact, and I landed in DFW. I've never chased before, so I showed up at his office, and for about 90 minutes, he taught me pretty much the basics of forecasting. He told me to download a little app called Radar Scope, check out the College of DuPage site and satellite for the satellite to showcase, I guess, when the cumies pop, right? But what precedes that is what I learned to be the HER, which is the models that show you within 24 hours, what occurs. And I remember in that office, he was so enthusiastic and I just so passionate about storm chasing, and it was infectious. And he told me in that meeting, and he showed me this little red dot. It wasn't like a big day, but there was like a little red dot that I think was around 4-ish p.m., and it was right around Ozona, Texas, which might have been, I guess from Fort Worth, what is that, 4 hours, 4.5 hours away? And he said, just be here tomorrow at about 4 o'clock. And I went to bed that night, and I said, there's no way that these models can predict this. There's no way that you're telling me I'm going to show up to this little town, and there's going to be a supercell. And the next day, you know, we wake up late. I'm not a storm chaser at this point. I'm just, you know, I have a breakfast, and with my fiance, we're sightseeing around Fort Worth. We take our time, driving calmly toward that area. And sure enough, I think it's, I don't know, 3:30, and I think we're in San Angelo. And Steve calls me and he says, "Are you there?" I said, "No, why?" He's like, it's already gone off. And I was confused. I said, "What are you talking about?" He says, "Yeah, it's happening, and you're missing it." So I start accelerating, and we start driving through the Cap Rock, and I think at the time I didn't know this, but the anvil was so massive, it blew up, and it was really overcast. You couldn't really see anything. But as we drove through the Cap Rock and the canyons, and it cleared, and we got into that area, which is, I'm going to pronounce this wrong, Iran, Texas, I believe, Iran, and we saw the vista. It was an atomic bomb. And this was in 2019. I know a lot of you were on that storm. I think it was called the Fort Stockton storm at the time. I know there's been a recent Fort Stockton storm that was also very photogenic. But that was it. I saw that, and I was hooked at that moment. I remember after that storm, we went to a restaurant, which was the only restaurant open in town, and all I saw were people with laptops open, wearing T-shirts just like what you're wearing, and I said, "This is unbelievable. I feel so comfortable. I feel safe. I'm in the middle of nowhere at 10 p.m. in a restaurant I've never been to before, and I just feel like I'm around friends." And at that moment, I realized that there was something very special about this community. And it was soon after that first experience that I realized at the time, now we're going to get not a sequel, but the second coming of Twister. But at the time, there was no Twisters. It was just the 1996 movie. And as a filmmaker, somebody who, you know, grew up wanting to make a movie my whole life, I realized that this was what I needed to do. I wanted to make another film about storm chasing that hasn't been done since 1996. And that's when I went off, and my writing partner and I, we spent quite a amount of time. The first draft took about 9 days. We did about a 9-day just purge. I told her pretty much everything I learned from the community and my experiences. And we got the first draft out, and over the next year, we just continued to work on it and work on it. And then if you play hopefully the next slide has a video, because the next slide, I brought the script back to Arlington to the George's estate, and we read lines together. So let's see if this one plays. Okay.
On the whole thing?
Okay, so are none of the media linked then to it's just photos then? Okay. Well, this is okay. So I'm just gonna, I guess, describe what happened. Actually, Steve, do you want to recite what you did on that couch? I'm joking. So yeah, so I had Steve recite a lot of the lines that ended up becoming Roy Cameron, the character, because, you know, Roy was partially influenced by that man. And you can go to the next slide. You know, making a film is, you know, it's a lot of work. And all these little squares on the walls of my apartment are shots. And what you do is when you write the script, it's in written words. But as a director, your job is to visualize it. So, you know, I think I spent, I don't know, 6 to 8 months, and I went through every scene, and I basically envisioned every single shot that I wanted in the film. And each board, it depended if it was one board or 2 or 3, but those represented different scenes in the film. The unfortunate truth about filmmaking is when you show up to actually film, you don't have either enough money or enough time to do what it is you think you're going to do. So, for instance, if I had, I don't know, 15 to 20 little squares that I wanted to do for a particular scene, I was told that I had time to do 4 of them. And in about 15 minutes, I had to make a decision which 4 could tell the story of that scene. And sometimes none of them worked because the location I ended up at was not what I had thought I was going to, it wasn't the same location that I envisioned. So it's a task that's quite difficult, and what my job was to be comfortable being uncomfortable. And that was one of the biggest lessons that I learned on the film.
Well, and what is also really cool that y'all do not know is the fact that Jamie kept sending us his script. And we were also doing like technical stuff, saying, yeah, a chaser would say that, a chaser would not say that, oh, don't do that. And, you know, he really tried to make it as close to what our lifestyle is all about, you know, when we're on the road and stuff like that. He was very meticulous in that. And I really appreciated that. So he bounced things off of us, characters, people that he wanted to star in the movie and things like that. He talked to us, does this look like a good character to play this one and so forth. And so he gave us a lot of input, technical, but also just artistic-wise. And I think that helped because we were just trying to stay as close to the chasing community as we could to make it as real, which the first Twister movie is not really very real of what we as chasers do. So I think he was very careful on that, and I hope you like that. And I think the one thing that he really was concerned about, if you know the movie very well, is the scene where they go into the swimming pool. And that scene, he really had this battle over, is that going to be good? Is that going to be realistic? I said, man, that's going to be the killer scene, you know. And I said, if you can actually do it and pull it off with your budget. So he just went forward with it.
Well, you know, there was a time when I was writing the screenplay, and I was thinking, if there was no realistic shelter and you were within, I don't know how much distance of a wedge storm or any tornado of substance, where could you seek shelter? Would a pool be a viable option? And I did a lot of research, and no, a pool's not a viable option. Because you know, I would look up photographs online, and I saw the remnants of what happens to a pool when a storm or a funnel, and you have a lot of debris that piles into the pool. And of course, if you're in the pool, you're going to be with a lot of debris. But there was a lot of, I guess you would call, suspension of disbelief. And at the end of the day, it's a film. It's meant to be entertaining and enjoyed. So if you go to the next slide. Oh, we're here. Okay, sorry. So the other big thing about TESSA and the Georges and Tempest tours was I was fascinated with the idea that people paid money to travel all over the world to come and basically get jeeped around like Jurassic Park to see these massive dinosaurs in the sky. And I thought that would be a fun element of the film, is to create a storm chasing brand. And, you know, I thought, I love the name Brody. You know, if you guys have seen Jaws, that's the big Easter egg there, Chief Brody. And if you go to the next slide, I was drawing a lot of inspiration from what's out there right now. Like what type of imagery, what type of colors, what is it that, you know, you guys are used to that represent a great logo or emblem in the chase world? So if you go to the next slide, you can start seeing the development from, you know, what it is that I saw in the real world. And if you go next, I worked with a really fantastic production designer trying to come up with a good logo for this fictitious brand. And if you move next, you'll start seeing that I like the color orange because it popped. You know, it represented caution or safety. You know, it was important to have a silhouette of a tornado. And it was just something that kind of came together. And then to see it in fruition, and you go next, to the next slide, to be able to actually put it on a vehicle, it was a dream come true to see something that, you know, was inspiration from right out there outside this room and be able to put it on a big screen. So I was very fortunate to have the opportunity to do this. So if you go next. So yes, the pool. the whole thing, and that I realized that was a lot more difficult, especially given our budget, was how to take what you guys experience in the real world and put it into, basically the narrative and recreate it. And of course, putting an entire van into a pool is, I guess there was a lot of liabilities with that, and I guess the school that we were at didn't want an entire van in the pool, so we had to think outside the box, so we cut a van in half and we put it on a condor. Spoiler alert for anyone who hasn't seen the film. But if you go next, it was always trying to, create chaos around the camera and take all the experiences I had chasing over the last 5 years and be able to recreate it. And that's where we had to rely on things like these big Ritter fans that blow, I think, about 50 to 60 mile per hour wind gusts. Had a lot of special effects people go into hay bales and pick up debris and just create as much of the real world elements. Because if you go next, you'll see, unfortunately, I would love to play these videos. I guess the videos didn't link, but this was just an example of another day on set where we had rainmakers and we had fans going and we had a lot of strobe lights to represent lightning and all the effort that went into recreating something that we get to witness during storm season that we're so lucky to witness. That's just beautiful and breathtaking and also extremely dangerous, of course. If you go next. Well, we can move on because these you have to kind of watch. So the popcorn moment in the film is one of the only CGI shots in the whole movie. We didn't have the budget to afford what you would get in what you saw during Super Bowl weekend, which Twisters had plenty of, which is an unbelievable CGI budget. So what we had to do was think outside the box, and if you go to the next slide, we had to figure out ways to do things practically, which means do them in the real world with real elements. So that's me holding a bag of chips, which I dropped on top of a fan, and it somewhat successfully but unsuccessfully worked. So that's why we realized very quickly we needed, there was no way to get the popcorn to kind of flow up into the clouds. So I was very fortunate to get that one shot. But if you go to the next slide, the idea was how to make it without CGI. None of these have video, right? Oh, this is too bad. So this was another scene. I'm sure all you guys know Val and Amy Castor. From Oklahoma. They were our liaisons out in the field. They helped curate the chase experience, keeping us safe. And this was it's very comedic because what's happening is my cinematographer from the film is rigging a pretty big movie camera, a red camera, to the front of their truck. And on the right side of the frame, which you can't see, is a developing tornado. And we're not rolling. And I'm very stressed out because the sole purpose of this specific second unit was to get real-life imagery of the storms, but the storms don't know that you're setting up a very big camera. They're just going to do what they're going to do on their own time, and if you miss it, you miss it. So what I learned quickly was it was difficult to try and capture these elements. So if you go to the next slide, I'm sure this has happened to everybody at least once. Martin, has this happened to Tempest Tours?
Yes.
Okay.
Yeah, when they get stuck in a thing, it's like, okay, we need to move to stay on the storm, and they're out of there and they're pushing that van, so we get out of those pretty quick.
I think what we ended up doing here was Val was able to hook up his truck to our van and then eventually get us out, but we did not move that van an inch with the two of us that were pushing it. We can go to the next slide. Yeah, so then I came back to Los Angeles, and then I thought, okay, maybe I can miniaturize the effects of tornadoes by kicking dust around, backlit, with minimal fans, and This did provide some great elements for VFX. So what we could do is we could separate the dust. If you see that big black tarp, what that does is it allows VFX to separate what you would call like the dust clouds there, and then they could superimpose that over footage that has no dust. And if the movement's right, it does look, depending on the scale, like that could be, you know, mile-tall inflow of dust being seen from miles away. So that did prove to be impactful for the film, but it still wasn't enough to get the effects and make the film as realistic as I think a lot of people believe it to be. So then I needed help, which is the next slide. And who did I turn to? I think we all know who this gentleman is. So Pecos Hank, I reached out to him, and we had a lot of conversations together. And I'm just curious, how many of you here were at the summit? Okay, so you guys know the backstory. We kind of discussed kind of how we work together. So if you move on to the next slide. What we ended up doing was Hank had an unbelievable library of footage, and we worked together for months, and we had about 400 shots in the movie. And it wasn't just the tornado scenes in the film. It could be as small as just the characters just in the fields, or they're parking the car in the parking lot. To me, I wanted we didn't film this. We filmed the exteriors in Montana, but most of the time, we weren't allowed filming during hazardous weather. In fact, if there was high winds or any type of lightning activity, they shut us down.
Which makes no sense since it's a weather movie, but.
That is true. And the first day on set, we were shut down because the winds exceeded, I think, 50 mile per hour, and we lost a half a day. So to me, it was important that every scene in the film, it felt like this was during the peak season of storm chasing, and that whether it was a cummy field developing during the early hours of a day, or whether it was an anvil top that was coming over top, and if you saw the supercell behind the characters from one side, that if you reverse the camera, you would see the same anvil top developing behind them. So I just was important to me to make this as truthful as possible. So if you go to the next slide, you guys know what storm this is. It's Chapman, I believe. And the key was finding the right tornado to use as a good backplate for what ended up being the climax of the film. And what I liked about the Chapman tornado was that it was a dark storm that had, brightness, and that showed the edges of the width of it pretty clearly. And there was a lot of unbelievable movement that was happening with the rain that was wrapping around it. So we decided to, and the other big thing too was, this was one of Hank's only shots where he didn't have windshield wipers going through the frame. The thing is, as I'm sure, it's usually raining when you guys are in close proximity to tornadoes. And of course, there's, you have your windshield wipers going through. For someone like me who needs a clean plate, that's a problem. Because then you're having this big black thing swiping every so often. And I guess for this moment, we were lucky to not have that. So we were kind of between a rock and a hard place in most cases, because there were tons of beautiful photogenic tornadoes that Hank had shot, but there was always something where the camera was moving, or there was windshield wipers going through the frame, because what VFX needs is a tripoded shot that has no movement, so that they can basically rotoscope and cut the tornado out every single frame, so that they could place it in the shot that you've shot with the actors, in which there's a blue sky and there's no activity. If you go next, yeah, we'll move past this. Unfortunately, I can't show the videos, but there was a lot of inspiration, as I said, and it all started with the Georges. So I think some of you obviously have seen this inspiration slides from Summit, but we'll go through it again for those who haven't. So the next slide, who's this gentleman here, the cash register? Do you recognize him? All right, let's see who this gentleman was. Yes, it was inspired by Skip. Let's see who's next. Who's this guy? Do you have any idea, Kim, who this person is?
Not at all.
All right, let's see if we can figure this one out. Oh, there they are.
Yeah, that's my husband without a beard.
Look at that. Do we prefer Steve with or without the beard? All right, we can move on next. Okay. Do you guys remember who this duo pair was? Yeah, someone said Brett. That's correct. Go next. Yeah, that was, of course, I think Brett and Brandon, if I'm not mistaken, during, was that El Reno? Yeah. All right, next slide. Well, this was also, I think I gave this away, so you can go to the next slide. Yes, so Steve George had such an influence on me. He had such enthusiasm, and he was so, you could just sense his heart when it came to storm chasing that I couldn't help but, that had major influence over the Roy Cameron character who became William's surrogate father in the film. Because in a way, I think, Steve, you were somewhat of a surrogate father to me in storm chasing. Is that weird? Okay, maybe it's a little weird.
No, that's not weird. That's not weird.
All right, we can move on okay, this one's a fun one. Does everyone know who this guy is? Okay. So who could possibly have been influenced this character? Let's see. This is like a little bit of a mixed thing. Yeah. Of course, Reed Timmer and Roger Hill. Which is interesting because I give it away in the name. I think his name is Zane Rogers. So I try to do a little bit of a little hint there. And then let's go next here. So this, you can't really tell. It's a little bit phased out, but that's the Bill Brody character. I'm sure everybody know who influenced Bill Brody's character. Anyone? Tim Samaras. Let's go next. Yes, Tim. So in preparation for the movie, I couldn't help but read The Man Who Caught the Storm by Brantley Hargrove, and at the time, I was going through a lot of grief because I had lost my mom to Alzheimer's, and to me, losing my parent, it generated a lot of. It was a good outlet for me in terms of figuring out the characters, and I couldn't help but when I was reading the story of Tim, it was less about the day that he passed in El Reno, and it was more about kind of the man that preceded that event and that everything that came to be before that. So to me, that was really important to honor him and, of course, Carl and Paul. And it kind of jump-started the heart of the whole story for me.
And the book that you read just like marked it up continuously. What book was that?
Sorry?
The book that...
Yeah, no, so A Man Who Caught the Storm was a big inspiration, and I just thought that I wanted to understand kind of not just the present day chasing, because, I'd experienced it with all y'all for the last at the time it was only a couple years, but it was a good insight into the history, because the history is very important, and that was really influential for me.
Yeah, and you marked it all up, and you were just telling me just a little bit ago, it says that you ended up giving that book to somebody.
So when I was working on the film, I had given the book to Anne Heche, who was also unbelievable to work with. She plays the mom, Quinn, in the film. And we had a very special relationship, and she just was fascinated by the storm chasing world, and I wanted to share the book with her because I thought it would be a fun read for her. She was a voracious reader. She got really intimate with all the characters that she created, not just with this film, but many others that you've seen in the past. and unfortunately we lost her a couple summers ago. So you know, that book is probably with her or her estate, but it was a nice thing just to have that experience, obviously, with Anne on set before she passed.
Yeah, and you were telling me that one time when y'all had your cast party and you did all that, just her reaction to when she actually got to see the film because she passed away before it was released.
No,
So, no.
what happened was, so we were editing the movie, and I kept in touch with Anne, and she had her son there, Atlas, who I think at the time 13 years old, and I went over to her condo, and we only had the first 8 minutes of the film, which is the prologue. It's the beginning to where the title ends. The title is, and I remember screening the film for her and her son, and they were just so giddy and excited. You know, I could see through her son's eyes, which, you know, this film is, it's really for families and for kids to inspire them to want to do what these people do. And I was just so fortunate to at least show her 8 minutes of the movie because she ended up passing away a couple weeks later. So it was heartbreaking that she never ended up seeing the movie. But to have that moment with her is something that I'll definitely cherish.
Yeah, it was a real cool moment, I know, for them to be able to experience that. So the only other thing I was going to mention from Supercell, did you have some more?
Yeah, well, if you go past the next slide, so everyone, yeah, if you guys know David Hoadley, he was fantastic. I remember speaking with him. I contacted him. I said it was very important for me to use his work. His artwork is so influential. I definitely wanted to have his stamp on the film, so he was kind enough to donate all his artwork to the film.
So who's that cute girl in the sunglasses?
Oh yeah, this is another. Is this David Hoadley's work? I assume it is.
Yeah,
And
that's me.
Did you guys commission this?
Yeah, and who's that person that's on the right?
Is that Martin?
Yeah. So all of these people are people. Bill Reed is the one on the left, and I'm trying to think who is the one that's right by you, Martin. Chris Gullickson, and that's Bob Consemius, Dr. Bob, and yeah, Chuck Doswell's in, I think with the hat, isn't he with the hat at the back? Anyway, that was like people from our staff that David drew for one of our tours. So it was our 20th anniversary for Tempest. So it was a really cool deal. I've never been immortalized by a thing. So that was fun.
No, David was great. I just remember he said, I said, how much do you want us to license your material for? And he said, no need. He said, just pay for the postage to send the materials to, I think we were filming in Montana. So we paid him the postage, which I think it was like $2.90. But I'm so happy to have his work in the film because it adds a lot.
Yeah, it really does. David's just amazing. He does a lot of the Tempest shirts and has for years, and they're always very individual and just great, and we just love him.
And I think, if you go to the next slide, okay, so that's pretty much it.
Yeah, that's it for that. And then just the other thing I was going to mention real quick is that when Martin asks my husband to be in the movie, of course they were filming in May, and I'm like, I can't come in May. It's chase season. What are you talking about? And so we finally figured it out, and we got it done. And he was asking me, he goes, Kim, you need to be in the movie. I said, I don't have time. I'm chasing. I got things to do. So we get there, and we are sitting around after we get there, and we're at the hotel, and Daniel Deemer comes over and sits next to me, and Jamie's introducing us, and Daniel just looks at us, and he goes, y'all are the real thing. And I was like, yeah, and so he sat down and he talked to me for about 20 minutes, and we had a really good conversation. But it was
Just
a really cool
if you
deal.
don't know, Daniel plays William the boy. He's the
plays
star of the
William.
film.
And he is tall. He's like what, 6'5"?
He's 6'5".
Yeah,
He's a big boy.
He's a tall guy, and so we had a really nice time. But then Jamie kept saying, "You just need to be in the film," and I said, "Well, I could be an extra. And he goes, yeah. And so, I mean, I happened to have a storm chasing shirt with me. And so I went and filmed with my husband the next day, and I was in the movie. Big surprise for me. And if you look for me, I'm running behind him in the restaurant when we were all leaving as chasers. So that's where you see me.
Just another fun story about Daniel. So when we were auditioning for the main character, because we knew at that time we had Alec Baldwin for Zane and Skeet for Roy and Anne for Quinn, we didn't cast the kids. You have William's character and then his love interest, who's Harper. I knew I wanted Jordan for Harper. Her name's Jordan Simone. She's a fantastic actress. She's in the HBO series We Are Who We Are, which came out quite a few years ago. But I didn't know who was going to play William, and originally I wrote William to be kind of a squirrely, kind of smaller build character, because, you know, I was a late bloomer in high school, and I wrote myself as the main character. You write what you know.
So you were Daniel.
I was basically Daniel, but I was tiny. I was like 5'7", 5'8" through those years. Actually, I was probably shorter than that. I was probably 5'5". I hit, I think in college, a little spurt. But I'm looking through audition tapes, and Daniel's comes up, because at the time it's COVID, and we didn't have a proper casting session, so everyone did video submissions. So I'm watching a lot of tapes, and not so good, and then Daniel's comes up, and it's just unbelievable. I mean, he's just incredible, and he's wearing the red sweater, which reminded me of E.T., and that's another little Easter egg. There's a lot of Spielberg influence, as you know, with this movie. But I was so excited. I saw his tape, and I said, that's William, that's the character. And then at the end of your audition tape, as an actor, what you do is you slate. And what slate means is you say your name, and then you say your height. Because height's very important in filmmaking, because the frame is your frame. You need to know kind of how tall your characters are, because if you have someone who's extremely tall and someone who's very short, if it doesn't play into the story, it's just very hard to work around. So I remember he said, "Hi, my name is Daniel Deemer, and I'm 6'5". And I was like, okay, this is a problem. One, you're a high schooler, because that's the age of the character. He's like 16. But I thought he was so tremendous, and I said, we'll make it work. And I was able to write some little things in the script. For example, halfway through the film, he shoves Roy at the gas station and shoves him on his butt. And I thought that was fun. And then there was a couple lines about him eating too much. But sometimes you just got to play and work and change things. The thing is, it's an art of change. And that's the thing about filmmaking, I'll say, is you prepare yourself, you kind of see the whole thing, you do your best in preparation, but you have to be prepared to just on a whim change, because anything can happen. You can get shut down, you can have 30 minutes to shoot something that you thought you had 3 hours to film. You may get a different cast, another actor that you didn't anticipate that has a foot on the original idea you had of the character. So it's just a constant art of dealing with change. And I think if there's one lesson I can give to any budding filmmakers, again, is just being comfortable with being uncomfortable.
That's a good statement. So let's talk a little bit about what you've been doing since then and what you have planned to do in the upcoming, what you can tell us.
Yeah, so I'm actually delivering my next film as a documentary. And believe it or not, it's about seashells. How many of you guys and girls, how many of you guys love seashells? Did anybody here collect seashells? Okay. It's something that I guess I'm addicted to the wonders of nature.
But what inspired you to do that? What weather event? Didn't you have?
Oh, no, it's the other way around.
Oh,
so
okay.
I visited Florida quite frequently as a child. One, that's what got my addiction to lightning, because Florida is the lightning capital of the world, I believe. Actually, that's not true. I think the Venezuela, the Maracaibo area is. But so Florida had two things that I picked up as a child: seashells and lightning. So my next voyage, I guess, into filmmaking was seashells, and I started writing a supernatural thriller about seashells. So as I was preparing that, I started doing research and meeting all these eccentric seashell collectors in Sanibel, Florida, because Sanibel is the mecca for seashells in the world. And 6 weeks after I filmed the island, Hurricane Ian wiped it off the map. And I remember when it was developing over the straits around Cuba and then the Keys, and I just knew, because I've been tracking hurricanes a long time. I've been going to Florida since I was a kid. And I just know in the Gulf, these hurricanes, they always turn right. And the initial forecast had it toward Tampa or north, but at some point it ripped to the right, and it had a bullseye right on Sanibel, and my heart just dropped, and I realized, you know, they don't stand a chance, because Barrier Islands, they just get, I mean, it's a tsunami. The storm surge, 15, 20 feet, Fort Myers Beach. And then as I'm watching landfall, I couldn't help but think to myself, I was just there. I have all this footage. Of course, it's about seashells, but I got to continue this story. The story's changed. So I went back 2 weeks later, and a lot of the subjects that I filmed, they were obviously displaced, but they got hurricane badges so that they can go back on the island once the causeway was temporarily rebuilt. So I was one of the first people to get back on the island with a camera, and I filmed kind of the whole process through the eyes of the characters that I met, their experience seeing the devastation of Sanibel and the process of rebuilding over the last year. And it was a very powerful story. It's funny because seashells, in a way, there's a big metaphor for me. I feel like seashells and people are very similar. We're both resilient creatures. And I think that's kind of the main theme of the film, and I'm very excited to have that come out, hopefully at some point this year. It's called Sanibel. Yeah.
Is there one other thing you might be working on?
Yeah, there is some other thing. I can't say too much about it, but there is a documentary series on storm chasing that I've been working on with some producers, and we have some pretty big meetings coming up over the next couple weeks, so I'm going to keep my fingers crossed. I can't say too much about that, but if you guys were at the summit, you saw I had my camera out, and I was chasing last May with both Reed and Hank and a bunch of others. And the thing that I noticed is, of course, Supercell was more of a it was more for entertainment purposes. It was a throwback to the 80s. I enjoyed it in its own way, separate from what I see in terms of what this series is, which is a lot more about the psychology, the history, and the passion of why you guys do what you do and how important it is in terms of first responding and safety and generating warnings for people out here.
Yeah, I think it's going to be fantastic. Like I said, he can't say a whole lot, but I wanted you to know that he's not just leaving Supercell and then going on to new horizons. He is actually kind of staying in the community as far as like doing other things, and because I think he has a real commitment to the chasing community and what we're all about. So I think it's going to be fantastic. Y'all have to really see it when it comes out.
Yes, I think everyone can agree, when you get caught, when you get bitten by that bug, I will forever chase. I just can't help but want to chase, and it's something, people say moth to a light. It's, when you see something like that, the skyscapes and the colors and the power, and it's unbelievable. And I won't, whether or not it has to do with a project, if it's, trust me, I just want to go chase for the fun of it. I'm tired of just carrying a camera around and working. I really do want to just be there out in the field and just enjoy it in the moment.
Yeah, it seems like it never fails when Martin and I are chasing, or even when I'm with the group, I'll get this, my phone will ring, and it's Jamie. And he's like, "Are you out chasing? What are you doing? Where are you?" You know, and he just, because he's in California, so he's like going, I just want to be kind of, like on the sidelines.
We do digital chasing, right? So I think 2 years ago, there was a pretty big severe weather event happening during TESSA, and I remember all the speakers and Steve and Roger, we were all watching the college, well, we're watching the radar scope, and we were watching the satellite imagery, and that's what I do in Los Angeles most time. Is I'll be tracking weather from Santa Monica, which is kind of interesting.
Yeah, it's just, I always say it's Jamie. So I'm going to go ahead and open it for any questions, and we'll get those, and then we'll finish up with the raffle prizes. Anybody have any questions for Jamie? Questions? No? Really? Okay. That's great. Okay, so do you have the other buckets, Miss Laney? We're going to let Jamie draw these prizes for the big ones and for the ones for his posters. So the first one we're going to draw is for the Mobile Threat Net Unit, which is one of the largest ones for, so, I know. So he's going to, you shake it. Okay. The Mobile Threat Net, we're going to do that one first. It's a year subscription. It's worth $1,200. So everybody have their tickets out because we're going to finish up with that.
682328. Yeah, right here.
Oh my gosh, that's great. Thank you. Okay, well, hold on to that ticket. Lane's got that. We will need you to give her, of these, we're going to need you to give them your name and phone number and email for the people that you're winning it from. So we'll need that. Okay, so the next one is the RAOB. You don't look at it. And this one is worth $1,300.
Oh, wow. We gotta get this right. 681778. 681778.
Anybody have that one? Anybody have that one? Go twice. 778 at the end. Is that person come in?
Okay.
Okay. Try another one. Mm-hmm.
681773. 681773.
Oh.
Hey!
Yay! Okay. There you go. There's the lucky winner. Okay, those are the two really big ones. And then we have, we're going to do the Supercell poster, the first one. What? And you're going to get to take a picture with Jamie with the poster that we're going to post on social media.
Yeah, 682256. Hey!
Yay! Okay, so give it to Lainey. And this is poster number 2.
Okay.
Okay.
This is the second poster.
Okay.
682227. Hey!
Yay! Congratulations. Okay, and then the last one is Jamie brought up with him the DVD for Supercell. It's a Blu-ray. Yes. It's a Blu-ray, and he just brought that up, so he wanted to go ahead and put that in the raffle, so we did. So the last one.
681814. There you go.
Yay!
Right.
Congratulations. Okay. Okay, that is
Wait,
all.
I think there's something else.
No, that's all the prizes.
No, there's something else. Wait, what's happening? What's happening? Look to your right. Uh-oh, what's happening here?
Oh my God.
Thank you, Jamie. Okay, so this here is Kim George. And she, how many? 4, 5?
Well, we had a TESSA the year after 2013, even though we had a TESSA 2013, but I wasn't with you guys yet. And because of the thing that happened in Oklahoma, we had one 2014. So it kind of reset. So 2014, 2016, 2018, 2024. Six? Six?
So this lady here has put on 6 conferences in a row. She's now retiring along with Roger. So Roger and Kim are retiring together. And so I guess I'm probably going to give the job to Steve.
No.
So the next conference is going to be very unusual and fun. Probably a little out of hand. So, but really, Kim has really worked hard and very meticulous on putting it together and very careful and creative on putting these together. So I just want to say thanks to Kim for her hard work and good luck on your future endeavors.
Thank you, guys. I really appreciate it. I'm staying with Martin through 2025. So I will be there for the next 2 tour seasons, but I will not be here. I will not be there 2026 for the next TESSA. So I still will be around a while. I'm planning on going to the Chaser Summit next year. So y'all will still see me, and if you see me out chasing, be sure and say hi to me. But thank you guys so much for coming today. I hope you enjoyed the event. And if there's anything else that we can do for you in the meantime, we're going to hopefully have these videos up on YouTube for each individual speaker so that people can go and see them later, especially the presentations that you want to see. But thank you so much, and have a wonderful rest of your night.
Thank you.